Hello, everyone. Good morning. This is Hiroshi Emoto. I'm working for the NICT International Affairs and also working for ASEAN IVO Secretary. Thank you very much for your joining this forum, ASEAN IVO Forum 2021. First of all, I would like to invite NICT President, Professor TOKUDA Hideyuki, for giving us the opening address. Professor Tokuda, please.
Hello. Good morning. I hope you can hear me, right?
Yes.
Okay. Good morning, everyone. I'm Hideyuki Tokuda, President of NICT. We are very pleased to hold the ASEAN IVO Forum 2021 in online format despite COVID-19 situation in Asia. And thank you for participating in the forum. I hope we will be able to cope with COVID-19 and we'll have an opportunity to meet each other in person next year's forum. Let me begin by thanking the steering committee for their cooperation in holding this forum. Particularly, I would like to thank the chair of each session, Dr. Haj Abdul Ghani bin Hamnaim of Bernays UBD, Mrs. Roinda Diaz Toti of Ignatius MCIT, Dr. Gwen Tan Choi of Vietnam's VNU, Dr. Risa Conson of Thailand NICT, Dr. Francois Chip of Singapore I2R, Dr. Sam Sasesri of Cambodia's NICT, and Professor Alejandro Barat of the Philippines MU. At the present, the world is facing a mountain of issues from global warming to pollution, natural disasters, food shortages, and the global spread of COVID-19. It is a mission of us, ICT researchers, to find solutions using ICT with consideration to the SDGs. This is not an age where these large or global issues can be solved by the effort of just one country. Many countries cooperating to seek out the solution is essential. Thus, the organizations advancing R&D projects that span many countries like ASEAN IVO are of the utmost importance. This year, too, we open up calls for presentation in food, environment protection and disaster prevention, secure and smart communities, health and welfare, and so on. We received 26 submissions. I would like for you all to listen to these 26 R&D presentations and find within them inspiration for your own research. Furthermore, I hope you find the connections with your research and develop technologies usable in the real world. The call for new project begins today, so I hope today's presentation and debate will influence the submissions. Finally, through this forum, I hope all of you enjoy today and that you will find this forum a very fruitful event. This is all from me for now. Thank you very much.
Thank you very much, Professor Tokuda, and for you giving us the opening address. Thank you very much.
Thank you.
So next, we will moving to the group photo. Please turn on your camera. Next, we will moving to the first session. So for the session 1, for ICT and food, and the chair will be Dr. Hadi Abdu from UBD. Can you hear me?
Yes, I can hear you. Good morning, ladies and gentlemen. Thank you for this opportunity to have this sharing this session. Our first session is on ICT for food. Yes, so this session, I would like to have another photo session first before the start of every session. So please, can you turn on your camera again? Thank you. As a reminder, each presentation is for 10 minutes, and there will be a 5-minute question and answer session. After the session, if you have any questions, then you can use the raise your hand function in Webex. Thank you. Now, to begin the session, may I invite our first speaker, Dr. Trong Minh Hoang from Post and Telecommunication Institute of Technology, Vietnam, with the title of presentation, Agricultural IoT Based on Edge Computing. Please.
Excuse me, can you see my slide, my presentation?
Yes, we can see your slides.
Is that clear? Yes, sir. Yes, thank you, Chairman, very much. Welcome on this is my presentation. I am starting my first presentation in agriculture IoT based on edge computing. My name Hoang Trong Minh. I come from the PTIT Vietnam. So in our proposal, I would like to introduce some important point in today. In the first, I would like to show and some significance of the study is the motivation of the study. And the second, I try to figure out and sum and concrete the objective in our proposal. And the third, I want to talk about the overall of our proposal. And the last, I want to listen and some question, and I will answer the question. Wow. As the first, I would like to introduce in significance of the study. As you know, it's agriculture IoT system can bring so many benefits for the our life, the labor cost reduction, food security, high quality, high output, and local nutrition control. And I want to impress in some motivation in our proposal is just now we are to face as a COVID break situation. Just now we all want to move and automation as oriented. So and the second, I would like to introduce and some important from the edge computing or the multiple access edge computing can contribute the technology on the light. Our day, the light day. As you know, as the edge computing is the one of the 4 technology is contribute in the 5G technology. And the second is the can to bring and some performance by the improving the performance as a device, because the edge computing can bring the control close to the user. And it's the can make and some in quality of infrastructure and high performance is the network, because of in support in the service quality for the collected data stream. Edge computing can be integrated with the and some heuristic algorithm like the AI is making intelligent decision. And the lab is very important in our day. We can want to move enhance security, and edge computing can ensure data security and moving to work to digital twin. So from this situation, we are try to figure out and some concrete objective in our proposal. That's in the first, in the intelligent control aspect, we want to proposing intelligent computing solution as of network for data collection and local response control using state of as smart and edge computing. In the improved security area, we want to win an IoT device security framework based on authentication, data preservation, and encryption. And the last is in the enhanced performance of the agriculture IoT system. We want to propose modern solution, load distribution, and data processing in associated with the crop production and the farming practice. So just now I want to talk about in express in our mission in this proposal. As a first, we are know and situation agriculture system have been impacted by huge growth new emerging technology in 5G, AI, and automation. Right now, I need to say, and we are facing with effective local decision making, precision enhanced of operated agriculture IoT system. We want to incorporate automation actual into IoT system. It will become good for the new normal situation. Just now, we want to propose an intelligent model solution based on novel techniques for plant care and disease control. And the second, to moving on in the IoT security framework, as you know, we agriculture system are impacted by massive IoT device, operating system variation, and new chip and distribution control route. So we want to propose a security framework related to IDS based on AI, ML, DL approaches and D2D authentication schema. And the third is I want to enhance the performance of agriculture of IoT system. As you know, agriculture system have a practical even in extremely condition. We need to find and some actual agriculture system as it required to deal with big data processed by massive IoT system. My IoT device, I would face with the increased sensor traffic leading to large amount of computation. We want to propose a novel modern solution to offload task and pre-processing data. So come to this current system. In the Vietnam indoor, we have and some automatic watering system, and Malaysia is our collaboration. We have a fertilizer system based on IT system. In the framework, is the current system, the IoT can be to focus in and some control in the user resource status. Is the module 3. We want to implement in this IoT framework in the zero box. Is the edge computing here, and to effective with the product management and effective the security solution, and to touch on the control connection layer by and some smart intelligent control. So in overall, in the to working and to reaching our aim, I try to get the cooperation between and some country in Asia. For as you look in my picture in the intelligent control mission, we have and some experience from the NICT, from Japan, from Vietnam, from Malaysia, from Thailand, and the security we want to utilize is the previous cooperation between the Vietnam, Thailand, Japan in the security framework is come to in practice. As a performance area, we have a collaboration between the Vietnam, Malaysia, and last in the further practice, we have a testbed farm. We win parallel testbed from Vietnam and Malaysia. And this slide I want to show and some experience is the cooperation between Vietnam and Japan in the security on the data stream, and the Thailand we want to talk about and get some experience from the telecommunication network and the Malaysia. And this is the end of my presentation. In this last slide, I want to show you and some cooperation between the Vietnam, Malaysia, Thailand, and Japan, and some experts come from the university and is the farming, and the company is the farming. Okay, it's just so. Thank you very much.
Thank you for the presentation, Dr. Fong. May I invite the floor to ask for questions? Yes, Dr. Fong.
Can I ask question?
Yeah, please.
Please.
Okay. I mean, you have 3 different parts of your project, right?
Yep.
Security, control, and modeling.
Yep.
Okay. In the security and control, I think there are several other methodologies already, but in the performance, how long? Hello. How long is actually your project? How long is your project actually planned, Prof. Wang? Hello. Can you?
Sorry.
How long?
Can you repeat again? Yeah.
Yeah. My question is to the third part, the performance.
Yes.
How long is actually your project planned?
It's the performance of the agriculture IoT system.
No. I mean the project is planned for 2 years or 3 years or how long?
I'm very sorry. I try to fit in 2 years. 2 years.
Oh, 2 years.
Yeah.
Do you think modeling such a performance is enough in 2 years?
I think that's a good question because I have some previous cooperation. I think we can be to extend it to reach one.
Oh, okay. Okay, no other question.
Yeah.
Thank you very much, Prof. Wang.
Yeah, thank you. You're welcome.
Well, I have a question here. Can I ask? Can you hear me?
Yep.
Yes, please. Yes, please.
I have a question that
Yes.
you've done some work previously, right? I'm just wondering how much data that you already have from the existing outdoor and indoor so that you can actually build on it.
I'm very sorry. Excuse me. I can hear you clearly.
You said that this is going to be, you're going to use all the previous work that you have done and then build onto the existing, to the proposed project. How much data you actually collected in order for you to build the model?
Oh, I think the data is very important. That's why we are trying to cooperation between some as much as possible for the country in our project. This member in our project is I try to get it, but I want to expand it to get more data.
Okay. So the thing is, are you going to do an outdoor or indoor data collections for your proposed project? I mean, outdoor or indoor agriculture?
Just now we have some project parallel in the indoor project. That's okay. That's fine. But the main challenge that I want to expand it to the outdoor project, the outdoor scenario.
Okay.
The indoor, that's okay.
Okay,
Yes,
that's good.
we can get data from my partner, right?
Yeah, I mean, I understand that. It's outdoor usually a challenge.
Yeah.
No other questions.
Yes. Thank you very much. I think the big challenge.
Can I have a second question, please?
Yes, okay.
Okay, maybe. I have also some project regarding smart agriculture and so on, but
during the time 2020, 2021, I had the difficulty to go on because of the COVID-19 situation. And I knew that in Vietnam, at the beginning, it was okay, but recently it was not okay with the COVID-19. So how do you cope with this kind of problem? Are you still continuing your project, or did you hold your project a little bit?
Yeah, just now this is our member in my project is open now. That is just idea. I want to, if you had some experience, I want to invite you and the other people come into our project.
So your country is already open?
Yeah.
For visitors?
Some for some case. As my best I know.
Okay. Okay, thank you, Prof.
Yes, thank you very much indeed.
Are there any questions?
Yes, any question?
Hi, good morning. I have a question about security aspects. So could you please elaborate on what are the security threats that you envision in such agricultural IoT system? So what are the security threats that you are trying to protect against?
Excuse me. So my security, my security area is my main researcher. Yeah. But I can hear you to ask my question for me.
Oh, I was asking about what are the security threats? What are the threats in such a system?
Yeah.
What are you trying to protect against?
Yeah. I think following the computing manner, I try to make some framework is localized for the. That's only this my project. I focus about Isdbt. The intrusion defense system. That's the only.
Okay, I'm afraid we have to stop. I'm sorry, we have to stop.
Okay, can you give me a question
we have to go on
by email? I'm ready.
Presentation.
Yeah, thank you. You're welcome.
Now,
yeah, thank you very much.
Let's move on to our next speaker, Dr. Chai Lee Goy from Curtin University, Malaysia, with the title of presentation, Agribusiness Supply Chain Management System. Please, thank you. Now, can I remind everybody to switch off your cameras and microphones while the presenter is presenting? Thank you.
Can you all hear me?
Yes.
Okay. I'm going actually from Curtin University, Malaysia campus. Before that, good morning to all the participants. Actually, this I can say that just the preliminary stage compared to just now the first presenter. Actually, just now the first presenters, I think that he has done a lot of works already. For my actually proposal, I don't think this is called a complete proposal. This is just early stage of my ideas of my research works. So the topics of my ideas of research work is related to agribusiness supply chain management system. So I just explained it briefly today about my proposed ideas. The ideas come actually because this research is more to Malaysian context. Why actually I'm interested in this research? The first thing actually agriculture actually is one of the important sectors in Malaysia economics. From the slide there, you can see that in terms of percentage and also contribution actually in this case. But I'm also looking at, I found out actually one of the policy, this is national cooperative policy. Actually, the government has started cooperative movement as the fourth generator of economic growth. Like manufacturing. This government that agriculture to contribute 5% in 2013 and 10% by 2020. But however, I don't think that this target case. Based on my one of even one of the aggressively in these agriculture sectors. I realized the problem even just about the weaknesses of supply chain in this case. So to this actually have a lot of products here. The problem that based on my finding a lot of waste even in next. So there's something that it's not mean that we don't have resources. Actually, we have a lot of resources. But one of the problem here, based on my finding, actually is a lot of waste. And just now I mentioned that one of the reasons is due to supply chain. During the this pandemic, COVID-19 actually, COVID-19's pandemics. During because since 18th of March, when the government implemented this so-called lockdown, or here we call it as a movement control order, the situation even worse. Actually, we can see that. And when I refer to some newspapers reporting, or some newspapers actually discuss about this issue in this case. So there's something must be when we discuss about supply chain management, it should be lack of, for example, like some attribute there in this case. So this is concerned about what we call it as a sustainable agriculture in this case. So that's why my ideas, the objective of my research ideas actually is to recommend a systematic agribusiness supply chain management system. This is my main objective in this case. So to discuss actually about this, when I reviewed this Kurisky HD 2015 supply chain management system, he highlighted start from natural resources until reach to the final consumers actually. But I realized that a lot of the situation from based on the literature's review, a lot related to distribution side here from this side. So this is the things that this distribution either from the private sectors and even the government sectors. So this is a question that even we have government agencies, certain bodies actually still why this is the problem in this case. That's why this must be further analysis, further research need to be conducted in this area. So that's why my first idea is actually to discuss about this is more to should be a better system in this case. Either can be a system can be like 8 or something like that. Start from for example, like if I'm a consumer, for example, I want to have certain products, for example, what a fruit or vegetables, for example, like that. So how I deal with that, like this is a simple illustration from there. Like I use the system, I search for the before that consumer able to buy something, for sure that this is this supply from they go to the system, then it's good for the consumer to easily to go to the system, to the app, for example, to purchase this in this case. So in this case, I want to claim for a systematic like supply chain management system. But I realized that there are quite numbers of the system actually already there. For example, even we have in Malaysia context, we even have a very successful like a platform like online e-commerce like Shopee, Lazada, or something like that. We even have these e-delivery services. In this case, like GrabFood and GrabFood, Food Panda and the rest of this. But I'm starting to think that why not this thing also apply to agriculture in this case? Seems like everybody now, especially during the pandemics, then I realized that everybody, even now already government start to open the borders. I think in at the moment, even yesterday when I read the news said that the numbers of patients, for example, like COVID-19, like category 4 and 5 started to increase, maybe due to the government opened the borders and so on like that. Maybe I don't know that maybe that will be the second lockdown or something like that. Even in only because even in my state, like in Sarawak, even in Kelantan, actually we are still in the third stage. So in this case, this is a move forward to think about this system actually, so to solve this problem in this case. So to discuss about that, there's some benefit linked to the trend. For example, like more agility, more sustainability in terms of that. So we can use blockchain and so on like that. So based on data, for sure, this information go to for me, because I'm from marketing backgrounds. In the marketing background, in marketing research, one of the important element for us to continue our research to understand our consumer is data. So that's why in this case we can collect all this data from the system, and we try to understand this from a consumer side and also from the farmer side in this case. For sure, another thing that what I can see increase speed of this supply chain management system in this case. So that's why in general we can see that in terms of marketing, for sure that we can, just now I mentioned that in marketing for me actually, because supply chain discuss a lot in marketing, for sure that we can understand consumer as perspective, start from this need recognition until post even when they purchase, we still can study that based on a post-purchase evaluation from there. From there, we can not just we can collect data more about that. So for the conclusion, actually, for sure that is we can create a more effective system, especially not just the whole system of supply chain, but a communication system in this case. I think due to the time limits, I think I need to stop here. Thank you very much.
Thank you. I open the floor for questions. Please, Tony and Anwar.
Okay, sorry. I just got a call from secretary from my department. So, Professor.
I'm sorry. Could you turn on your camera?
Yeah, I can turn on my camera. Wait a minute. Yes. So, did you get my picture?
Yes.
Okay.
Yes.
Thank you, Prof. You're from Kuching in Malaysia, yeah?
Yes, Sarawak. Yes, in Sarawak.
Sarawak, yes. Okay, I just have one question actually. Since your idea was actually created during the MCO, and now Malaysia is opening, for example, 29th of November, can go to Singapore without any problem. I mean, the PCR is a must, of course. And then there is an agreement with Indonesia and other countries as well to do this vaccinated travel lane or something like that. So since your project was created during the MCO, now Malaysia is already opening. So how beneficial would this project be for the government of Malaysia at this time then? Can you inform us, please?
Okay, actually, we just already opened, I think, just around last month. I think for Sarawak context, actually, we are a bit strict in this case. So because we have, compared to the rest of the state, I think besides Sarawak, I think another state called Sabah, actually, we have autonomy in terms of immigration. So that's why even people from West Malaysia, when they come to Sarawak, they still, even to work, for example, to study, they need to apply. So that's why we are quite strict on that. So we just opened, I think recently, I think a few weeks ago, I think. So this system actually is not just about after MCO, for example, like that. But the ideas come to me, yes, after, during MCO, I can see that. But the keyword for me from my plan here is about management system, because it's what I mentioned just now, that we can see that a lot of ways in this case, this is related to improper management system in this case. For example, like in Sarawak itself, we have a huge, we are the largest state actually. We can see around that, for example, in terms of these agricultural products. For example, like recently, I give one examples, like in the rural area, for example, like fruits, for example. Like we have not fruit like very popular, like durians, rambutan, for example, like that. In some of the area, like rural area, this like this fruit like not fully harvested because it's too much ready, and in some of the rural area, this is maybe not really priceless for me in this case. So this must be, we need to do something that in terms of supply chain, so we can supply it to the rest of the area, rest of the state, maybe rest of the countries in this case. This is the ideas is that is yes, I'm agree that this ideas is when I sit down there during MCO, but the most important thing to solve the problem, especially related to the waste, a lot of wasted actually in this case, so that we have a proper this supply chain management system.
Okay, thank you, Prof. No other question from me. Thank you.
Okay, thank you very much.
We have another question from Solifan Kanita, please.
Okay, no question.
So Chai, do you have any collaborators for your project? That's the time that we have. Thank you, Dr. Chai.
Okay, thank you very much.
Questions we can direct to Dr.
Yes.
Chai. Thank you.
Thank you very much for the feedback.
Yeah. Thank you. For our next speaker, may I invite Dr. Puja Shivanan from University Brunei Darussalam with the title of presentation, Crop Disease Predictions and Computational Modeling. Please. Dr. Puja, can you unmute your microphone? Can't hear you.
Can you hear me?
Yes.
Yes.
All right. Sorry about the glitch. I'll make that quick. I hope you can see my slide.
Yes, please.
Yes, good morning. Sorry about the glitch. Good morning, everyone. Thank you for the opportunity. And I'm Pooja Shivanand, affiliated to Faculty of Science in University Brunei Darussalam. And project is CROP, which is Crop Research for Disease Onset and Prediction. And though I am the presenting author, we have collaborators from Brunei, Vietnam, Japan, India in this project. And today with me, I have Dr. Rao, Dr. Mei Khan, and Dr. Huang also in this session. And today I'll walk you through the objective of our presentation of our project, the benefits of the project, what we are doing currently in our university, and what we propose for ASEAN IVO, and how would we implement the AI and provide an ICT solution before going to the conclusion. So the objective of this project is to ensure regional self-sufficiency in agriculture by providing ICT-enabled solutions, because the pandemic has made it very imperative to be self-sufficient and self-reliant in agricultural production, and also has kick-started the importance of digital technologies to ensure smoother productions everywhere globally. But when we are designing all these technologies for implementation, one of the major challenges that the agriculture sector is facing currently is the crop disease, where the crops are affected by different pathogens that are present in the environment. So if the disease has a three-pronged approach, where we are currently targeting on rice, this rice is affected by pathogens like fungi and bacteria, which cause diseases and causes crop damage, which is not just the case. The onset of this disease also depends on environmental factors like temperatures and wind velocity and rainfall, pH and everything. So it's all an interconnected system that causes the disease. And we are trying to understand this better with the application of technology. And the benefit that such a project would bring about would be both for the agriculture sector as well as the food, where we can identify a database of crop pathogens and develop models for the benefit of farmers, because they are the ones on the field, and also provide frameworks for policymakers, which will help in decision making, pest management strategies, and also establish collaborations. And also ensure food security, because a lot of crop damage is happening. A lot of food is being destroyed, and this will also help us to ensure food security, which is the Sustainable Development Goal 2, which is zero hunger, and a goal to achieve self-sufficiency in the ASEAN region. To brief you a bit about the ongoing project, in Brunei, we are focusing on rice. And we are studying what kind of diseases affect rice and what are the causative organisms like fungi and bacteria affecting these rice species. So we are collecting these specimens from the agricultural fields, and at the moment we are doing studies on using biofertilizers and biopesticides, and study their germination indexes in a very controlled system and not in the open field at the moment. And to carry forward this kind of a project, we have recently been awarded much funding we could save the university to start a project from January, prediction specifically in rice through genomics research. Currently, we are doing culture-based studies, and we want to do the genomics approach to understand what kind of bacteria and fungi in the bioaerosols that harbor the crop pathogens cause specific diseases. And with this grant in mind, coming from our university, we will be procuring the air samplers, installing the air samplers in agri fields for collecting bioaerosols and identifying the specimens, and doing DNA barcoding and genomic analysis to get the data on crop pathogens. And what we have next is we want to propose something from the ASEAN ICT virtual organization, where in Brunei, starting next year, we have this sample collection, metagenomics, a bit of data analysis and solutions going on. And if at all we are to be funded by the ASEAN IVO Forum, we would like to carry forward this research, where we will continue doing the metagenomics analysis, and also with our collaborators in computational sciences, we would develop basic models like crop models, weather forecast models, etc., and integrate those models to develop certain solutions. The solutions will be, of course, digital based, perhaps an online application that could help mainly farmers and the policymakers as well. So this is the flowchart of the model, data model, where we have the crop data. We would like to digitize it with various types of data collected, analyze the data statistically, develop crop models, integrate the models, and then use machine learning to make predictions in this area of study. So we just not have, we're just understanding the diseases caused by pathogens on agricultural crops, but also the other parameters like soil parameters, the wind parameters, the temperatures, the climatic conditions, how these are impacting the growth of a particular crop. For Brunei, we'll be focusing on rice, and in ASEAN countries, we can extrapolate it to, and this would help us provide a roadmap where we have all this data and integrate those and provide robust solutions. And ultimately, we would like to develop an application which is a digital-based interface to disseminate presence, and because farmers need some kind of a help because they may not really understand what is the pH or what is the days when folks telling, what is the velocity, what's the moisture content, what is the onset of all these pathogens possible, and the application of fertilizers or applications of pesticides for that matter, and possibly information to individual farmers, so to develop application for the benefit of the farmers. So in summary, I would like to say is this project is mainly targeted on achieving self-sufficiency in agriculture, starting out from identifying the crop pathogens, because while we are designing all these technology, we also need to understand why agriculture is failing sometimes organisms, because these organisms are also connected to the sources like and how their dispersion rate affects the growth, for example. And then we develop different models and we apply ICT in the form of a tangible application to provide solutions. So I would like to end our presentation with a quote from Masanobu Fukuoka, where the ultimate goal of farming is not just the growing of crops, but the cultivation and perfection of human beings. So our project is ultimately aiming at helping farmers, helping the person on the ground, and helping policymakers with all the information and data and statistics that are necessary to devise strategies. And definitely this would be a long-term project. So thank you very much for listening to the presentation. And if you have any questions, you can reach me at my email, pooja.shivanand@ubd.edu.bn. We also have different collaborators from Brunei Darussalam from our university, Dr. Rao from University Technology Brunei, the other university in Brunei, Dr. May Khan from University of Tokyo, Japan, my colleague Dr. Hussein Taha from my university, Dr. Sachin, Professor Sachin. He's the expert in climate bioaerosols. He's housed in Indian Institute of Technology, Madras, and you've already listened to Dr. Hong in Vietnam. So thank you very much.
Thank you, Dr. Pooja. Now I open the floor.
Thank you. Can I ask question? Yeah.
I already raised my hand. Yeah.
Yeah.
I already raised my hand. Yeah.
Anwar, please.
Oh, okay. Thank you, Prof. Pooja. So I wonder, all these models you are mentioning, like weather model, base model, and so on, are they already there, or do you want to create this model during the project?
We would like to create these models during the project because we have started off with studying microorganisms and pathogens at the moment, and we are also collecting data. So the more data we collect, the better it is for models. I know that, but yes, we are.
How long do you think you can create all these models all together?
Pardon?
how long do you think you can create all
Can
these
you repeat the
models all
question?
together?
This would be definitely a long-term project, okay? And we would be collecting data every week, and which is spanned over 3 months, 6 months, a year, 2 years,
Yeah,
and
because
depending on.
if you want to create the model, then you must collect the data maybe 1 or 2 years, right?
Yeah, definitely. And
And
depending on the funding,
then your
depending
project
on
is
the.
over already.
Yeah.
Okay,
Tools.
anyway,
Yeah.
just my point of view. Okay, thank you, Prof. Puja. Yeah.
Thank you very much. Yes.
Professor Busama.
Okay, thank you. Okay, my question is to generate sustainable community practices. I think the involvement of the government agency or might be industry is important. So in your case, I didn't see any involvement of this government agency but good project. But I think the involvement of government agency or industry is important for sustainable practices. What is
Yeah.
your comment?
Yes, I totally agree with that. And that's a very useful comment. I'm sorry I did not put it on my slide because it was a collaborator for ASEAN IVO. For our project that has already been given funding from a university, we have established the collaboration with Department of Agriculture and Agri-Food in Brunei Darussalam. So we have formal collaboration with them, because without their help we wouldn't understand the ground reality, right? So our students for most of the experiments also use the facility of the Department of Agriculture, because they are the ones who are providing us information on crop diseases. They have something called a crop protection unit, and they have this database of microbes that are affecting crops, especially rice. And so we are working with them. I would also agree that probably we need to establish contacts with the farmers, because as you said, ultimately they are the ones who will be farming, and they are the ones who need help or information, and we are the ones who will benefit of any real information
That's
we
why
provide.
government agencies very important. Government agencies, they are the
Yes.
one who are very close to the farmers.
Yes. So
Yes, okay.
probably next time we make a visit, I will ask them if they can help us establish with the farmers.
Okay, thank you.
Yes. Thank you.
Any more questions?
Hi, Dr.
Vida.
Puja. I'm Dr. Vida from UTV. I'm basically
Hello.
one of the alumni. I mean, not alumni. I'm still currently doing one of the ASEAN IVO project 2018, where we're looking at smart watering system for paddy. So basically, I've been doing it for almost 2 years now, and more or less, I think you need to discuss with me in some way or another, because in terms of paddy, it has a life cycle. So it only goes for around 110 days. So your data is only effective for 110 days for that particular cycle. And in 1 year, there's only 2 cycles for Brunei. So the amount of data that you'll be collecting will be quite limited in terms of the waiting for the cycles. And it depends on where your plots are, because in Brunei we have several plots. So you need to get approval for which plots you're looking into. So maybe we can actually collaborate from that point of view. Just
That
to
would be
give you assistance here, because I've been working and I'm one of the fellows and I was mentored by people from TA anyway. I mean, from the people from Paddy Expert. So that would be something that could actually help you out.
Dr. Vida, thank you so much for raising that,
No
and it
worries.
would be really helpful to collaborate with you. And we welcome you to join the project if you're willing. That would be really helpful to us as well. And at the moment, we are collaborating with the Vasan IBTE, and we have also paid some visits to Kandol. And the potted plant experiments that we are doing was like 6 months, as you said. You're right. In a year, you can have 2 cycles. For the pathogen studies that we did in potted plant experiment setting, we carried out for about 4 to 6 months. And definitely water and irrigation, because of paddy, would play a huge role, and we would like to hear your inputs in this regard.
Because you also need to look into quite a number of variables, because varieties is also playing an important role. So some varieties are already resistant to pests and diseases. So these are the things that you need to look into as well. So what sort of crops that we're looking into, the varieties that we're actually planting in the. So these are things that you need to consider as well in terms of making sure that your data collected are more efficient and sufficient later on. Yeah.
Thank you so much. So we
Sure, no worries.
I will contact you. Thank you.
I'm afraid
Yeah.
that that's all the time that we have. If you have any question, you can directly ask Dr. Puja about this one. So our last speaker for this session, I invite Dr. Nadia Hussaini Zainul Abidin from University Putra, Malaysia. The title of presentation, Remote Monitoring of Harmful Algal Bloom via Marine Toxin Biosensor in the Integrated LoRa for Food Security. Please.
Hi everyone, can you hear my voice?
Yes.
Hello?
Yes.
Okay. All right, so I'm going to start. So good morning, everyone. I'm Dr. Nadia Hussaini Zainul Abidin. You can just call me Nad. I'm from the Department of Computer and Communication Systems Engineering at the Faculty of Engineering, University Putra, Malaysia. My project is on remote monitoring of harmful algal bloom via marine toxin biosensor integrated LoRa for food security. Okay, so fresh oysters, clams, cockles, I love them grilled and especially dipped in some Thai sauce. But did you know that they can be toxin contaminated? This year, on October 11th, the State Fisheries Department has imposed an immediate ban on shellfish sale, harvest, and also consumption. The department advised the public not to eat shellfish obtained from the waters of Sungai Geting, Kelantan. Kelantan is a state in Malaysia. The area is suspected to be affected by something known as red tide. Now, what is red tide? Red tide is algae bloom. Now, you're wondering, algae can't be that harmful, right? Wrong. The sample analysis of the shellfish obtained from this area showed that the shellfish was contaminated with a nerve toxin. The ban is still in effect up to today, and it has been more than a month. Now, imagine how devastating that is for the people that rely on the shellfish industry as their means of income. So what exactly is algae bloom and why is it harmful? So we call them harmful algae bloom or HAB. Algae ranging from microscopic single-celled organisms to large seaweeds, algae are just really simple plants. But as tiny as they are, they can cause us a huge problem. Under the right conditions, they can bloom. And when they bloom, they look like this. Commonly known as red tide, they can either appear red or they can appear brown, foamy, cloudy, and there are many other forms of it. And once an area is afflicted by HAB, there is a high chance of recurrence. And it tends to occur in sheltered places with restricted water movements such as lagoons, ports, and embayments. Now, HAB is not limited in Malaysia. Recent massive fish mortalities have been reported in Johor Strait in Malaysia, Balinao, Philippines, and shellfish poisoning and fish poisoning has been reported as early as 1970s in Papua New Guinea, Sabah in Malaysia, central northern Philippines. In the 1980s, it was reported in eastern Indonesia, Sumatra, Indonesia, and both sides of the Malay Peninsula. Now, this is a picture of massive fish die-offs. So one of the primary effects associated with HAB are contamination of drinking water, discoloration of water, smelly pulse on the beaches. This is especially upsetting if you live in that area, you have a smelly environment, and if that place is a tourist attraction spot. The smelly pulse can get really worse in a way that it releases gas that can irritate our lungs. And HAB has its life cycle, and as it decays, it also depletes the oxygen in the water, and this causes threat to the aquatic vegetation underneath. HAB can also clog the gills of the fishes, and also the one that we talked about in length was contamination of shellfish. If a human consumes contaminated shellfish, the person will get a paralytic shellfish poisoning, and the symptoms is observed as early as 30 minutes to 60 minutes, and it starts with the numbness and tinglings of the lips and tongues, extends to your fingers and your toes, and causes loss in muscular coordination, inability to breathe, and eventually paralysis. Now, there is no antidote for HAB paralytic shellfish poisoning, and the treatment is only supportive, such as artificial respiration. Now, this is something that we want to avoid at all costs because this is a near-death experience if it doesn't cause death itself. Now, what are the causes behind HAB? It is the increase in nutrients, also known as eutrophication. This can be natural generated nutrients or land-based discharges such as fertilizer runoffs, sewage effluent from industries and plantations, and also waste from livestock farms, and climate change caused by extreme temperature, extreme weather events such as flooding or droughts that cause restriction in water movement and transport by ocean-going ships and coastal boats. They go to a place affected by HAB, they store the water, and when they go to a new place, they release the water, and HAB is now spread to the new area. And other causes include pollution, food web alterations, and also water flow modifications. So the current monitoring of HAB is done by the Fisheries Biosecurity Division from the Department of Fisheries Malaysia. Sampling is done once every 3 months, and once an algal bloom is detected, it will be done once a week. Now, it still relies on the traditional methods of using microscope, which is very labor-intensive, time-consuming, and requires high expertise to identify the species and toxin. Now, why are we not regularly testing our waters for HAB? The reason is because our seafood culture industry is small and scattered nationwide. This causes problems to regular monitoring in terms of geographical. And also, the industry of shellfish is not very lucrative. So doing the regular testing themselves is not an option. So this is something, this calls for us as researchers to develop a technology that can help monitor these algae blooms on the onset of the bloom. Okay, so we cannot prevent HAB, but we can be better prepared with good monitoring and also mitigation solutions. The longer HAB is left untreated, the more severe is its effect. So this is our plan. Our plan is to remote monitor an area with possible recurrence of HAB to detect the onset of an algae bloom. So we are going to deploy biosensors employed on a buoy, and these buoys are going to be integrated with LoRa modules, and which will allow asynchronous data uploading to the LoRa receiver or gateway and to the clouds, and this data will be available to end users and end devices in the form of dashboards. If there is data abnormality, the system will alert the authorities and for fast mitigation. So this biosensor will be configured to collect data once a week, and the data will be collected early in the morning where algal bloom is the most visible. So why are we using LoRa? Because LoRa provides long-range communication up to 5 kilometers in urban areas and up to 30 kilometers in rural areas with good line of sight. It is best suited for IoT applications such as ourselves that require long range, low power requirements, and also low bandwidth. And for places like the maricultural site that has minimal coverage and minimal communication infrastructures and requires low operational cost. Now, what are the parameters that we intend to monitor? I intend to monitor chlorophyll alpha to show the abundance of algae. We intend to monitor saxitoxin, which is a common type of toxin secreted by algae. We intend to monitor spike in phosphorus, spike in nitrogen, drop in dissolved oxygen temperature, and if our funds allow for it, the image of the water discoloration. So the site that we chose for our project is Kuala Gula in state of Perak. The reason why we chose this site is because in June 2020, there was a massive fish die-offs, which affected 20 fish cages. So this is a huge loss in income, and the population is made up of socioeconomic status within lower middle to poor. So we really need to help them. So what are the benefits of the proposed project? This project will benefit a coastal community where the population thrives on mariculture industry, socioeconomic status with times is up within the lower middle. Sorry?
You have 2 minutes.
2 minutes, okay, sorry. With socioeconomic status within the lower middle to poor to have a sustainable fishery economy. Also, raise awareness of local communities and companies of dumping land-based nutrients in water. We also want to highlight the advantage of using technology have a sustainable economy. So the low-cost remote will allow for swift action on HAB eradication, preserve the aquatic ecosystem, give us food security and safe food for consumers, and most importantly, this proposed project will use the existing monitoring water quality guidelines by the ASEAN to complement the existing monitoring and management system on HAB. As collaboration goes, we have initiated contact with Department of Fisheries Malaysia, and we have received funding from National Instruments Malaysia branch amounting to 24,000 USD. We would like to welcome anyone who is interested to collaborate with us on this project, because we need more insights on this, on developing this project. Currently, our funds allow us to develop only one prototype of biosensor integrated buoy and only one LoRa receiver. If we can secure more funding, we would like to deploy more than one biosensor integrated buoy and more than one LoRa receiver, so that we can have a wider coverage of HAB monitoring and also deploy this at other maricultural sites and help more shellfish industries out there. With that, I would like to thank you for your kind attention. Thank you so much. Terima kasih dan arigatou gozaimasu.
Now I open for questions on Dr. Tony.
Okay, sorry, I keep asking questions, but this one maybe is very important. Yeah, I mean, your system is dependent on LoRa,
Yes.
right?
Mm-hmm.
So if there is no LoRa, you cannot use your system. Or how is it?
If there is no LoRa, I cannot. Where LoRa is just a means to communicate the data from the
Right.
biosensor to the cloud. So it
But
doesn't have.
But you need to adjust your system to the communication protocol from LoRa, right?
Yes, correct.
Yeah. So if there is only, let's say, LTE, can you use your system, or how big is the adjustment to use the system without LoRa?
Okay, so actually LoRa, we chose LoRa because that place doesn't have much coverage. So LTE is out of the question. So LoRa is the most viable communication system.
Yeah, but most places do not have LoRa. That is my concern, right? So what do you do when there is no LoRa?
Actually, the funds that we have is to erect a tower to implement the LoRa receiver. So we are using that funds for that.
Okay. So only for one place, right?
Only place for now, yes.
So it's somewhere else.
We
Okay.
more funds for that.
Thank you.
Okay. Yeah. Actually, two couple small questions. First question is, your harmful algae bloom, do you analyze what type of climate really favors the bloom? That's the first question. Climatic features, does it help the harmful algal bloom to grow? Second question is, you said like you'll be implementing the buoys. So how do you locate the exact location? What is the process of identifying the location of buoys? So those two are my questions. Thank you.
Thank you very much for the question. For the first question, actually the spike in nitrogen, the spike in phosphorus, the spike in temperature, so those are the parameters that we will be monitoring. And if we at extreme temperatures, such as when we have a drought, that is when harmful algal bloom is most likely to occur. And we have seen this recently because we were having a very hot weather and algal bloom just happened out of nowhere. So the exact cause, the exact condition behind them is not fully understood. This is why we need to have like, hopefully in the future, prediction model. Other places have done satellite imagery to capture the water discoloration. That's another method. But I think in the future, the best way is to have a prediction model to detect before it starts. Yeah, but this project only monitors first. Yes, this is our first step to helping the shellfish industry. For the second one, there are several locations, and we have consulted the Department of Fisheries Malaysia on this. They have advised us to go for either Kelantan or Perak or Johor, and Perak seems like a good place because it is nearer to our university, so we can go there a lot of times and make the data collection and see if our project is doing well. And if it goes well there, hopefully we can get more fundings and apply at other local coastal communities as well. So that is our first place that we will go for.
So the location of buoy is not as per the situation, but as per the location you're choosing it, closeness to you.
Okay, it has to be somewhere where there's a lot of shellfish farms, fish cages, and also places where the water movement is not freely flowing. So those are the places that we aim for. Yeah.
Okay, thank you. I'll give a chance to others. Thank you.
Professor Abu Sahma, you have a question?
Can I proceed?
Sir, please, Alisa, please, question.
Hi, Alisa. Yeah, Alisa from NICT. Just wondering, I think you might have answered the questions. I was going to ask, like, what type of image are you going to collect for the color of the water? And I think you just mentioned about the satellite image, right?
Yes.
So how good is the image, the quality of the image that, using the satellite image? Is that good enough to, do some prediction out of that, or, monitoring out of that?
Actually, the idea for satellite image is from USA. They use, I would think that they would use really good satellite imageries. But for Malaysia, we don't have that yet. So this is something that we can look into the future.
Okay, I'm afraid that's the time that we have. Thank you for the session. If you have any questions, you can just directly go to ask Dr. Nadia. Okay, so we have finished our session, but before we go on to the next session, we will have a 5-minute break. Thank you.
Thank you, Dr. Haji Abdul, and all speakers. Next session will be session 2, ICT for environment protection and disaster prevention. This session will be chaired by Mrs. YANO. YANO-san, can you hear me?
Yes, I'm hear you.
Nice, thank you. Please.
Okay, thank you very much, Mata-san. Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished participants of ASEAN and ICT IVO Forum. After we listen to some presentation from the first session, we continue to listen to the presentation in the second session with the main theme of ICT and for environment protection and disaster prevention. But before we start, I think we can take a photo session first. Okay, before we start this session, let me introduce myself. My name is Woro Indah Widyastuti. I'm from CIT Indonesia. I will chair this session. Hopefully, this session can run smoothly and successfully. Thank you. In the second session, there will be 3 presentations that will be delivered. 1 from Vietnam and 2 from Indonesia. Well, to shorten the time, I will let the first presentation, Dr. P. Lee Nguyen from Vietnam, to deliver his presentation with the title Realizing Mobile Air Quality Monitoring System Architectural Concept and Device Prototype. Okay, 10 minutes time is yours, Dr. P. Are you ready?
Yes, good afternoon, everyone. My name is Nguyễn Phi Lê, and I come from Hanoi University of Science and Technology. So, can you see my screen now? I'm sharing my screen. Can you see my screen now?
Yes, we can see.
Yes. Okay. Okay. So, I will start my presentation. Okay. So, today I would like to introduce our project entitled Realizing Mobile Air Quality Monitoring System, Architecture, Concept, and Device Prototype. And this work is a collaboration between our university and Chiba University in Japan. So in this talk, I will first introduce the background of our research, and then the problem statement and our goals in this project. And then I will present our solution and some preliminary results. So as you know, air pollution is getting more and more serious all over the world, and especially in developing countries like in Vietnam. And In our country, air quality monitoring is mostly based on static station, and I think this is common all over the world. And for example, in Hanoi, we have about 50 stations in total, and most of them concentrate in the central area. And for monitor air quality real time, we have some application on smartphone like Air Visual or Palmer and so on. And this application provide the user the real-time air quality information, and they also bring the forecasted information in a near future, like 1 week ahead air quality information. And the current air quality monitoring system suffer from 3 critical issues. And the first one is the limitation of monitored reasons. And because the static stations are quite expensive, so they are deployed very spare. And the monitored reasons are very limited compared to the total area. For example, in Hanoi, we have only 50 stations in the total area of more than 3,000 square kilometers. And the second problem is the lack of fine-grained forecasting and analyzing system. And the current forecasting model can only provide the short-term forecast, for example, within 1 week ahead. And especially all of the forecasting model now cannot predict the air quality in unmonitored region. So it means that they cannot provide a temporal prediction. And the final issue is the lack of public database for developing country like in Vietnam. So in our country, researcher like us is very difficult to access the raw data of air quality information. So in this project, we aim at construct a fine-grained real-time air quality map like in this figure, and we hope to bring a high accurate information about air quality at anywhere and anytime. And we also want to build an API library for analyzing and forecasting air quality using machine learning. And finally, we also investigate the optimal deployment of air quality system. So to realize that goal, so we have 2 keys in our solution. The first one is to leverage the mobile monitoring system, monitoring devices mounted on vehicles like buses. And by exploiting the mobility of the vehicle, we can broaden the monitored region, and then we can monitor a large region with only a limited number of devices, and we can enhance the prediction accuracy. And the second key point in our solution is to use spatial and temporal prediction model. And by using temporal information, we can forecast future air quality at any time. And by utilizing the spatial information, we can predict air quality at unmonitored regions. And so, I'm sorry. So here is the architecture that we have proposed. So we propose a 3-tier architecture, and at the bottom we have sensing tier that consists of many sensors, many IoT devices mounted on vehicles, and this device will collect real-time air quality data, and the sensory data will be transferred to the application tier through the communication tier. And in the application tier, the server will store the sensory data and perform machine learning model to forecast the future trend of the air quality, and we also predict air quality in unmonitored region. And the application tier also optimize the behavior of monitoring devices to provide information to user through smartphone application and web portal. And currently, we have finished the prototyping our IoT device, and we also running field tests. Here are some capture of our devices. Here here are some sensor in IoT in our device, and belong collecting the air quality of indexes. We also measure the GPS, and we also measure the energy consumption of the devices. And here's the circuit layout of our device, and there are 4 main components. The first one is the MCU, and we use Wi-Fi and LTE for communication. And for the power, we use both battery and solar energy harvesting. And this is the device and functional blocks in our device. And this one is the sensor module. And this is the operation flow chart from when the device collects the sensory data and send to the server. And here the screen in our server. And this the data stored on the device SD card. And we also run the field test, and we mount a device on a private car, and we run over Hanoi. And here's the air quality information collected from device and visualized in our web portal. So besides collecting the data, we also perform the data calibration to correct the data, the raw data from sensor. And we are trying various machine learning model to calibrate the data. First we try some simple model like Isdbt, and then now we try more complicated model like ZAN. And we use very high accurate device for reference like Green 03 and Green 07. And here our experiment setting. And in this slide, I'm showing some preliminary result on our calibration method. And you can see in this finger, the red line is the ground truth, and the blue line is our calibration result. And you can see the calibration result quite match with the ground truth. Okay, so in this project, we have proposed a mobile air quality monitoring system rely on IoT device mount on vehicle. And we already finished prototyping, and now we are collecting and calibrating data and put them on the web page. We are welcome on collaboration, and if you have any question, you can reach me at this email address. Thank you very much.
Okay, is there any question regarding her presentation? I think there's no question. So thank you very much, Dr. P, for your presentation.
Thank you very much.
Okay.
Excuse me, there are questions. People have raised their hands.
Okay, I didn't see that. Okay, thank you. Okay.
Thank you. Yes.
Yeah.
Thank you. I think this is an interesting project. I would suggest that you should include use case when you do the proposal. Also, maybe try to include stakeholder into your project.
Sorry, I could not hear your voice clearly. Can you repeat your question?
Sure. It's not the question. It's more toward like I would think that it is a good project, and you include stakeholder into the project. Plus, try to come up with some use case. I think that they make the project look very good.
Oh, thank you very much.
Right.
Thank you for your advice. Yes, thank you very much.
Okay.
Could I cut in? Actually, I don't have the icon for the raising hand. I have a question.
Okay. Please.
Okay. My name is Vittiyakon. I'm from Thailand. Actually, from Chulalongkorn University, Thailand. We have implement like similar projects, something like this in Thailand. Actually, in Bangkok, Thailand. Actually, we mount on the like a loop bus in Chulalongkorn University.
Yes.
My question is like when your like vehicle is moving,
Yes.
is because of the airflow to the your sensor will be different from the stationary sensor. You get what
Yes.
I'm saying?
Yes.
How can you cope with the precisions when your vehicle is moving? And then how fast your vehicle is moving? Actually, that is my questions.
Oh, thank you very much. Indeed, that's very interesting question. So, to get a correct data from sensor, so we perform the calibration on the raw data obtained from device. So now we are perform the calibration on static sensor. But after calibrating on static sensor, we will do the calibrating on moving sensor. So we will make the vehicle run with different speeds, and we will collect also the speed, and we use both the speed and sensory data to calibrate the data.
So it means like you better have like many like static sensors to calibrate like when you're moving, right? How static sensors for you, right? When you have used to calibrate moving sensor.
No, we use moving sensor to like we make we mount sensor on the vehicle, and then when the vehicle move, we collect the moving sensors data, and we use that data to train our model, machine learning model. Yes.
All right. Okay. Thank you very much.
Thank you very much.
Okay, I think it's time to move to another presentation. Thank you.
Thank you very much,
Dr. P.
Thank you very much.
Oh, not possible to ask another question?
Is it? I think. Is it possible? Okay, please.
Okay. What's your name again? I'm sorry.
My name is Lei. You can call me
Hi,
Lei.
Lei.
Yes.
Hi, Lei. It's quite interesting that you actually use moving sensors.
Yes.
Right.
Yes.
So because if you move the sensors, there is certain limit of speed you can collect the data, right?
Yes.
So how is your project? How is this the limitation of speed? You can still collect the data from the sensor.
Yes. So actually, the initial goal of our project is to put the sensor on the buses, and for buses, we the speed of buses is not so diversity. So we know the maximum speed of buses. I think about 50 or 60
kilometer.
Yes, kilometer. Yes.
Oh, okay. Thank you very much.
Yes, thank you.
Time
very
is
much.
off now. Thank you once again. And maybe if there is any question, you can directly go to Dr. P.
Yes, thank you very much.
Second presentation is I will ask Mr. Hamam Lisa from Indonesia to deliver his presentation with the title Artificial Intelligence Driver Disaster Mitigation Solution. Dr. Hamam, please, your time.
Thank you. Question. Ladies and gentlemen, a very good morning to all of you.
Cannot hear you.
We cannot hear your voice.
It's okay. Agak maju, Pak. Agak maju dikit. Sorry, excuse me.
Hello. Can you hear me, everyone?
Okay, Pak.
Yes.
All right. So let me restart.
I think you're on mute.
Thank you so much for Ibu Woro, the chair lady for attention. A very good morning to all of you. My name is Hamam Riza. Dr. Ilyas from the Center for Disaster Risk Reduction Technology.
Doctor, I think you are muted, or for some reason the sound is very low. The volume.
Can you hear me now?
Yes,
I think you may need to stay near your mic because every time you move away, we can't hear you anymore.
Okay.
Yeah.
So you can hear me now.
Yes, we can hear you now.
Okay. All right. So I would like to present our solutions on AI-driven disaster mitigation, and it is done through the Center for Disaster Risk Reduction Technology and AI Innovation Center at the National Research and Innovation Agency of Indonesia. As we all know, some people say Indonesia is the natural disaster laboratory. Since the geography of Indonesia cause vulnerabilities in many regions, which are prone to geophysical and hydrometeorological disaster. We can name all sorts of natural disaster, natural hazards in Indonesia, from earthquake to volcanic eruption, tsunamis, land and forest fire, flood, landslide, and many others. So in doing this, since Indonesia lies in the, I would say, Indonesia lies in the path of most active ring of fire, Pacific, which affects all those countries, Russia, Indo-Australia, and Pacific plate. Certainly, according to the World Risk Index 2020, we can see the risk of disaster in consequence extreme natural events. Most of the world's countries, it is calculated by basis through the multiplication of exposure and vulnerability. Indonesia has the risk of extreme natural disasters about 10%, exposure around 21.3%, up to 50%. So vulnerability encompasses also the societal sphere, and is comprised of also of other components which are weighted equally, such as susceptibility of the structural characteristic and conditions, various abilities. So at the bottom line, potential disaster in Indonesia can be really grouped in main hazards and collateral hazards. I would like to say a few things about what is the impact of all these natural disasters. Some of the economic loss have been reaching out up to 15 years. For example, the geological disaster. From 2004, 19 is up to 20 billion. Also, just recently, but South Kalimantan indicated are really suffering economically. Also, from the forest fire here, Bahasa, it's also showing up 20 billion in just a single year in 2019, in 2015. So all those are posing a great loss to our nation. That's why in order for us to be more competitive and provide compelling solutions to mitigate this disaster, we adapted to the latest development of technology 4.0, such as AI, IoT, big data, and cloud computing. AI-driven disaster predictive modeling is our way of responding to land and forest fire, for example, for preventing this land and forest fire in our peatland, development of hotspot forecasting system by observing the peat groundwater level. AI-based can be the basis of the policy recommendation on doing the impact-based forecasting and risk-based warning. We are also putting early efforts to mitigate forest and land fires by predictive modeling based on data mining experience. So I want to share with you these two use cases. First, for the land and forest fire prevention, and the other one is start up on AI for tsunami, early warning. As we can see in this slide, the weather modification technology are really an indicator for our action into the prevention of land and forest fire. So it is really a best timing and effectiveness of this operation, weather modification technology, which can prevent the occurrences of hotspots throughout. So in order to do this, we have several steps of doing AI for forest fire prevention. First, groundwater level for peatland in many provinces are collected. It becomes a big data for forecasting that we are going to put into our time series forecasting, where we do seasonality analysis, model fitting, and evaluation, prediction. Then it will go into the third stage, where the predictive result, observation of the groundwater level, and the forecasting coming up from different agencies. So the read down station from other IoT sensors in this peatland. So from this, the prediction of the groundwater level in the next 3 months starts in provinces fire mostly occur like in Riau, Jambi, South Sumatra, and other. This will engage into weather modification. So this hotspot can be reduced and prevented, certainly can be mitigated. The core of this work are data mining coming out from different agencies providing the data. So, for example, the weather data, the peatland groundwater level, and support coming from ministry. And we also provide this forecast to determine the effectiveness of water modification. Rate reduction. Time frame 3 to up to 6. The next one is our use case is AI-driven tsunami early warning system. Prone to tsunami because of the ring of fire.
Up, Pak.
Now, there's a lot of tsunami. Same tomography.
Master.
Yes. Okay. I'm getting to my last two slides. So tsunami modeling along the Sunda and to Banda Sea. We have developed tsunami modeling for more than 1,000 scenario for exercise in South Java Sea, where we are very prone to the collision of the plate from Eurasia and Indo-Australia plate, which can cause the major earthquake in Indonesia. And from this, we build up the modeling, which we call peka tsunami, prediksi kebencanaan tsunami, where we predict the tsunami prediction system, travel time, location, and wave. I think that's all that I can say. Thank you so much for this opportunity. Thank you.
Okay. Is there any question from Paham presentation?
You can still listen to me, right? Yeah.
Yeah.
Chair, I have a question.
From UTB, please.
Okay, Hamam. Dr. Hamam Riza, how are you? Long time no see.
Hello.
Tony Anwar here.
Hello, Pak Tony. How are you, Pak Tony?
Yeah, I'm
Good
okay.
to see you, Pak. Yes.
Yeah. So, Pak Hamam, can I call you Pak Hamam, right?
Yeah, sure.
I would like to know your tsunami warning system or something like prediction system, eh?
Yes.
How different is this to the existing ones? Because I know that since 2004, since Aceh tsunami, in Indonesia we have done a lot of research and development in this area of tsunami warning system, prediction system, and so on. Can you inform us, please?
Sure, Pak. Thank you for the questions. So you are right. Since the great tsunami in Aceh and in the Indian Oceans, yeah, there have been efforts to actually provide tsunami early warning system. So at that time, we have worked together in collaboration with many donor countries to support the availability of buoy system. Yeah,
right.
These buoy systems are being deployed throughout Indonesia. Around 22 or 24 buoy system were being deployed, but unfortunately, from time to time, this buoy system were lost or broken. It was really a sad news for all of us since these buoy were being vandalized by, a lot of ships passing through this buoy, and by 2016, we lost all of this buoy system, unfortunately. So starting in 2018, we were hit. Yeah, we were hit by the Palu and Donggala tsunami in Sulawesi. So the government, the president, Joko Widodo, have declared a new development for the tsunami early warning system. So BPPT was mandated by the president to work together with the BPPT.
Yeah. Okay, the difference is the voice system, and now you have AI driven.
We're rebuilding the system, and we have deployed many other buoys.
Right,
And also, we are going to include the Indonesia cable-based tsunami method, the subsea cable, fiber optic cables, which is equipped with the pressure sensor and ocean bottom unit to read out the earthquake and the potential tsunami. And now the data being collected for the modeling of using AI and machine learning.
Thank you very much, Pak Hamam.
Thank you.
Okay, bye.
I think it's time is already up. I think I have no opportunity to open the question and answer for this session for Pak Hamam. I think if there is any question, so you can deliver directly to Pak Hamam itself. Okay, thank you, Pak Hamam, for your presentation. I think Sarah, the secretary will announce something. Is still?
Yes, I would just like to ask our colleagues in Indonesia. The problem does seem to have largely resolved itself, but I believe you're all in the same meeting room. So for the following presentations, please remain near the mic, and if it is possible, we would ask that you turn the volume up, because we are getting a lot of dropping out in the middle of the presentation. So thank you very much.
Okay. Thank you. Okay, thank you, Shara. So, okay, let me start for the third and the last presentation in this session. I will ask Professor Dr. Imas Sukaisi Sitanggang from Indonesia to deliver her presentation with the title of MLP, or Machine Learning for Data Analysis of Peat Swamp Forest Monitoring System. Professor Dr. Imas, please, time is yours now.
Thank you very much, Ibu Woro. Can you see my slide, Ibu?
Yes, we can see.
Okay, thank you very much. So my voice also clear, ya, Ibu?
Yeah.
Okay, good morning, everyone. So my name is Imas from IPB University. So I'm going to share our research work and also research agenda. This is the collaboration work between IPB University and University Putra Malaysia and University Technology Brunei. The title is the Machine Learning for Data Analysis of Peat Swamp Forest Monitoring. So as the background, we know that the forest and land fire in Southeast Asian region is the big issue almost every year, especially when it occurs in the peatland area or the peat swamp area. We have the data like this, about 70% of peatland in Southeast Asia is occur in Malaysia, Indonesia, and also in Brunei. Especially in Indonesia, we have about 70%. The total peatland in Southeast Asia occur in Sumatra, Kalimantan, and also in Papua. As you know, when the fire occur in the peatland, so many negative effects of this disaster, especially in the transport wage, can be felt by a friend in Malaysia, Kalimantan, and also in Brunei Darussalam. So in order to minimize the negative effect of forest and land fire, the prevention is the important key there in Indonesia, Malaysia, and also in Brunei. So this is the idea of our work. So we need to have the real-time monitoring system, the prone area as. Pardon?
The slides are not moving.
Okay. But now moving in, yeah, it's moving, Dr. Rina?
It's still in PPT mode, but not in presentation mode.
Okay. So, oh, sorry. So I again share the presentation. Okay. So can you see my presentation, Dr. Rina?
Yes, but it's now in slide 3, but it's still in presentation. But I think it's okay. Just present it first.
Okay. Yeah. So yeah, sorry for the issue. Okay, so this is the idea. So we need to have a real-time monitoring system on the prone area in land, especially in order to develop the early warning system of the forest and land fire, especially in peatland, in order to minimize the negative effect of peatland fires. Actually, Indonesia, Malaysia, and Brunei, we already implement the IoT technology in order to record the data in the peatland under the project NIPC, Network Asian Peat Swamp Forest Community, funded by ICT Virtual Organization of Asian Institute and NICT ASEAN IVO. So in this project, we established the IoT technology in some area in Malaysia, Brunei, and also in Indonesia in order to collect this kind of data, including the water level, temperature, and the humidity in the peatland or peat swamp forest. Okay, in addition to this technology in Indonesia, we already have the peatland real-time monitoring system. We call it the Sipalaga, as Dr. Hama mentioned. Sipalaga is the real-time system collect some parameters in the peatland area in Sumatra and also in Kalimantan. Since 2080, the Sipalaga collect the data from 142 devices across into province, to island Sumatra and Kalimantan, using the technology of GSM, and so GPRS to send the data from the land to the server in the BRG in Jakarta. This is the dashboard of Sipalaga. This report the daily data from the fields, including the weather data and also the water level in the peatland area. So in Brunei already implement the IoT technology to collect this data from the peatland. This is the architecture that developed by Brunei. They already implement 4 sensor in the Badas peatland area in Brunei Darussalam using the LoRa technology. This is the architecture. And in Malaysia has already implement the IoT in Raja Musa Forest Reserve, Selangor. They established 6 sensor in this area with LoRa technology. This is the data collected from this technology. This in the right hand, we plot the data from the Sipalaga for since 2080, and this is the data from the IoT system from Malaysia. The issue raised data is about the quality, whether the data has this kind of the issues such as the missing value, noises, and also outlier, and also inconsistent data, because some devices in the remote area Sumatra and Kalimantan are not working properly, especially in the area in the forest and far from the city or from the remote area. So this is the idea. We have the real-time system to collect the data from the land, and then we want to develop the application to analyze and to process the data. So then we will implement the machine learning algorithm to develop the time series prediction model to have the forest and land fire vulnerability. So this flow is to develop the pit swamp forest monitoring.
I'm sorry to interrupt.
Yes.
Your slides are not advancing because you appear to be, you're not sharing the slideshow. So you're sharing just the regular Microsoft PowerPoint window.
Okay. So, can you see my slide now?
We can see moving. Yes, okay.
But okay. Sorry. Is to develop the analysis for the peatland fire data, and then the second one is to forest and fire, especially in peatland. Additional output, of course, in some publication and also some works to out the estimation. We also implement the machine learning algorithm the fires by the type computation neural network, LSTM, and also using the Facebook Prophet, the algorithm. We propose this work for 2 years. Yeah, in the first years we want to develop the data preprocessing system, and then the second year for the forest vulnerability based on the pit swamp data. This is the contribution. So in terms of innovation, to propose the web-based and mobile application for time series prediction of and which is the third between Indonesia and we plans there is between there is also student included in the project. And then the last one, we want also to establish the cooperation between the stakeholder in Malaysia, Brunei, and Indonesia, including with BRIN. Thank you very much. This is the research team, yeah, from Indonesia, Malaysia, and Brunei Darussalam. Thank you very much.
Hi, Miss Chairman. Could I ask the question? Could I ask question? Could I ask a question? Yeah, what kind of sensors you use for monitoring the pit swarm? Actually, in Thailand we have a similar project that we would like to implement for the disaster management. Okay. But I would like to know what kind of the sensor you use, and then how many sensors you use, right, in order to do the prediction model. Okay, yes.
Okay, thank you very much, Prof, for the question. So I also invite Dr. Wida here to provide the answer from Brunei side. From Indonesia, we have the sensor as many 142, Prof. The sensor located in Sumatra and Kalimantan to collect the climate, weather data, and also the ground level data. Yeah, but the communication we use the GSM. yeah, and the GPRS technology. So please, Dr. Vida, add the
Thank you.
sensor
Thank you,
system
Prof.
from
Imas.
Brunei. Thank you.
Yeah, so for Brunei, we actually implemented two sensors. One is for the groundwater sensors as well as the weather sensors. So we actually planted 3 at the moment, especially around the area where it's degraded. So these are the data we are collecting is basically on the water level, soil
Could you
temperature, soil
turn on
humidity.
your camera, Vaida-san?
Like judging from like the sensors you deployed, do you think that you get a good prediction model actually? I mean, like in terms of the number of sensors, and then do you satisfy you with your prediction model?
I think because at the moment, the data will be collected from 3 different countries, and it's more viable, and it's more the data is more robust because we are now taking from 3 different parts of 3 areas where the data are more, we have more data, and especially in Indonesia, they have more data, right? And I think in the context of prediction, Dr. Imas will be able to provide more info on that. Yes, Prof. Imas, please proceed.
Thank you, Dr. Vida, from Indonesian side, because the sensor is located in 142 location, Prof, and this record daily data. Yeah, so it's more than enough to do a prediction because this established since 2080 until now. The sensor still collecting the data, so we have a large data to do a prediction model.
Okay. I think there is Pak Tony Anwar from UBT.
Yeah. Sorry, okay, I would like to ask you about how many sensors actually do you deploy? You in Indonesia, you said 142 locations. Is it the same forest or is it different? So the second one is what kind of prediction model actually is being used for this prediction result? Prediction, predictive analysis. Okay, thank you.
Thank you, Prof. Tony. Yes, in Indonesia, about more than 100 sensor located in Sumatra and Kalimantan, especially in front
Okay.
forest and land fire area, in Sumatra and Kalimantan. As we know, from Sumatra, so many in Rio, for example, Sumatra Selatan, Southeast Sumatra, and also Jambi, in Kalimantan, West Kalimantan, Pulang Pisau, and also in East Kalimantan, so many location. Yeah.
Because of the forest fire,
Yes, of course, Kalimantan and Sumatra especially. But
Thank you.
currently also forest fire is occurred in Papua, but the Sipalaga cover only 2 islands, Sumatra and Kalimantan currently. Yeah. And for the prediction, the important parameter from the peatland is water level, Prof. Because from the water level we can estimate the severity of forest and land fire. So we want to do prediction on that parameter, the water level in peatland fire, because if
Sorry. I think there is a misunderstanding. Prediction algorithm. What kind of algorithm are you using?
LSTM, lots of memory, and then also because we already proved the LSTM, and Facebook Prophet has the good performance in terms of the time series prediction. We already done on this, so we want to implement this
Also in Brunei, LSTM.
In Brunei, I think currently not in the CNN method. Yeah, Dr. Vida, please correct me.
Time
Yeah.
is up.
Yes, and I would like to stress as well that we are the concern is basically to mitigate. So we are making sure that the area is always wet. So we're trying to mitigate the forest fire from happening. So one of the things that we actually look at, that's why it's very important for us to ensure that the water level is at the optimum level. Yeah.
Thank you very much, Prof. Both of the Thank you.
Okay.
Thank you.
Okay. Time up now. Thank you very much for Professor Dr. Imas. Now I think we're coming off the end of the session. Thank you very much for your kind attention to hear all the presentation in this session. And also thank you very much for all presentator which has delivered nice presentation. Hope in the future you will have successfully collaboration. Thank you, and I return the next agenda to the committee. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Chairperson Wano-san, and all the speakers. Okay, it's time to move to next session. Next session will be next session 3, ICT for Secure and Smart Community. This session will be chaired by Guan Tan Tu, Professor Guan Tan Tu from YNU. Professor
Thank you so much.
Guan Tan Tu, can you hear me?
Yes. Thank you so much, Dr. Hiroshi.
Thank you. Please.
Good morning, ASEAN IVO Steering Committee members. Good morning, presenters. We have now 4 working presentation in the section. First, I would like to invite Dr. Philip Abela Martinez from DOE, Philippines, to present Bruna Sync, providing digital content in remote communities through opportunistic spectrum access. Please.
Are you now? Yeah, I'm sharing the screen. Okay. Mabuhay from the Philippines. I am Philip Martinez from the DOST, Advanced Science and Technology Institute of the Philippines, and I am here to present going efforts in entitled Bruna Sync.
Yeah,
Sorry.
yes.
Providing digital content in remote communities through opportunistic spectrum access. So the rationale for these efforts is due to the pandemic situation, in-person classes here in the Philippines are still limited and has abruptly shifted to remote mode of delivery. However, in this setup, there are still unserved and underserved areas in the Philippines where information infrastructure is unavailable or unreliable. To address this digital divide, the project investigates the use of wireless technologies operating on TV broadcast signals to deliver educational materials in remote and rural communities. And we have chosen to explore in UHF TV frequencies because it is known to reach farther distances compared to other frequency bands. So let us discuss Isdbt datacasting. Isdbt is the digital TV standard adopted by the Philippines. We are currently on test broadcast, meaning we have both analog and digital TV transmission operating at the same time. But analog shut-off is scheduled by 2023. And by analog shut-off, we have an opportunity to use the vacated frequencies for other applications. And we see this as an opportunity to explore datacasting, which is a way to send auxiliary files apart from the broadcast material. To tell you more about this, let us imagine the digital TV transmission as a data pipe wherein you have your video, your audio, and some null packets for to maintain the constant bitrate. We maximize the unused capacity by using this data by inserting useful data packets. This could be packets containing modules for the lessons that is synced with the video and audio content for broadcast. So here is our test setup. We have the video and audio encoder. Then we have multimedia in the form of a text file or a PDF file that is inside theoretically in a file database, and it is carried into a object carousel, and it is then transported into a transport stream via a multiplexer. So the normal multiplexed for broadcast is only audio and video, but now we are inserting multimedia and text, etc. in an object carousel. This modified transport stream is then received by the the DTV receiver, which is connected to a single board computer for processing of the received transport stream to be able to show the content for broadcast and to capture the sent data that is sent through the transport stream. So again, it's generate the transport stream with audio, video, and data. Transmit for now using an SDR-based transmitter, but this setup could be modified into scale to use other transmitters as well. But for now, it's SDR for the proof of concept. Then we receive the transport stream to the DTV receiver and retrieve the sent data. So here is the developed Isdbt transmitter prototype. It is an SDR-based transmitter prototype with one segment channel transmission plus 12 full segment transmission. It is operating at 10 watts peak output and complies with the necessary modulation for Isdbt, which is 64 QAM, 16 QAM, QPSK, and the various bitrate depending on the modulation scheme. You can see the picture of the setup of the transmitter, the INQ plots, and the Isdbt constellation plot. Here is the Isdbt receiver prototype developed by DOST-ASTI. It is an integrated tuner which tunes into the RF frequency and to lock into the certain program for that is being broadcasted by the transmitter, and it is it's integrated with the modulator to transform this transport stream into an MPEG file format, and it has a USB interface to be connected to the computer for the processing of the MPEG file and for actually control of the tuner. So the picture on the left is the said board in action. It receives a transmission broadcast, educational file that is being broadcast, and the receiver is connected into a laptop which simulates a single board for us to just see if the tuner is able to tune and to able to convert the transport stream into something that is viewable, like the picture that you are seeing right now. So we also have some preliminary testing since we both have the transmitter prototype and the receiver prototype. So the scenario here is that because we are limited with the transmit channels that we can actually use, because in the urban areas we cannot use the TV channels. So we are testing this in a rural area where there is no TV transmission, apparent TV transmission. And the scenario is that we have a low power transmitter located in the school to simulate situation wherein the school itself is a broadcasting station wherein the community can tune into those the programs being transmitted at the school. So, and we are measuring the signal strength and confirm reception of the stream and attempt to retrieve a PDF file that is embedded into the transport stream, which is 6 MB in size. So you can see the picture from the transmit side and from the receive side. So due to the limitations of our testing, we only have distances from 0 to 100 meters. So from the transmit side, that's your antenna, and from the receive side, you can see us measuring the receive signal strength and the confirmation of the reception stream. So preliminary result, to receive the stream and retrieve a 6 MB PDF file at 80 meters away from the transmitter. So the figure on the right is signal level after the side. It is around negative 50 dBm. For this project is to test other kinds of file formats and different file sizes. More test scenario, just more of would like to test more the broadcast language and work on an improved and integrated receiver device wherein a computer is integrated into the tuner and the modulator board. And that ends my presentation. Thank you. And the floor is now open for your questions. Thank you very much. And again, mabuhay from the Philippines, and stay safe wherever you are.
Thank you, Mr. Philip Martinez. And it's time for us to have a questions, please. Yes, Dr. Rahman. I have one question.
Sir.
Your solution is very interesting for the developing countries based on the Isdbt.
Sir.
The casting.
Sir, yes.
And how much does it cost? The package including Isdbt transmitter and receiver antenna. Can you?
Because we are in the prototyping process,
Can
the
you
costs
estimate?
are initially high. It is around the actual cost for the prototype itself. I guess it's just remember it's a prototype, so the costs are high. It ranges from 20,000 pesos for now, but
Equivalent to dollars.
because sorry, times
range.
divide by around 250 to 300.
Oh, it's good. It's good. Yeah. Thank you. And it's time for more questions, please.
Hi, Alyssa from NICT. Can I ask, have a question?
Ashin.
I'm just wondering, have you talked to, like for the sustainability, have you talked to maybe the Department of Education, the Ministry of Education, or I'm not sure, the Ministry of Telecommunication, for them to maybe after the project, they can sort of like subsidize or endorse this type of equipment, to make it more sustainable?
Yes, we have considered partnering with our Department of Education and for our National Telecommunications Commission, which is the our FCC in the Philippines, in order for this project to be developed further and to introduce them that we are developing these efforts. And actually, we have initial meetings with the school and the Department of Education, and we are actually partnering with them to test the contents that they have, because they have the video contents already, and they just have to distribute it in the this remote area. So we are currently talking with them and exploring the synergies for us, because we believe that this is a great project that will help our Department of Education to reach more students and to have an interactive experience in the remote delivery of learning.
Thank you very much.
Okay, I have one question, Mr. Philip.
Sir?
Can you hear me here?
Yes, sir.
Okay, I didn't see any collaborators in your presentation, right?
Yes, sir.
So what do you think about the potential impacts on the Asian countries, based on your project?
Sir, because we share the same situation in ASEAN, I think we could partner with other ASEAN countries as well. And the only difference is that the technologies of the digital TV that has been adopted is different by other countries. And I think it is Philippines and Cambodia that has adopted Isdbt, and other countries have adopted other standards which may or may not support data casting. But the technology or the algorithms would be similar as well. So we could we could forge, and we are open to partnerships with other countries as well. Or if there are other ASEAN countries that has started with data casting as a form of educational delivery, then we are open to have meetings and collaborations with other countries as well. Yes, sir.
Okay, thank you.
We have one more minute for question, please. Very short questions.
Okay, Philip, have you any supporting funds for your project?
Okay.
Currently, sir, the project is currently supported by the Philippine government as of now, and we are looking for other funding sources as well to have more developments in this area, sir.
Okay, thank you, Chairman.
Okay, thank you, Mr. Felix Martinez. Good.
Thank you, sir.
Good success. Thank you. And now, next, I would like to invite Dr. Sai Long Kyok from Singapore, University of Glasgow, Singapore, to present an IoT-based public translation transport
Excuse
data
me.
collection framework.
Excuse me.
Sorry. Okay.
We would like to take a picture, a group picture for this session. So could the people involved in this session please turn on their cameras so that the
Okay.
Secretariat can get a group photo? Thank you.
Thank you.
Right, thank you. Thank you very much. We may proceed with the presentation.
Thank you so much. And let me to invite Dr. Sai Long Kyok from University of Glasgow, Singapore, to present an IoT-based public transport data collection framework using Bluetooth proximity beacons. Please.
Thank you, Chairperson. I'm Silong from University of Glasgow, UK, but actually based in Singapore. So today I'm going to share my experience, our project experience on using IoT systems to actually collect public transport data using Bluetooth proximity beacons to collect bus data sets for analysis. So this is a brief outline of my talk today. So what are the problems, definitions, how do we actually can use technology to actually improve the urban mobilities, especially for developing countries. And then we'll present our sharing of our prototypes on using IoT-based bus tracking systems, our deployment experience and insight, and how we can actually work together with some of the partners in ASEAN, to make an impact and what are the potential future works and collaborations. So I think this is a very typical scenes that you can see in many developing countries where people were waiting for bus services at the bus stop, primarily because the bus schedules are not really accurate, not like in Japan or in European countries or even in Singapore. Buses schedules are pretty accurate and the waiting time is quite minimal. But in majority of the developing countries, we have these problems where people may not know what time the buses will arrive, and how can we actually use technology to improve such a situation. So these are some of the pictures that we've taken in Johor, Malaysia. I'm personally from Malaysia, so although I work in Singapore, and sometimes I go back to Johor, and then this is some of the scenes that I've seen in Malaysia, as well as in KL, even though there's a bus its estimated arrival time dashboard available, but I think most of the times it's not accurate. And if you look at this further, there are many developing countries around the world which may not have the necessity technology or costs or fundings to actually improve the public infrastructures, especially for the public transport systems, right? So I think majority of the ASEAN countries as well are classified as developing countries where economies are in transition, and then some of this technology can actually help to alleviate problems faced by the commuters at large. In particular, what we observe currently is that majority or most of the countries in developing countries, they prefer to purchase new bus fleets, in terms of hardware, right? In terms of software infrastructure investments, we see that there's a lack of software infrastructure investment in such situation, right? In rural areas in particular, bus frequency is considered very low. You may need to wait for a long time for the bus to arrive. Sometimes you may not even have bus drivers coming to work, right? And that ensures that the users are not really, they don't really know when the bus will arrive, and sometimes it may not even arrive, right? So when we speak to the bus operators in Johor, for example, the operator also mentioned that there's lack of bus driver because there are certain regulations by the governments that the bus drivers should be citizens of the countries, and they can't really employ foreigners to actually work as a bus driver. Okay? So of course, in terms of the accuracy, the scheduling, the service quality is actually not so good, compared to the developed countries. So, for example, if the bus driver call in 6, and then the bus service may be disrupted, and especially for those serving in the rural areas. So what we did actually is we partnered with a bus operator in Johor just to test service routes between Kulai and Johor Bahru. So we were working with a very small bus operator in Johor that doesn't have any software infrastructure in place. They only run the bus fleets. So it's a very competitive route actually between Kulai and Johor Bahru. There are many bus operators. There are also free buses provided by the government. But all of these buses, majority of them, they don't have a software infrastructure to provide estimated time of arrival. So the bus drivers, the bus operator also mentioned that it's actually quite expensive for them to invest in the infrastructure. For example, to install software system, cloud systems, or even GPS real-time systems for bus fleet tracking and bus arrival information. So this is the second versions of the implementation that we actually worked on or deployed. So we actually use IoT-based systems that use Bluetooth beacons as the way or methods to detect bus at the bus stop, and we also use the Raspberry Pi devices connected with 3G connectivities. And then with the Bluetooth chip on board the Raspberry Pi, when the bus arrived at the bus stop, we were able to detect that the bus actually arrived at the bus stop. Then we can then track, in some granularity, the location of the bus. Now, of course, we'll need a cloud platform to actually process the data and then provide the analysis. So this is the first step towards data collections, and later on, we can then use the data collected to actually perform analytics or even bus arrival prediction in the future. So this is the architectures that we actually implemented and deployed. So we actually, as I mentioned, we only experimented with one bus service route between Kulai and Johor Bahru. So we actually fitted a Raspberry Pi at the bus stops or even some shop houses along the route, right? So that when the bus passes by the bus stops, Bluetooth detection will be able to detect, the beacons we put inside the bus itself, right? So this actually alleviates, the cost investment by the bus operators, because we just need to put a Bluetooth beacon inside the bus instead of installing a GPS device on the bus together with a 3G connection that constantly send a location update to the cloud services, right? So so we have a Raspberry Pi deployed at the bus stop, and then the bus stop location will be detected if the bus is in proximity, and then via the 3G connection, we send to the cloud for analytics, right? And at the same time, we can then, compute or even analyze the bus arrival time along the route in the future towards the destination along the service route, okay? So we also developed a simple mobile app, with the mobile, with the map illustrating the location of the bus stops, the estimated arrival time. And of course, then there's no funding for this project currently, and that's why we actually rely a bit on the Google advertisements to do it. But I think it's just a prototype that we wanted to experiment, an alternative way to do data collection, because some of the GPS traces may not be available for us to actually analyze the data, because I think most of the bus operator will claim that data is private and that they do not want to share the data with us. So for the field trial and deployment, this is actually a bus stop opposite the Kulai Hospital, in Kulai. So we fitted a Raspberry Pi here, right? And then we actually had to rent a power supply from the shop at the bus stops. Of course, we equipped with the 3G connectivities, and then that will be able to detect the bus when bus arrive. So if you look at the video here, just to give you some sense of the accuracy of the bus arrival time, the user can actually check the mobile app to check when the bus will arrive. but we didn't actually manage to do a info panel at the bus stop because this will require the cooperation from the city councils, which we haven't really got a chance to speak to them. So it's actually a field trial deployment together with the operators in this case. So if we for this particular deployment, we actually only fitted 3 Raspberry Pi. So one before the Pulau final terminals, and then one at the Johor Bahru bus station, Central Station, JB Central. So we actually fitted in one of the grocery stores or convenience store, and then one in the middle, right? So we ideally we should actually fit most of the Raspberry Pi along the route so that we have a more accurate location detection of the buses. But I think it takes time to actually speak to the owners or city council to fit this for deployments. So we also tested a bit on the in terms of the detection range for the buses, for the Bluetooth beacons, right? So depending on the transmission power of the beacons that we put inside the bus, it's actually quite accurate for the detection. So we can say that, we can actually detect the beacons about 90% and above for distance which is less than about 10 meters. So which means that we can detect on this side of the road as well as the opposite side of the road. Sometimes also depending on the speed of the bus, right, the drivers, and also whether the bus driver will stop at the bus stop. So if the bus driver stops at the bus stop, then it's actually quite easy for us to detect. But if the bus driver behave normally, for the upcoming so we can also do crowd level detection on the bus as for example, right? So of course, the challenges we face. I think we are looking forward to counsel with the bus operators, with also researchers. So maybe we do this together in Malaysia or in ASEAN. So thank you for your attention. Forward to your questions. Thank you.
Thank you, Mr. Ceylon Chok, for the interesting presentation. And it's time for us to have questions, please.
Okay, thank you, Dr. Ceylon. I think quite interesting. You know why? Why it is interesting? Yeah, because you are from the University of Singapore, and then you are trying to solve the problem in Johor.
Yes, from Johor.
Okay, University in Johor.
Actually.
Oh, in Johor. Okay, I think this work is very good. And, work together with the municipal. They will pick up. Maybe and you. If they really good, they can. I think maybe we can, because you are you have no collaboration yet. So then maybe you can work together with. Sure. Maybe we can have a matching grant if people, we can.
I also graduated from UTM in computing science. So it would be good to collaborate.
I took very interesting. It's very interesting. Maybe we can contact me. I can. Yeah. This one involved. I think we have to work together with the municipal, council. No point. Yeah. Yes. Okay. That's my question.
Thank you very much. Thank you.
Thank you, Professor Abu Samad. We will success some cooperation. And we have some times for question, please.
I have also a question. My question is, are you actually creating this project from scratch?
Yes, actually, we started with a crowdsource mechanism.
Because,
so that time, we actually
because there are a lot of existing companies and marketing solutions, market solution. Like, for example, I work with IVO traffic technology as I was at UTM, the computer science. They also have some kind of solution for this one, right?
Yeah, sure.
I was also in from 2011 until 2017. So
Yeah, I left already. I think
UTM, you mean?
It was until 2001. Yeah.
Dr. Tony?
Break. Yeah.
Oh.
Beg your pardon?
You said you were working in UTM from
in computer science 2011 until 2017. Professor Wanasya is a good friend of mine. Okay. I have another question. So you mentioned that you work together with a bus operator. May I know which bus operator you're talking about?
So we work with the SNS.
Oh, SNS, not Handal Indah, right?
No, Handal Indah has their own mobile app, and they also have
Yeah, that's why I knew they have their own solution.
and all this, they have their own systems.
Right.
But whether they're willing to share the assets, we are not sure. So we're actually targeting a very small operator that don't have infrastructure, and this will be able to provide, estimation for especially the rural areas where all the smart operators are working.
Yeah.
And then it's actually quite low cost for them, so they don't have to fit all the 3G SIM card on buses, and they have to pay it.
All right. Very good. Like some collaborator, I would also be interested in this because I work with Aachen in Germany. The company is called IVO Traffic and Technologies, right? Okay.
Sure.
Thank you very much.
Thank you.
Thank you.
Thank you, Professor Tony Awar.
Yeah, thank you.
It's time.
I have
once
one.
again, Dr.
Can I have a question?
Yes, please.
Very small or very short question, please. Professor Hideyuki, please. Very short one.
Yes, very short question. Thank you for highlighting your model. It's very interesting. However, I think it's Bluetooth is one way you use. Do you use another way for transmission? Because sometimes the transmission is not very consistent. Let's say, for example, Zigbee or another way you can use because you Raspberry 3, right?
I think currently Zigbee is not supported on Raspberry Pi, right? So the Raspberry Pi itself only support Bluetooth and Wi-Fi. Yeah, so I think that's why we didn't actually use Zigbee. Zigbee will need a hub actually to do it. And there isn't any Zigbee devices that I can actually put on the bus. I think Bluetooth beacons are pretty much available from the market. You can just purchase off the shelf and fit it onto the bus easily. That's the reason.
Okay. Thank you, Professor Hideyuki, and
Thank you.
Thank you,
Thank you,
Dr.
everyone.
Silong
Thanks for your insights and
very
opportunities
interesting
for collaboration.
presentation. And now I would like to invite Professor Hoàng Văn Phúc from Liquido University of Vietnam to present the AI-powered comprehensive cyber-physical security for smart cities. Please.
Yes, thank you, Professor Nguyễn Thanh Thủy. Now, can you see my slide?
Yes.
So I would like to present our proposal in the project with the title IPOS mean Artificial Intelligence Power Comprehensive Cyber Physical Security for Smart City. I present it on behalf of my group with the partner from my university, from DNU, from University of Electrical Communication in Japan, from Songkla University in Thailand, and the NTU and NUS from Singapore. So I would like to talk about the background for our proposal that recently, so the security issue against IoT, the attack against IoT device have become a serious issue in Vietnam and other countries. So in the report from Vietnam, that 70% of IoT devices in Vietnam are under vulnerable, right? So so at the developing country, other country in ASEAN is facing the same problem. So the target of our proposal is that we propose a solution for the hardware security issue in the IoT system for smart city, and we like to contribute to build the research capability of the ASEAN institution in the field of hardware security for IoT. So we would like to establish the link for the researcher, and also not only in ASEAN, but also with the partner from Japan, from Europe, for the hardware security field. So as you know that in the IoT system, the number of nodes is very huge, so that the security and privacy is very important, especially now in the time of COVID-19 pandemic. So the cybersecurity issue become more serious, and the recent development of the artificial technologies and techniques can provide some efficient tool for hardware security, implementation, and also evaluation. So this is the general architecture for the secure IoT system, from the physical level, like the hardware design for IoT nodes, and in the gateway level, and also in the application level. So in this proposal, we would like to implement the security solution for multi-level, like from the hardware to the gateway, like ADS or anomaly detection, and in the application level. So for the physical designs in the IoT node, we already designed some parts. So it is the general structure for the secure IoT node design. We combine with some type of technique for the hardware security, like in the hardware design, we combine some cryptography design for, and the PUB design. PUB means the physical unclonable function. It's used for certification in the IoT system, and we use some open source secure MCU for the control of the system, and we combine with the TE. We mean the trusted execution environment for the IoT platform. And we have achieved some preliminary results. For example, we have developed the deep learning techniques for side channel attack to evaluate the security level of the AES cryptography 4. So we have published in the Isdbt APC case in last year. In this technique, we propose some reprocessing technique to reduce the number of required power trace for attack. In this attack, we use the power consumption information to attack the hardware AS4. So by using the techniques, we can reduce the number of power trace. And in the gateway level, we have research on the intrusion detection system to deploy the detection method in the gateway level. So because the IoT system is implemented on the very low cost and low complexity and low hardware resource system, so that we would like to provide the lightweight method, like we try to reduce the number of parameters and number of operations in the detection methods by we do pruning, like we adjust the network, the machine learning networks to reduce complexity, So, for example, in this pre-publication, we have already reduced the number of parameter and operation by 90 times, but we can get the same performance with the other techniques. And in the next step, we will implement this method in the hardware that we can employ for the IoT system. And also, we already developed the method to detect the hardware chosen in the IoT system. We very familiar with the concept of software chosen, but in the hardware design, the chosen can also be inserted in the design. So, for example, we had the elements with the chip, the original chip. We call the clean chip in the left side, and the chip with hardware chosen in the right side. We insert the hardware chosen. Hardware chosen can store the information, and we can leak the information from the system, and then we use the electromagnetic probe to do the scanning over the chip surface and get the side information. And we do some experiments here like that. We have the security evaluation board. We get the result that we can detect with the accuracy of 95%. And the next step, we can apply some deep learning techniques so that we can improve the efficiency. And also for the IoT node design, we have implement the PUB in FPGA and the secure IoT node design with rich file processor with research from Conca from EVC. We already make some chip for this methods. And for the merits of this proposal, that we can provide some guidelines for using the deep learning and AI for hacker security and IoT system, and we try to contribute to the standardization for the system, so we can publish some journal together. And for the impact in ASEAN countries, so at the developing countries, so the requirement for IoT device and system become very large now. So we will employ the research result in the IoT. So for the methods, we will combine with the theory method, and then we use the simulation, and then implement in hardware, and we will employ in the real system. So for the content, we will divide the process into 4 packages, like the server management, survey and subscription, and demonstration. And we also can get the funding from Lebanon Technical University, and we have already collect with many partners from Vietnam, from BNU, from NICT, and EVC in Japan, in Thailand, Singapore, and also in UK, from some ministry from ICT in Vietnam. So we hope that we can get some more collaboration by this forum. Thank you very much.
Thank you, Professor Hoàng Văn Phúc, for presentation. And it's time for us to have question, please. I have a question.
Yes.
You are concerning the DL, the deep learning based SCA, and also the deep learning based IDS, and then you are concluding with hardware Trojan detection. What is the connection between the two issues presented above and the hardware Trojan detection concerned by your project?
Yes, as we have seen in this structure, so in our proposal, we would like to do multiple techniques for multiple level in the IoT system. For the hardware chosen detection technique, we will apply in the physical level, like we will scan and detect in the hardware module for the IoT system. And for the IDS and other higher level, we will deploy. Okay. So we will attach the. We will use some algorithm in the gateway level to detect the attacks. And for the hardware chosen detection, we will employ in the physical design. So we employ in the device the practice the device. Yeah.
Okay. And what does it mean SCA? SCA, what does it mean? Security?
SCA means the side channel attack. It means that for the
okay, side channel attack.
Side channel, because they can use some other channel like the power consumption, sound, and some EM. Yes.
Thank you. You have we have some questions, please.
Yeah, I have a question. Hi, Prof. I wanted to ask, you are running the side channel attacks, and are you trying to use a TEE to actually do the protection? And did you actually run the side channel attacks on TEE itself? And what is the preliminary insight? Whether TEE is sufficient enough to protect against side channel attacks?
Yeah, actually, now we do the two independent research component. SCA and TE. Now we not yet employ the side channel attack resistance in TE. Just now we employ TE the basic TE design. So in the next step from now we discussion with the Kongkha platform EVC to combine the SCA prevention with the TE. So I think it's your question is very nice question. So we will employ this one in future.
Will you also be considering SGX, Intel SGX?
Sorry,
Intel SGX.
Intel SGX?
Yes. So it's also an example of TE, but it's provided by Intel.
Yeah, we have concerned some TE architecture from NTM or other providers, but now we just use the baseline TE. So we not, because we use the rich file processor, not the processor from Intel, so that we use another platform.
Thank you so much, Professor Hoàng Văn Phúc, for interesting presentation.
Yes, thank you very much.
Thank you. And now the last presentation in our session, I'd like to invite Dr. Didi Rosliyadi from Indonesia to present a trusted multimedia content protection scheme based on hybrid watermarking and blockchain model. Please.
Okay, thank you very much. Thank you. I would like to present about the trusted multimedia content protection scheme based on hybrid watermarking and blockchain. This is our researcher team. I'm from Research Center for Informatics, National Research and Innovation Agency, and our team from Japan and from Darussalam and from Thailand and from Taiwan. And so I would like to introduce about introduction. For the security, this is the critical in the transmission of digital products and transaction-based service by internet. And so the security issue in this digital product is confidentiality information, authenticity, integrity, and authority, etc. And so for digital watermarking and blockchain technology, this is a new technology that will protect the integrity of digital information and safeguard intellectual property rights. And then what is the digital watermarking technique? So I have three kinds of the digital watermarking for the copyright, and so for the access control and authentication. And for the copyright, we can to use this to protect the copyright of the digital product. And so in the access control, we can to protect the access control of the digital product. And the third is for the authentication. We can to protect the authentication of the digital product. And so the often we can to get the digital watermarking technique for robust, private, and semi-private. And then correlated with the blockchain, we have the blockchain and blockchain technology. In the blockchain, this is an essential and an emerging technology as an open distributed ledger or database that record or transaction details. This is the blocks, and so its record is tamed and correlated to the previous blocks and robust to modification of data and to be trusted for transaction between two entities in an efficient and variable manner. And then essentially blockchain is redefined to anything that requires transaction verification or a signature leading to authenticity and trust. And so from the reference one, they propose a novel watermarking based multimedia blockchain framework which uses a cryptographic hash and image hash to decipher retrievable original media contents. And so we use the blockchain technology on a distributed ledger technology domain allowing transaction to function in a decentralized system, such as allowing transaction to be verified without a central organization to process the transaction. And this technology has main potential usage, transferring any digital content. And then this is the feature for the privacy data and blockchain using homomorphic encryption for image watermarking. So for example, we have the client, and so there is a secure watermarking. We use the encryption. From encryption, we have the blockchain network. This is the blockchain network. And so we have the authorized provider. They can to the watermark provider and then have the encrypted watermark. And so in the blockchain network, we have the smart contract and we use the cloud server. And so we can the last step for this for the process is the description process. This is we get the data and information where the client is receiving. And then for the media contents, we have the this is the artwork with the right information, such as author, date, location, right order, etc. And so all the artworks, right information are included in the data. We use the hybrid of DCT and SVD. And so for the third process, we have the process that apply the DCT. And so for the fourth step, we have the extraction process. And so the last step is perimeter result. And then this is the illustration for the multimedia blockchain process. We have, for example, we have the host image. So we use the process for compressed sensing. And so we use the invisible watermark image. We have in the digital watermark technology, we have two types of the watermark. This is the invisible and visible. And we have the multimedia blockchain for the media transfer. After that, we obtain the watermark image. So we have the updated media database server, and the last media database server with blockchain. And so, what is the target and implementation? We have the first. We want to get some international journal. We have the two scientific paper, and so the second is international proceedings. Perhaps we got the two scientific paper, and so we also get the prototype of security system for an application security system. And then the research method, we have four steps in this study. The first literature study for the done to obtain corresponding information on digital image watermarking, DCT SVD method, and blockchain model. And so the second step is analysis. In the analysis process consists of grilling the users about what the current system does, and so what extra features they want in their new system, and what constraint the new system must satisfy. And so the third process is the design process is done, and to get a robust DCT SVD watermarking. And so the last process, the process, to obtain the performance of the watermarking proposed scheme by the DCT SVD method based on the blockchain model. And then we use the formula in the DCT and SVD. We have the mathematical modeling for to get the robust for the algorithm in the hybrid DCT SVD. And then this is the illustration for optimized hybrid DCT SVD computation. Over the extremely large image, we have the finding the proposed computation will be extremely faster than the convolutional for the extremely image. We use the sums image from the benchmarks for Lena and etc. And then for the leverage resources and participants, we have the sums researcher for some countries, like from Indonesia, Taiwan, Japan, Malaysia, Thailand, and Brunei Darussalam. And so we have to for the research area, we have to some researcher from the countries, like from the Japan, from Professor Terano from the system security, and so from the Malaysia for the data security, and from Thailand from security framework, etc. And so for the budget explanation for the our research for the joint equipment and joint workshop, and then this is the reference. Okay, thank you very much for our presentation.
Thank you, Dr. Didi Rosliadi. I would like to invite to have a question, please.
Yeah, I have a question, please.
Yes, please.
Okay, Professor Didi.
Yes.
If I understand it correctly, so you want to do something like digital image copyright protection. Is it correct?
Yes, yes, right. But we use for the digital watermarking.
Okay. You know that there is this technology now. There is this solution for that, which is called non-fungible token.
Yeah, IFS.
NFT.
And yeah, MS.
Yeah, and it is using also blockchain technology.
Yeah.
So how do you want to compete with this technology? Because has been there like 2-3 years already.
Yeah.
And has been used by a lot of people. Even there are certain NFT products which cost already $millions or something like that. So it's already established, yeah, as a standard for digital image protection.
Yeah. Thank you, Prof, for your suggestion. In our team, that we want to get some improvement for the algorithm. Because I think for the algorithm is we can still to improve every time, and so it is defend to the for the intruder or attacker, and so we in the result for our research is to get the algorithm. The name is the robust algorithm. Like for the in the simulation, maybe we can to check the like for the image in the digital watermarking, like for the PSNR values, like the peak signal to noise ratio or the normalized correlation coefficient. But in our research that the main result is to obtain for the robust algorithm for that. And so for the application, maybe we can to implement it for the NFT or another application for that, like that, Professor.
Okay, but still using blockchain, right?
Yes, right.
Okay, thank you.
Okay, welcome.
Could you have some more question, please? We have some minutes for question and answer.
Yeah, I'd like to ask, what is your application that you have in mind to apply for this research?
Mm-hmm.
Okay.
Yes.
Thank you. Yeah. Okay. And so if I want to describe about our research, I discussed it with our team that I think this research is correlated with the scientific contribution, and so I get the algorithm, the robust algorithm, and so I think for the application, like for the digital watermarking application, like for how to protect the multimedia data, like image or video or audio. And so we can to develop some application like in the Play Store and like that. And so we can to for the society contribution, we can to develop from the scientific contribution, we can to develop in the implementation for that.
Yeah, that's right. Yeah, would it be possible to include the stakeholder into your proposal?
Yeah, I think in like in Indonesia, because our research area, like from the data protection, we have some stakeholder for that, for the production agency in the multimedia, like for the copyright and authentication, and for the sounds like in the for the stakeholder in our research.
Thank you. Yeah, you should. I think you should include them. Yes, thank you.
Okay.
Thank you, Dr. Didi.
Yes.
Rosliadi for interesting presentation. And I would like to say that we finished our session. Thank you.
Thank you very much, Professor Gwen Tantu and our speakers for this session. So it's time to start the afternoon sessions. So I would like to move to session 4, ICT for health and welfare. So I would like to ask the session chair, Dr. Alisa. Can you hear me?
Yes, I can hear you. Thank you, Imoto-san.
Please.
Yeah, okay, I'll start now. So good afternoon, everyone. My name is Alisa Kongton from NICT, Thailand, and it's my great honor to be your chairperson for today's afternoon session. First of all, I would like to ask everyone to please turn on your camera so that we can have group photos together, please. Okay, thank you very much. So for this afternoon session on ICT for health and welfare, we got 3 speakers from Indonesia, Thailand, and Malaysia. So each speaker would have 10 minutes for the presentation and 5 minutes for Q&A. The secretariat will help ring the bell. If you hear one ring, it means you still got 2 minutes to finish up your presentation. If you hear 2 rings, it means your presentation is up. You have to finish your presentation by 2 rings. And then after that, we have Q&A. And if you hear several rings, it means your Q&A sessions is up. And then we have to move on to the next presentation. So without further delay, I would like to invite Dr. Jela Budiman from AI Comms Telecom University of Indonesia to please present his presentation on the topic of machine learning and compressive sensing for intensive care unit biomedical recording activities. Please.
Actually, this is about my research, and I'm going to have it with the project machine learning and compressive sensing for intensive care unit biomedical recording activities. The outline of my presentation is about the background and then the type of the patient's biomedical signal, and then the compressed sensing and why we use compressed sensing in these applications, and then the CS requirements and complete stage of the compressed sensing, and then how can we combine machine learning with this compressed sensing. This proposal actually according to the reason that from the ICU there are several biomedical signals produced, including video and audio, and then all the signals are monitored and recorded for hospitals documentation, and the status of the patient is transmitted to the nurse center, and then also we need storage for saving all the signal, all the biomedical signal, and then also we can predict the patient status according to the biomedical record. And then when the medical specialist is absent in the ICU, and the nurse have to take treatment to the patient, the nurse can take the decision what kind of treatment to the patient by the result of the machine learning in this application. And then also the specialist can read the patient status real time from remote. The status contains the real-time biomedical patient's data and the status prediction of the patients from the machine learning. Yeah, this is the type of the signal, the biomodal signal that produced in the ICU that will be analyzed and will be compressed by compressed sensing, and then after that it will be decided in what kind status of the patient from this biomedical signal. We can now there are ECG signal and then ABP signal, CVP, and then SpO2, heart rate, and audio and video of the patient's condition. Yeah, actually the compressive sensing or compressed sensing is a method to reduce the signal by a simple equation, yeah, in a matrix equation. So we can have a signal with with smaller size, but we just take it into one equation. So actually this compressive sensing will replace the conventional encoder, conventional compression encoder, and it is more simple than the conventional encoder in the encoder. But actually the reconstruction of the compressive sensing is more complex than the decoder of the conventional compression. But actually in this case we can make sure that the reconstruction is not mandatory to implement in this application. Why we use compressive sensing? Yeah, actually this is low complexity at encoder, and then it will become a fast processing encoder, and then it does not need much bandwidth. So we just need a much lower bandwidth, and then the reconstruction of the compressive sensing is not mandatory, since there are many machine learning which will decide the status of the patient of the compressed signal, and then the performance, the quality at the same subrate is not too different with the conventional compressing technique or H264. Yeah, we can see that the conventional compression framework and compressed sensing framework is different, and it is especially different in the encoding. That in the encoding, the compressed sensing is much more simple than the conventional compression framework. This is the requirements of the compressive sensing. We must have a sparse signal input to be the signal input to the compressive sensing. So the compressive sensing will efficiently compress the signal. And then we must have a restricted isometric property as a requirement to the CS. So the CS will have an efficient method in the process. And then we must have a compressible signal into the input of the compressive sensing. So with the compressible signal, the compressive sensing will have a very much effective performance. Yeah, this is the illustration of the sparsity, the signal, and the two-dimension shape, yeah, or image. With the DCT 2-dimension, we can see that the signal is changed drastically with the many variations of the signal will be changed to only a little fluctuation in the beginning only, but after the beginning and much more the length of the signal will be close to zero. So this is the sparse condition of the signal, and this is the something that the compressive sensing needs. So compressive sensing will have a good performance with this sparse signal. This is the complete stage of compressive sensing from the patient history, and then we do pre-processing, and then we do a sparse forward in the signal, and then we do CS acquisition, and then the signal is transmitted to the server, and then in the server we can do the CS reconstruction, to have a signal back, and then sparse reverse, and then post processing. So we can calculate the data back. This is the several reconstruction algorithm. This is the requirements of CS and machine learning. There are 3: similar size compression, and then good quality reconstruction, and good accuracy. And this is the scheme that I propose, about this combination of CS and machine learning. This scheme, the second scheme, is the scheme that more efficient than the first scheme, because we do not have to do reconstruction in CS, but we can do compression filter before we use machine learning to detect or to predict the status of patient. So we can predict the status of the patient to a couple of hours or maybe several days before the time. So we can predict. So from the prediction result, the nurse or the doctor can do any treatment to return the patient status to the better status. This is the architecture of our proposed application. So from the patient, the biomedical signal is compressed by compressive sensing acquisition, and then it is transmitted to the server, and then from the server, the machine learning will detect or will predict the patient status, and the current and the predicted patient status is transmitted to the doctor, and also it will make decided treatment. So the nurse, when the doctor is absent in the hospital, the nurse can do the future treatment to the patient. This is the conclusion. So we hope that our propose will help the patient, will help the nurse, will help the doctor. When the doctor is absent in the hospital, the nurse can do treatment as the result of the machine learning. So the patient will be better from the treatment immediately from the nurse when the doctor is absent in the hospital. I think it's enough from me. Thank you very much for your attention.
Okay, thank you very much. Now I would like to give the floor to the audience for questions and comments, please. Any comments? Any questions? Okay, I'll start first. Okay, I got one. I saw Dr. Abu Shama, please. I saw you raise your hand. We couldn't hear you. Sorry. Still, I can still could not hear you, Dr. Abu.
There is no sound.
Still cannot hear.
Okay, I can go first. Can you hear me?
Okay, yes, I'll move on to Professor from UTB, Brunei, please.
For the system, right, since it is applied to medical domain, this is very sensitive domain. And I think when you build the model, the generality of the model and the quality of the model is very important for the end user to use. I think it's a big challenge. The other thing is that when you do this, it must be a lossy compression, right? It will be lossy compression. And I would think that the way you compress, it had to be domain dependent. It had to be application dependent. because when you compress something and you get it back, the data that you get it back, and if it applies to a certain domain, it look very likely that it will be particular to that domain, if it works well for that domain. Now, if something changed along the way, I find it hard to believe that your model will be general. Do you think that makes sense? The generality of the approach. I would question that. I would question two things. The first thing is generality of the approach. Second thing is that how can you ensure the fidelity of the model to doctor? Because they are very particular about this.
Yeah. Okay. Thank you for the question, Prof. Yeah, the reliability of this model actually is already proved by several research. Yeah, actually, in our several research about this model, we also did the acquisition of compressive sensing, and then after that we do directly compression feature, and then after that we do directly in machine learning. There is training and there is testing, and we have good performance.
Okay, I also have the question from Dr. Abu Shama in the chat, and Dr. Abu Shama asks, how are you going to implement your project with your collaborator?
Okay, thank you very much for the question. Okay, actually I will propose my project to my partner. Actually, I have a partner in the hospital, in the National Hospital in the Bandung, yeah, Rumah Sakit Hasan Sadikin. He is a doctor there, and we have a good relationship about the project. So we can start this project with her, and then anyone want to join this project. Thank you.
Okay. The time is up for this first. So let me move on to the second presentation. May I invite Dr. Wetranugra from Thai Nishi Institute of Technology of Thailand to give the presentation on No One Left Behind, automatic screening of rare and neglected cancer by medical image analysis. Please.
Okay.
Yes.
Can you see my screen? Okay, thank you. Good afternoon, all participants. My name is Pikun Wetranugra. Today, I would like to give you the presentation under the theme No One Left Behind, an automatic screening of rare and neglected cancer by medical image analysis. Our team member research consists of both the academic professor and also the researcher from both Thai and Japan countries. First, I would like to give you some past and ongoing research background with the medical image. So the first one is the fundus image. This one, we use the fundus image to detect the glaucoma in the eye. Our motivation for the glaucoma in the eye because the progression of the glaucoma is very fast. If we didn't have the treatment within 24 hours in the advanced state or severe state, so it can be lead to the permanently blindness of the patients. So this is what we can detect from the glaucoma in the optic nerve head, the size of the optic cup and optic disc, and the ISNT rules. The second one is the HRCT lung images. This one is used a special technique called breath hold technique. Will generate 3D model with the end expiratory and end inspiratory when we breathe in and breathe out, and then we be able to generate the 3D model of it. We can generate the motion of the lung when it's expanding and shrinking, and then we can detect the emphysema, COPD, air trapping diseases into the 3D analytics. The next one is the malignant cells, which is the cancer cells. This one is the cancer cell in the advanced state when the cancer is already spread in your body already. So we get this cell from the fluid in our cavity in our body. So we can analyze the shape, the size of the nucleus, that is the normal cells or the cancer, and use the deep learning and CNN to classify this thing. Next one, the fourth one is, you can see this picture is our cornea. So this one we try to do the research by detecting the color of the cornea for the blind people. We have the contact with the Thammasat University Hospital to detect and collect all the data and get information with the generating the color modeling. And then the challenge point of this research is the lighting condition and also the calibration technique of the color model. So here it is. When we, the upper one is the blind people when they have the gray color. So we try to matching the color of the eye here so we can paint the ink into their eye. Similarly for both left and side color. For our ongoing process, which is working with the Japan Advanced Institute of Science and Technology in Ishikawa, Japan, is the detecting the main pancreatic duct model. As we know that the pancreatic cancer is very rare, so it is very hard to get the case study from the hospital. So we have to create like a jelly model like this and put the tube inside, and it's shown as the pancreatic duct. And we will use the ultrasound to scan and get the model and learning from this image to the deep learning model. So let's see for the pancreatic cancer, it is the 5th ranked worldwide of the cancer in the world and 4th ranked in the US. In Thailand, even if it's not in the top 10 rank, but is the mortality rate in Thailand is very high, up to 99.13%. It just means that the patient, when they have the pancreatic cancer, within the progression within 6 months to 5 years, the mortality rate is almost 100%. So it is very serious and it's very important if we can detect this disease before it's progressed in the advanced stage. So I will give you some brief introduction of the anatomy of the pancreatic cancer on the right side here. The yellow one is our pancreas located in the middle of our body. So it can be separated into 3 parts, the head part, body part, and tail part. So, and it's connected to the duodenum, which is our colon, which is related to our digestive system. The green one is gallbladder, and the green line here is the common bile duct, which is connected to the duodenum as well. Our challenge point on the early stage detection is the size of the cancer or tumor is very small. Sometimes it's less than 1 centimeter, and it's also in a deep layer or in our body. So it is one challenge point that we cannot just use the ultrasound image to detect this one because the size is too small, and there is no early warning sign. The early warning signs can be just only when the lucky patients have the tumor at the head part of the pancreas. So they will have some effect with the common bile duct, the green line that I showed on the picture previously. The effect can be like our skin will be turned yellow like that. The next trend is using just only the imaging sometimes is not enough. Just only one imaging, so we have to combine all techniques together. And sometimes they also need to use the tumor marker to analyze this as well. So our aim of this project is to generate the automatic screening for the rare cancer, especially in Southeast Asia countries. And we focus now on the pancreatic cancer to expand the capacity of the current diagnosis of the rare cancer by integrated all multimodal sensor together. This is the example of the medical image in both 2-dimension, 3-dimension, and it can be dynamic and static images. From the CT scan, MRI, EUS, they have their own benefit for each technique. Then we try to combine all these techniques together and get the finding to create the multimodal integration to build a unified platform that can maximize the detection rate under the limited resource in Southeast Asia country. Also the case of the pancreatics as well. The plan for connect this project. So we are open for the medical image and the signal team as well, because in the medical imaging is consists of both structured and unstructured data. Just only the biosensing or some signal from the ultrasound can be used as the analytics information as well, and connected to the AI technology to create the support system in the healthcare and be able to establish the sustainable international relationship between Southeast Asia countries. And in the end, we believe that everybody's life is very vital. So everyone should have a life that living up to 100 years and beyond. So thank you very much for listening. So anyone have any questions?
Yes, thank you very much for your presentation. We have a question from Dr. Tony.
Yeah.
Please.
Okay. Thank you for the opportunity to ask questions again. So, Prof. Pikun,
Yes.
from Thammasat University.
Yes.
This is from Tainichi.
Tainichi. Well, I was working at King Mongkut, North Bangkok for 4 years. So, okay. Anyway, the question is, how do you get the data? Is it a real-time data or is it from public domain data or something like that?
Right now, we are trying to search for the open source data as well, but now we have the connection with the Thammasat University Hospital, and the medical doctor can provide that information to us, but maybe we have to wait for sometimes because the pancreatic cancer is very rare and it's very hard to get that information from all patients at the same time.
Yes, because of the privacy policy or something like that.
Yes.
Okay. Can I ask a bit further? How many data do you have already?
Now we have the video recording from the ultrasound, but that one is the one that we use the jelly box. The one that we generated synthesis by using the jelly box as I showed on the slide with the Kanazawa University. For the real images, we have some of the CT image, but
how many? How many CT images?
Around now is around 20.
Okay. Thank you.
Because the case in the hospital maybe just only around 20 cases per year.
Yeah, thank you very much. Now I understand. Thank you.
Thank you.
Any other comments or questions from the floor, from the audience? Okay, yes, please.
I like to give some comments.
Yes, please.
The success of the model must depend on the quality of the input, correct? Must be correct. Right? So in that case, right, if the process that can take advantage of the image or some other input, which might be into the 3D, that should enhance the quality of the model, right? So I think that should be what we are looking for.
Yes, it's very important. Thank you for your comment.
Okay, I have one question from myself. I believe that another important part is, for the doctor, the expert that can help you tag or annotate your data, to be able to train your AI model later. I think that's another one that you should, find. Like you said, you have collaboration with the Thammasat University Hospital, and then I think you should pinpoint or, get together with a doctor who can help you, annotate the data, collect more data, and then help you, with the training of the AI model. So that's just my comment.
Yeah. Thank you very much. It's very informative comment for me. Thank you.
Any
Thank you.
other comments from the audience? We still got times, I think. Okay. Maybe not. Okay, so I'll just ask another one more time, one more question. So you like the title is rare and sorry, I forgot. So yeah, but then you want to first specify on the pancreatic first, right? But then
Yes.
maybe later on you have the option to expand to another rare and neglected type.
Yeah.
Okay, but right now the data that you have is for the pancreatic cancer.
Right. Yes.
Okay. Okay. Thank you very much.
Thank you.
Okay, I think then we can move on to our next presentation. So thank you, the presenter. So for the last presentation of our session is going to be presented by Associated Professor Dr. Nohana Assad from the National University of Malaysia. And the title is going to be Alpha Prototype Face Mask with HEPA filter and oxygen sensors. So please, I'll give the floor to you.
Thank you and good afternoon, Dr. Alisa. Dr. Alisa, can you hear me? Okay.
Yes, I can hear.
And yeah. Oh wait,
But I didn't see the
sorry,
slide
I
yet.
forgot. I forgot to share mine.
Yep. Okay, now I can see your slide. Okay, yes.
Okay. Okay, let me start again. Okay, good afternoon, Dr. Alisa and all panels. My name is Nohana Arsad and I'm from the National University of Malaysia. And my project title is Alpha Prototype Face Mask with HEPA filter and oxygen sensor. With my team member, Prof. Jennifer Chua from Mapua Institute of Technology, Philippines, and Ms. Indra Herman from Institute Technology, Bandung, Indonesia. This is the outline of my presentation, which consists of introduction, problem statement, objective, methodology, and finally conclusion. As we all know, for the past 2 years, our life has been overwhelmed by COVID-19. And COVID-19 is a coronavirus disease that appeared in 2019, and the case was first detected in China. It's also identical to severe acute respiratory syndrome coronavirus. It is a type of airborne virus that can spread through small droplets of saliva in a similar way to the cold and influenza and transmit as we speak and spread. In addition, it can also be spread indirectly via surface that has been contacted by bodily fluid of someone who is infected with the virus. COVID-19 brings many impact on global economy and society, causing sudden halt in business operation, disrupting supply chain, and inevitably causing job losses. In order to contain it, World Health Organization recommends following certain procedures such as wearing face masks, social distancing, sanitizing hands, and always keep good hygiene. Therefore, a prototype of face mask with HEPA filter and oxygen sensor is to be developed, besides to make sure there is always sufficient oxygen provided when wearing face mask, and last, to prevent the virus inhaled by human when wearing face masks. For the problem statement, why do we need these prototypes? This is because, according to the graph, we can see that the number of COVID-19 cases still running at high, although most people took vaccination. In addition, local manufacturers prefer exporting their face masks to other countries to make better revenues, causing short of supply. statement number 2. Besides, medical worker needs to wear multiple number of face masks 7 days a week, 24 hours a day, which take a lot of clean masks and make a lot of waste. During the times of wearing it, evaporation develops inside the face mask, and this reduces the size of many respiratory particles happen in the face mask, which cause discomfort and suffocation. Lastly, for those self-quarantine people also need to wear face masks all day and need to check their oxygen level SpO2 every day. This is the range of blood oxygen saturation SpO2, which 95% to 100% means that red blood cells are well oxygenated and sufficiently transporting oxygen around the body. While if 91% to 94% needs to monitor closely, and if less than 90%, this will be dangerous and should consult with doctor. So next, we will talk about the methodology. This is the flaw of the mechanism of this prototype. By using HEPA filter to filter out the microparticle, viruses, and bacteria with oxygen monitoring system to make sure the blood oxygen saturation SpO2 is not less than 95% when we are at outside hospital or self-quarantine. For the HEPA filter is an abbreviation to high-efficiency particulate air filter, which with a great capacity to filter out the small particles such as germs or viruses. Besides, it can remove more than 99% of the particles from air that pass through them. In addition, HEPA filter is a good help for people with asthma, allergy, or those who suffer from respiratory problems. With an example of a product with air purifier with using HEPA filter, when air purifier absorbs the air, it passes through the HEPA filter and release clean air into the room. This proves that the HEPA filter is composed of a mass of randomly placed fiber, so it can easily remove pathogen larger than 0.3 micron. For the oxygen monitoring system, this system is planning to build up with Arduino and oxygen sensor, which we will use MAX 3100 sensor, which we attach at the ear loop to collect the oxygen level. The sensor is safe to use since its main application is for medical monitoring devices, fitness assistant devices, and wearable devices. This have 2 LED optimized optic and low noise analog signal processing to detect pulse and heart rate signal. So how this sensor works? When the heart pumps the blood, there is an increase in oxygenated blood as the heart oxygenated pieces. So by knowing the time between the increase and decrease of oxygenated blood, the blood rate is determined. So this sensor also can connect to Bluetooth system so that people can always check their SpO2 level when they wear face masks. Okay, we come to the last slide. The conclusion, I would like to conclude that the MAX 3100 sensor and HEPA filter will be used to build this prototype, since both of this material can be used to reduce the use of face masks. Help victims of pandemics can get medical help immediately when their SpO2 level is less than 95% and reduce the risk of by virus. But there is also a challenge in this prototype, which is classification of COVID-19 or other disease related with low blood oxygen level, such as heart disease. Thus, I end my presentation with thank you. Okay, Lisa.
Thank you. Yes, thank you very much. So now I would like to give the floor for the audience for any comments or questions. I'll start first while other are still asking later maybe. Just wondering, like the first one is this the mask with the HEPA filter? Is it already available in the market? Like is there the products that's already just combined, like using HEPA filter with the face mask?
Okay. Thank you, Dr. Alisa, for the question. Actually, we have a collaborator. For example, Indra for the ITP. She is in the field of additive material. So from there, we will build our face mask with the material, additive material to produce the face mask. And together with me, Prof. Jennifer also expert in the IoT, for example. And then we will connect the oxygen sensor with the IoT application so that everyone can monitor remotely their children or individual, freely.
Okay, so another question. When you say the IoT, the sensor would attach to the earlobe, right?
Yes.
Is that the place? Is that the place is good place to measure the oxygen? I mean, I use the oxygen measurement thing with the finger, right? Like I saw that people use it for the finger, but then with the earlobe, I mean, is that the best position that, can detect the oxygen level from the earlobe?
Yeah, from so far from the research, we have seen that or read that from the from many paper reported that we use the earlobes to collect the levels, the oxygen level, because normally we will put on our hands, right? So, but we will feel uncomfortable because we always use our hand to eat and then for writing. Meanwhile, for the earlobes, is because it's very easy to attach something like our jewelry, right? So I think it will less discomfort for the user.
Okay. All right. Are there any questions from the floor?
I have a question.
Yes, please.
I was a little bit interested in the system diagram after the statement from Dr. Norhana about using IoT and the oxygen sensor. So how do you connect the oxygen sensor and IoT?
Okay, so we have the Bluetooth. We will have the Bluetooth, and then it connect to our phone. And then for our phone also, we upload our data to the cloud, and then everyone can monitor their level of oxygen.
Okay.
So it's a smart device, actually.
Oh, via the smart device.
Yes.
Oh, okay. Okay. Thank you.
So currently, what we have, what we have now is face mask can detect how many germ on the face mask, and then so we are going to for the IoT, the system, the cloud, also ready. Just we want to integrate and then see how it works.
Okay. And how often do you have to clean the mask with the HEPA filter? Like, is it one time use, you throw it away, or you can reuse it, or you
yes,
can clean
for this
it?
one, yes.
You can
reuse it, yeah.
Oh, okay.
Because one of the pollution and waste pollution, because we can see that many face masks thrown away everywhere, and then it's a waste that we have to clean our environment with this approach.
I see. Okay. Any other comments? We still got a few minutes for the comments or questions or any input. Maybe I'll ask another one, like one last one for me. Just wondering, like, do you consider this, or like say in Malaysia, right? Do you consider this as the medical device? like say if you have it as a product, and I think say for example in Thailand, to be able to register as the medical device is a lot of process. You have to go through a lot of like FDA, the Thai FDA and a lot of things. So how about in your country, like if this is considered as the medical device, how long is the process, or do you know like the process? Is it hard or is it easy?
Yeah, I think it's a little bit hard actually, the process, because we have to get approval from many departments, and then but one of our collaborator now we are in a discussion with Institute for Medical Research Malaysia, and then they are testing the face mask that we developed, and then we are waiting for their response and feedback how this face mask can be used particularly for the frontliner, because they are the one who will use all this PPE, and to make sure that the oxygen for the frontliner also not less than 95%. Thank you.
Okay. I saw Professor Tony Anwar raised a hand. Can you just give a quick comment? Or
Thank you, Dr. Lisa from NICT. So, what is actually your product? I am still a bit confused, because oxygen sensor is there, IoT is there, cloud computing is there, face mask is also there.
Yes,
it's the face mask with the oxygen monitoring.
Sensor. Yes, monitoring. Yes.
Okay, that is your product, right? Okay. Thank you. Yeah.
Thank you.
Okay, thank you for all the comments. I believe this is the last presentation for the session on ICT for health and welfare. So thank you everyone for the participation, and I would like to conclude this session, and we can take 5-minute breaks before we start the next session. Thank you very much.
Thank you.
Thank you, Dr. Arisa and the speakers. Hello, everyone. It's time to move to next session. Next session will be in session 5. This session will be chaired by Dr. Francis. Francis, can you hear me?
Yes.
So please go ahead.
Okay. Good afternoon to everybody. I'm Francois Chin from the Institute for Infocom Research, A-STAR in Singapore. Welcome to this session. Is on ICT related technology. And in this session, we have 4 speakers, 3 from Malaysia, 1 from Vietnam. Okay, so before we start, I'm not sure everybody is here for a photo session. Can I invite all the speakers in this session to turn on the cameras and we have a photo session? Okay, I move. So for every speaker, we have 10 minutes of presentation, 5 minutes of Q&A. During Q&A, questions, you may raise your hand for question, or you can directly ask the presenters. Okay, so the first speaker for this session is Mr. Min Wei To, and his presentation topic on the implementation of e-commerce is for the development of IoT device water quality monitoring. So, Mr. To, start your presentation.
Hi, a very good evening to everyone. I'm Min Wei. All right. So you can if there's any question, you can just raise your hand and ask me. So I'll be sharing my screen now. Okay, so can everybody hear me? Okay. All right. So today my research topic will be on the optical segmentation on E. coli colonies formed on specialized E. coli test piece. And this project is actually
I hear some breaking sounds.
Is it okay? Is my voice okay?
Mr. To from ESM?
Yeah. Can everybody hear me perfectly? Okay. All right, so basically for my part, there is actually a lot of is actually for development of IoT devices for the water quality monitoring system. Okay, so basically the main reason of us creating this project is actually due to the limited water resources that is actually being an increasing problem globally. So while water reuse system is the only way to tackle this problem, many of these projects fail because of not proper monitoring and maintenance. So by using ICT technologies, we can have a real-time analysis and monitoring of the water quality. And by using advanced technology like machine vision technologies, we can determine the water quality and count the colonies of the E. coli or any kind of bacteria that is in the water instead of us human counting it manually. So one of the problems, one of the few problems that we face is that the technologies of the previous years is that we have to test the water in the big labs, but remote areas, they could not access the lab so conveniently. So therefore, this is one of our problems that we found out during this project. And the second one is actually when handling the water sample with possible E. coli. When I say possible, it means that we are not sure whether or not E. coli is present. It's actually a very hazardous task, and it requires highly skilled personnel to actually run the test. And overall, the testing of water quality is not a smooth process. It's still very disconnected. We have to bring it from one area to another area, so it's still relatively disconnected. And after the test is done, the counting of the E. coli colonies usually is determined by a dot or many dots if there is a lot of E. coli colonies in the test piece. It is a very tedious process because lab assistants still count it using manual method, using a counter and maybe under a light and a magnifying glass. So to tackle all these problems, our solution is actually to design a portable machine vision system, which is actually in an enclosure. So it will be in a small enclosure and all the necessary sensors will be inside the enclosure. And then because of having the machine vision system, we also have to investigate the lighting effects on the colonies. All right, so this one I will explain a bit more later on. And lastly, to enable the automatic counting of the E. coli colonies on the test piece, we have to perform optical segmentation on the image that is taken in the enclosure. So therefore, the title, optical segmentation. Okay, so before we start understanding how the process is done, we have to first understand how water quality is determined. All right, so commonly, this is actually a common practice around the world. So water quality is actually determined by counting the colonies in a test piece. All right, so usually the unit for it is colony forming unit, or CFU per 100 ml of water. All right, so there is actually a standard to follow through where we are determining the quality of the water. So like for example, the drinking water that we are drinking every single day, for safe consumption, it has to be 0 CFU, means that it's totally clean. There is no E. coli specimens inside the water, right? Therefore, actually on the left side here, we can see that actually to test the E. coli, we're actually using this specialized E. coli test film. So this one is actually only sensitive to E. coli bacteria, all right? So when it's if there's presence of E. coli, actually dots will form on the test piece here, the square part here. All right. Okay. So next, just now I did mention about the enclosure assembly. So basically, this is the enclosure. It's a very small enclosure which I've designed. All right. So all the necessary equipments, or rather, the whole process of testing the quality of water is actually done in this small enclosure. All right. So it starts from the incubation. So it starts from the moment we drop the test water onto the test film on this part here, just as I explained just now. All right. So it starts here. Incubation for it to form the dots on the test piece. There's actually incubation needed. All right. So the incubation process will be done inside the enclosure. All right. So it has to be run for 24 hours at a set temperature and a set relative humidity of 45% and the temperature of 37 degrees. This is the requirement for incubating E. coli bacteria, right? After that, the machine vision technologies, the sensors, the cameras, and even the lightings are actually residing inside the enclosure. So as you can see from here, this is actually all the necessary components. So the microprocessor and then the camera and also the lighting is inside. Okay. All right. So this is actually what we have done thus far. All right. The results are quite promising. All right. So this is actually the first step into the machine vision system. All right. So when we're talking about machine vision, one of the most important thing is actually a lighting. We have to vary different lighting to actually improve or make the dots here more visible, therefore having a more accurate E. coli count. Right. So as you can see here, we have done various testing on various lighting colors, and these three is actually one of the most obvious in terms of the difference. All right. So on the left is actually the control unit. So this is white, regular white lighting, which we can find in our regular household, right? And if you compare the red lighting and the white lighting, you can notice that the red lighting picks up more dots. So actually, I said earlier on, the dots actually represent presence of E. coli bacteria, right? Of the E. coli colony inside. So as you can see here, the dots over here are is sharper and it's more apparent, all right? And then the blue, it couldn't pick up anything. So this is basically got to do with the wavelength of the various lighting colors, all right? So as you can see, red lighting is actually giving us the best results, all right? And we can verify the claim by using different softwares. Like for example, the most common one with ImageJ, all right? So as you can see from here, just by looking at it, the ImageJ picks up more of the dots compared to the white one. Okay, so as you can see from here, I've highlighted it for you. This is actually from a particular section of the test piece. So you can see here a few dots that is present on the red one is not present on the white one on the version, right? Okay, so lastly will be actually verification using the OSU method. All right, so this is done using MATLAB. So this is actually the red lighting for the red lighting, and this is for the white lighting. All right, so as you can see from the graph on the left, there is a great distinction between the foreground and the background. So there is a good comparison between because usually the dots will be on the foreground and then the test piece is actually the background. So there is a great distinction between the foreground and background. Therefore, the counting of the E. coli, the dots, the colony is actually more accurate. So as you can see here, this is actually for the white lighting version. There is no distinct peaks, all right? There is no peaks stating that there is no distinction between the background and the foreground. So therefore, actually, we can prove that by using red lighting, is actually giving us a better visualization of the presence of E. coli on the test cell, on the test piece, sorry. All right. So basically, that's the end of my presentation.
Okay. Thank you, Setio, for your presentation. Any question from the floor?
Okay,
Anyone?
I got one question from hold on. Okay, so this one is actually, this design is actually to be used on the field, mostly targeted to remote areas. where accessing labs to carry out water quality monitoring or testing is not available in that area. So this is where our construction or this system goes into play. Okay.
On who will use this technology?
Okay, all right. The next question now. Who will use this? So basically, this one be used by the water plants personnel inside. All right. So where remote areas there is no labs inside. So this is, and the lab workers are not on site. So basically, it's for general people like us. So anybody who has the access to the water source is able to use this device to actually to test the water quality of that particular area. Yeah.
Okay, this follow-on question. Any improvement to the existing film? Yeah.
Okay. So the film that we are using is actually, there is no improvement in terms of the film. The film is actually widely available in our market. All right. Actually, a lot of labs still use this film. What we are improving is actually the automation part. All right. So we don't have to, because previously when we are talking about counting E. coli cells or E. coli colonies on a test piece, usually we use a manual counter and we count it one by one using a naked eye, using our own naked eye. By using this design is actually to have to run everything automatically, therefore the use of machine vision system. All right. So the machine vision system is able to recognize and count the E. coli colonies on the test piece without human being there. So it's less tedious for us humans or the user of the caretaker of that particular water source. Yep. Okay.
Okay. Thank you for the answer. Any other questions from the floor, from any participants?
There's a question in the chat. I don't know if it's been read.
Okay.
Hi, can I add on to my questions?
Yeah, sure. Please go ahead.
So is it something portable, like something that is using is it requiring power to actually run through things, etc.? Because that was not really clear to me. Because you said it's going to be brought to remote, right?
Yes, this system is totally it's very portable. In fact, the entire enclosure is no bigger than your regular water bottle, and is run using batteries. And the microcontroller that is used inside is actually of a small size and is relatively low power. So you can run the entire test without needing of like a power source and so on. Everything is in the enclosure, and the enclosure is portable and is powered by rechargeable batteries. Yeah, and it's actually, you can actually bring it around from one station to the other without worrying of any like power cords and so on. Yeah.
Because you can only look into E. coli, right? Because at the moment in Brunei, we are facing issue of manganese, because it turns the water brown. So despite having treatment before, but because of the presence of the, I think it's manganese, it turns the water brown. So can it be improved to that level as well?
All right. So for this part, is actually the answer is yes, but there will be requirements, or there will be changes need to be done to the algorithms. All right. So for now, one of the main problems of water is actually E. coli. E. coli is actually the main cause of a lot of sickness, like the most common will be diarrhea and so on. Yeah. So if there is a need to detect other kind of bacteria, yes, it can be changed. Maybe there is a need to change the test piece or something like that because like, this test piece is only sensitive to E. coli. If there is a test piece that is suitable for the magnesium that you are mentioning just now, yes, it's able to do that as well. Right.
Okay, thank you.
Thank you for the Q&A. Thank you, Mr. Teo. Let's move on to another presentation.
All right, thank you.
Thank you. The next presentation is by Mr. Inkiet Tay. His presentation title is Development of IoT Water Quality Monitoring System. Okay. Mr. Tay, please.
Okay, thank you, Dr. Francis. Okay, yeah, can you all hear me clearly?
Yes, we can.
All right, thank you. So I will share the screen right now. All right, can you all see the screen right now?
Yes, we can.
Okay, all right. So good evening, everyone. My name is Tay Kiat. So I'm from the University Science of Malaysia. Okay, so my project title was the development of IoT water quality monitoring system. All right. So this project was actually a collaboration project with some of the experts from my universities, Dr. Yu Gohua, Dr. Yan Kin Sam, and Associate Professor Dr. Liu Chiuping and Miss Hong Chia Hui. All right. So I'll be the presenter today to show you guys what this project is all about. So just a detour from the project title. So as just now we had a question on how to detect the magnesium problem, right? It actually can be solved through this project. So I will slowly show you through this project and see whether it convinces you or not. All right. So the purpose of my project is to develop a system which can perform real-time monitoring system for the water reuse system. Then the second purpose of this project is to collect critical water reuse data to improve household water use and water conservation purpose. So then why I need to do this project? So the background of this is as water demand continues to increase across the globe, the availability of potable water continues to decrease, arising from climate changes and limited water resource. So what do I mean by limited water resource is the water resource around the world, yes, there's a lot of water, but when you talk about usable water, it's actually really limited. So that's why due to all these factors, our water it becomes a problem where how we can obtain this usable water. So lack of sustainable water management on the urban water system also make us kind of hard to get this usable water. So accounting all these factors, water reuse system seems to be one of the viable solution. So there's a lot of water reuse project developed around the world, but many of these projects has failed because of lack of monitoring and maintenance. So that's why. So my objective of the project is to integrate the water quality sensors and performance of water quality measurements. So the second objective was to send and store the water measurement data in cloud storage. All right. So this is some of the standard imposed in Malaysia. So I obtained this water quality standard from the Department of Environment of Malaysia. So basically in Malaysia, there are 5 classes of water quality standard, which are class 1, 2, 3, 4, and 5. All right. So each class is split based on their tolerance of each of the water parameter, and each class has a different usage. All right. So yeah, this is the continuation. All right. Okay. So right now I will give a brief overview of my IoT water quality monitoring system. So my system consists of the water level sensors and turbidity sensors. Originally, I plan to integrate. We plan to integrate more sensors like the pH sensors and conductivity sensors and total dissolved solids, or we call TDS, solid sensors. But due to some issues on the delivery issues, so we are unable to obtain those sensors and start to develop our system. All right. So then all these sensors are connected and controlled by the microcontroller, which is the Arduino Uno Wi-Fi revision 2 board. All right. Okay. So basically, I will show you. This is my flow chart for the working mechanism of the IoT water quality monitoring system. So basically, we have a filter water here. So it will measure the turbidity and measure the water level by these sensors. Then these sensors will send the data to the Arduino Wi-Fi board, and this pod will upload the data to ThinkSpeak. All right. So since the data is stored in the cloud server, the data can be easily accessed anytime, anywhere. All right. Okay. So this is the type of sensor that I have used for the system. The first one is the DF robot non-contact liquid level sensors. So it uses water sensing capacitor to detect the liquid level. So when there's no water, there will be a presence of distributed capacitance. So this results in a certain amount of static capacitance to the ground on the sensors. But when there is liquid near the sensors, the parasitic capacitance on the liquid will be coupled to the static capacitance. So the final capacitance will be larger, so the controller board will be able to detect it. So to more simple term is, this is the first, as you can see the first diagram, this is normally when there is no liquid around the sensors. But when there is liquid around the sensors, as shown in the second diagram, it's an analogy when I have a finger like a water it will contribute some of the capacitance and add up in the total capacitance. So the control board will detect the extra capacitance and say, oh, this got water. All right. So yeah. Then the second sensor used is the DF robot turbidity sensors. So basically, it uses light to detect the suspended particles in the water. So beams of light will be produced from the photoemitter and need to pass through the water before it reaches the phototransistors. So the cloudiness of the water will affect the amount of light received at the phototransistor. It will then affect the voltage that is allowed to pass through. The voltage value is converted to NTU in the coding. All right. So basically, this sensor measures the turbidity. What we meant by turbidity is the cloudiness of the water. If the water is very cloudy, means the NTU is very high. All right. So this sensor will detect it. So when there is a higher voltage produced from this sensor, we know that the NTU is lower. Okay, means the water is clearer. All right. So this is the relationship between the turbidity and the voltage. So yeah, this is an equation governing the formulas between the turbidity and the voltage. All right. So right now, the quality monitoring system that I have done until now. All right. So how we upload the data to ThinkSpeak. So right now I will show you a video on how to upload the data to ThinkSpeak. All right. Okay, I will play the video.
Hello.
Yes. All right. Yes. Hello. Yes.
Hello.
Are you playing a
Can you hear
video?
me?
Yeah.
Yes, we can hear you, Tony.
Sorry.
Right.
Mr. T, have you finished your video and or presentation?
Oh, I haven't. Can you all cannot hear the sound?
We can't hear the sound.
Oh.
No, we
I
cannot.
thought I share. Oh, but I thought I'm sharing the sound right now. Sorry about it. Okay. So sorry about it. Never mind. So I will just proceed because this one I just want to demonstrate how I upload the data. All right. So never mind. I will just roughly go through it. So basically, I've done the coding for uploading the data using the Arduino IDE, and this is how I connect it lah. All right. So so sorry for the technical issue. So I will continue the rest of the presentation. So sorry about that. Okay. All right. Then I will have, okay, this is the turbidity measurement that I've done for the known turbidity samples. So this is the reading I get, right? So for the clear drinking water, I have a negative something. So the 675 NTU, I got 2000 something, and 413 will be 700 something. All right. So I know there's still some accuracy to be maintained. So because this project is still under development, so we'll have to calibrate the sensors to the standard that is established in the world. All right. So that's all for my project. And to just spare me one more minute. So this project is the output of the ASEAN IVO project and IoT water reuse in developing cities and financially supported by NICT. All right. So that's all for my presentation. Thank you.
Okay, thank you, Mr. Tay. Any question?
Yeah, I have a question. Can I ask the question, please?
Yes, please.
Okay, Mr. Yingkiat. I am also a bit confused about what you are doing actually, because you connect the sensors, right? Like turbidity sensor, and then some other sensor.
Yes.
And you connect to Arduino Uno.
Yes.
Okay.
All right.
And then from Arduino Uno, you connect to the ThinkSpeak or something like that. Right?
Yeah, that's a cloud server. Yes, correct.
Yeah. What is the specialty of this project actually? Because if you just connect all these existing products in the market.
All right. So what is so special about this project is because there's a lot of water reuse system, but a lot of water reuse system has failed because lack of the maintenance and monitoring. So that's why we try to solve this issue to make all these water reuse project success. So we try to deploy the IoT water quality monitoring system to all this water reuse system so that it can remotely monitor this water reuse system. Yeah.
Okay. Okay. Anyway, what is the difference between your product and the other one? The first one.
Yeah,
So
actually we are actually connected projects. So for just now, Mr. Teo Min Wei will be in charge of actually on the organism part. So he will be actually detecting E. coli for now. All right, maybe there will be further organism can be detected in the water. Maybe. All right. So we are actually a connected project. So I'll be in charge of monitoring those water quality parameters such as turbidity, pH, and TDS, conductivity. Yeah, all these parameters are actually important to determine the water quality. Yeah.
Okay, last question. Is this a final year project or is this something else?
All right. Actually, this is my my internship project.
Internship project. Oh, okay. Oh, that's why.
This is my
Okay.
internship project.
No other questions. Thank you.
All right.
Yeah.
Thank you.
Okay, thank you. Any other questions from anyone?
Hi. I would like to know, because you're using these Arduino sensors, these sensors are basically like a plug and play. So have you ever tested it in the long run? For example, if you're going to immerse it in water for a long time, how is the sensitivity? How is the, will it be affected throughout times, etc.? Have you looked into that? And how would you propose to put this solution in the real deployment?
Yeah. So to address your question, yeah, that is why I would say this project is still under development, and our next step was actually to expand on like because the next problem we see is like what Miss Vida said about I would say when you put all these sensors in long run in this water reuse system, there's actually one thing we'll call biofouling will occur. It will be it is a condition where a biofilm that will grow on these sensors. So we are trying to address that problem, but we haven't have any results because that one is the continuation of this project. Yeah. So yeah, but sadly to say we have no result for that now. Yeah.
Okay, all the best. Thank you.
Okay, thank you.
Okay, thank you, Mr. Tay. Let's move on to the next presentation. Okay, by Dr. Muhammad Razali from the University of Tun Hussein On in Malaysia. You're speaking on the LT reverse vending machine for improving the recycling.
Okay, let me share my screen first. Okay, so first things first, my voice is okay? Hello?
Yep.
Yeah, okay. Okay. So thank you very much for the introduction. So my name is Razali Tomari. I'm from the University Tun Hussein on Malaysia. So basically today I will present in terms of my project title of development of IoT reverse vending machine and its feasibility study to improve recycling. So basically the presentation will consist of the two parts. So the first part will be I will explain about our machine that we developed, the components involved, the system configuration, and how we send data to the server. And then the second thing is that I will share with you our finding when we test pilot our system in two state in Malaysia. So basically in the future, you can see this is our journey in developing this particular machine where we test that thing, where we, let's say, join competition and etc. So one of the motivation of doing this project is based on this problem statement. So basically, statistically, it's about the 480 billion of plastic bottles was sold worldwide. But yet, from this particular figure, only 30% of that particular numbers was actually recycled. So leaving the rest in actually in the ocean and can be in some sort of the landfill. So in terms of the nature of the plastic, so one of the recycled items is that for the plastic, it requires around 500 years to naturally break down. And then one thing that we can solve this particular issue is that we need to perform the recycling process, in which for the recycling, we can, instead of relying on the raw materials, we can use the recycled items in order to develop a new product. So in that case, it supports the concept of the economic recycling. So one of the things regarding the plastic sinisters is that if that particular plastic bottles that enter our body, so it can cause some sort of disease. For this particular case, let's say the lung problem, the liver dysfunction, and etc. So one of the things that we try to emphasize is that we want to develop a system that's capable to improve recycling in Malaysia. So in general, for our local issue is that the recycling rate in our country is around 70%. And then this is some sort of the two current practice in order to perform recycling. The first one is that the user can actually dump the recycled item in the dedicated recycle bins. And then for this particular case, they don't get any reward. The second thing is that they can accumulate that particular waste and then bring that thing in bulk to the recycle center in order to get a reward. But currently in Malaysia, in terms of the recycling rate for the plastic is around 20 cents per kilogram, and then for the aluminum can is around 2 ringgit something. It's quite good. So what we do is that for this is some sort of the statistic of the recycling rate around the world. So one thing that I want to emphasize from this figure is that first world countries such as the Norway, Sweden, and Germany, they show the highest percentage of the recycling rate because of their incentivize people for the recycling, even with the smallest amount of the recyclable items. So in that particular country, they have some sort of they call it the container deposit scheme. So for this particular case, let's say, for instance, let's say if we buy the mineral bottle, let's say $2, so 20% is the thing that you can get when you return back that particular bottle to the vendor. So that is the concept of the container deposit scheme. But yet in Malaysia, the scheme still not yet implemented. So one thing that we try to improve, boost the recycling activities is by introducing the concept of interactive machine and concept of collecting point, which is we call that thing as the give a reward for the user that are able to perform the recycling practice accordingly. So for this particular case, this is some sort of the company that implement the recycling activities in Malaysia. So you can say, let's say iCycle or Recycle for Life. So this is some of the company that develop the apps in order for the user to collect the point, and then based on the collected point, they can redeem something, let's say some sort of the goodies or some sort of the reward in terms of the monetary. And then the second thing is in terms of the second one, let's say for the Monji and RVM in Kuching. So for the Monji, they develop the system in which when the user recycle, they can actually play game on site, which is the game was actually put in the RVM machine. So this is some sort of the solution worldwide in order to develop the interactive recycling process, and then at the same time provide the reward to the user. So this is some sort of the reverse vending machine that can be found in the USA, in India, in Thailand, Korea, Norway, etc. So basically, based on that, the things that have been developed in Malaysia and developed worldwide, we propose to develop our own custom-made reverse vending machine. So one thing that we want to highlight in terms of our machine is that it will be fully custom-made. So means that we develop something that is based on the requirement of the customer. So they say they want whatever type of shape, they want whatever type of redemption they want to put in the system, and then whatever process flow that they require, so we will develop that thing. So basically, our system consists of the machine, and then we develop our own dashboard. So for this particular case, we have two types of dashboard. The first one for the admin in order to monitor everything, the process and etc. And then the second thing for the user, which is they can view the accumulated point, the transaction log, and etc. Then they can use that thing in order to redeem a reward. So one thing that we want to highlight regarding our system is that our system is in terms of the modular configuration, which is we focus our system in terms of the smallest part of the module, which is the small module can be actually plugged into anywhere. They say behind the wall, whatever casing that the customer required, we can plug into that thing. So this is the thing that we emphasize in our project, which is we develop our own custom-made modular, this is the important part that will be utilized in order to identify the recycled item. So this particular chip will receive the recycled items, and then later on it will identify that thing. Later on, a diverter will divert the corresponding recycled item to the dedicated bin. So basically, for the chip that we have developed, so this is type of sensor that we use. So basically, in general process, we use the inductive sensors in order to detect the aluminum can. We use the combination of the capacitive sensor and also the laser in order to detect the transparency level of the PET bottle and then the capacitance value. And then later on, we use the combination of the ultrasonic and also the infrared sensors in order to detect the presence of the recycled item inside of the tube before performing the material identification process. So once everything is in line, is good, and then it will send the log to the mini PC. So mini PC will actually transmit all the information to the database. So for this particular case, we use the SOAP protocol, Simple Object Access Protocol. And then for this particular payload, we use the XML type of the payload. So this is basically some sort of the snapshot of our system. So in the left side, this is actually the console where the admin can actually configure in terms of the how many points can be collected for each of the recycled item, and then they can actually adjust that thing accordingly because of usually in terms of the rate of the recycling will be actually changed by day, month by month, and etc. So in the right side is actually the transaction log of the bin. So this is we extract the thing from one of the recycled item that we put on site. So this is the result that I want to show in terms of our machine. So this is the simple video of our machine. So basically, you can view most of the details of the video in this link, bit.ly RVM Mitigation. So this is some sort of the process for the user in order to utilize this machine. They need to touch the screen, and then inside the recycled item, material identification will perform, and then the amount will be shown here. And then later on, when the process is actually completed, they can press stop, and then the barcode they can utilize in order to redeem the point will be given to the user. And then this is some sort of the repetition of the process. The same thing, they put another item, material identification process, and then later on, yeah, the barcode will be generated in order for the user to claim the redemption and etc. So this is what I want to highlight in terms of the second part of my presentation, which is we have put our machine into location. The first one in the Cyberjaya, which is for that particular machine, we put it indoor. And then the second thing, we put one of the machine in Batu Pahat Municipal Office, which is for this, but for the second part, we put that thing outdoor. So we want to know the user perception level in terms of the machine, or it can be used in order to increase recycling activities or not. So basically, this is our finding based on our machine for 3 months in Cyberjaya and also 3 months in Batu Pahat. So basically, for the first prototype that we put in the SW Corp Cyberjaya, so most of the time the machine will be used by the SW Corp staff, in which they utilize the machine is quite freely occupied. So one of the things is that they highlight the problem of the machine is in terms of the technical issues. So the first one is some of the item stuck inside of the chute before entering the final bin. And then second thing is that because of this is a recycled item, so and they put that thing indoor. So one of the issue is that there will be quite smell in terms of recycled items. And then so finally, as the conclusion, we can conclude that RVMSLearn is enabled to extract the recycling activities, and then we can improve the system by introducing the vision system, which is in this case we train the model by using more recyclable item, and then we put the old camera in order to perform the process. So thank you very much for your attention to my presentation. Thank you.
Yes, thank you, Razali, for the presentation. Any question from the floor? Razali, just now I understand from your findings, from the cans, you mentioned there is like coffee smell. How do you want to solve that issue?
So actually, what we do is that so we need to do the cleaning for, let's say, every week. And then second thing is that we put the ventilator in order to, let's say, of course it will be some smelly outside, but actually the smell will not accumulate it inside of the particular bin for implementation. So but that is one of the issue if we use that thing indoor. But actually when we put that thing outdoor, so we don't have any issue regarding the odor of the recyclable item, especially from the coffee container. So it's quite strong compared to other type of the recyclable items.
Okay.
Can I ask a question?
Yeah.
Please go ahead.
You showed the main component basically that you want to sell is basically the sheet, right? But as you shown in the picture beforehand here, there are some structure like a box and then cards and then as we know, they have different shapes nowadays as well. So how do you into that? Because as you can see, your is actually in home, right? Something that can detect this is a can, this is a stick, this is a Tetra Pak. Is that mechanism there?
So actually, for the improvement of the mechanism, so because of there is some request in order to let's say identify the Tetra Paks. So actually, for the Tetra Pak, in general, it enables to use this particular type of system. So we need to use other systems. So for this particular process, we are developing the conveyor, the mini conveyor in order to handle this particular case. But you are right, actually, for this particular chip model, so it able to, let's say, aluminum can and PET bottle, but enable to handle the Tetra Pak because of Tetra Pak enable to slide properly inside of this particular PVC container. So one of the solution is that currently we're developing the mini conveyor in order to make the things much more smooth in terms of the flow of the recyclable materials.
So what about in terms of detecting whether it's a can, and then there are several type of cans, right? Sometimes it's the aluminum, sometimes it's not aluminum can as well. And because if you can see, Red Bull is a bit sturdy in terms of the can compared to the Nescafe or Pepsi tins. So does it also detect in terms of that as well? Or
okay, so for the previous system, we have that particular issue, means that we're able to differentiate between this type of the material. But currently for the improvement, since we use the camera, so we train that thing, everything. So we train every type of particular can, every type of the particular bottle and etc. So that thing, in terms of the output of the classifier, it can be either specific particular model or it can be general things. So there is some sort of the improvement for that particular thing. Means that they say Red Bull, whatever Nescafe, right? So for that particular case, we in terms of the training, we put that thing in terms of two type, because of usually for our case, for the Coca-Cola, they want only that particular material to be recycled to them only. So we develop specific dimension for Coca-Cola. So the improvement, currently we are in a process to developing the vision type of model in order to ensure that we are able to handle much more type of recyclable items.
But don't you think by adding the vision, it will cost more? And as you mentioned just now, some users actually just require a specific things. So it actually, I don't know what in terms of ROI, in terms of cost, will that be something more beneficial, or rather you can actually look into the maximum size that this particular recycle bin can actually accommodate? You know, because it has to reach a certain time, a period where it's already full. So you have to inform someone to clear it up, something like that.
So in terms of the costing, right? So currently we use the one camera. One camera is cost around, in ringgit mesh is around 300. Let's say USD is less than 100 USD. So it's quite cheap. So actually, total cost for development of the machine in ringgit measure is less than 3,000. It's quite cheap. Let's say you can say around less than 1,000 USD, something like that. Okay, but we are in the process to make the things much more affordable by using the vision system to make it actually more flexible in terms of the user requirement.
Thank you. All the best.
Okay, thank you.
Okay, thank you, Razali. Let's move on to the last presentation for this section, okay, which is titled Autonomous Drone Swarm for Drug Delivery in COVID-19 Pandemic. And this will be presented by Mr. Nguyen Phu Hang from Vietnam. Please.
Good afternoon, everyone. Can you hear me well?
Yes, we can hear you. Can you turn on the video?
Okay, I will start.
Yes, we can see you. Please go ahead.
I'm Hung Nguyen. I'm from the Lê Quý Đôn Technical University in Vietnam. Now I present our proposal with the title Autonomous Drone Swarm for Drug Delivery in COVID-19 Pandemic. Firstly, I will introduce briefly about the proposal. As the COVID.
Excuse me. You are currently not sharing your screen.
Sorry, wait. Can you see my screen?
Now we can see.
Yes.
Yeah. Yeah. And also maybe you need to speak a bit louder. Thank you.
As the corona appear from the end of 2019 in China is spread quickly over the world. So
Sorry, can you put to the full screen, because now we see two screen. We see the presentation screen with the text.
Okay. Seconds. Can you see the second screen?
We can see the screen. Yes. Yes. Okay. Now we can see it. Thanks.
And to reduce the outbreak of COVID-19, the best way, as we know, is to keep the social distance. Right? That leads new ways for delivering food and medicine instead of the traditional delivery service. So that raises the application of drone for safety delivery service. That I study is that two main possible use case use a drone. Its first application is transportation, medicine, or food. And second is the can use for the area spraying of public area. First one it can use for the public space monitoring or guidance during the lockdown. However, the current drone system may be a little bit need to improve for the navigation accuracy, as well as delivery scheduling. So in this proposal, we want to propose a new solution for the autonomous drone swarm. It for the smart delivery. It includes two new techniques. New advanced technique is first is propose a new autonomous navigation using the computer vision and the advanced vision, advanced deep learning. The second is propose a new way for optimize the delivery scheduling. With targeting to minimize the transportation time, energy, and payload and many objectives. Second target in the proposal is to contribute to capacity building the Asia region. And after that, we can have to develop the existing link and establish new link for researchers for Asia, Korea, and Japan. So now I introduce a little bit about why we need autonomous drone for the safe and in the COVID-19. When the COVID-19 spirit appear, we need to keep the social distance very well. But however, all people need food and medicine to treat them. Right? And so, but traditional delivery service assists the potential danger of the virus infection. So the safety delivery service apply the high advanced technology for food and medicine necessary. With the advance of AI, so it can provide a good tool for smart delivery, smart navigation, and how we can optimize the delivery schedule. So the requirement for the firstly is the drone should be localized itself in the environment. And second is in the drone swarm, when the system receives a sign of delivery, the system should be assigned its drone smartly in order to optimize multiple objectives like food, energy, weight, coupled, transport. So even though there are systems or several systems already developed, but we still need some autonomous navigation accuracy, optimization, optimize tasks for each drone. So to develop the to prepare for this project. Our team already studied and published a paper in in this paper, we present an accurate localization methods for transportation accuracy of 1.4%. It's possible to apply for this autonomous drones one with addition improvement. So here I show some the main part of our methods. Get the picture. We use radio camera and extract the picture and match between them. And the good best can be used for input for optimize pole estimation. And each frame to frame pole add up by it the current vehicle internal reference frame. So in now we study to try to replace the component of traditional SLAM by deep learning model. That means as you see in the we try to improve, try to replace some part of geometric value upward by the deep learning upward in the bottom like this. So in this project, we will provide some background of the drone technology, computer vision, and deep learning approach for autonomous drone navigation and related technology. And the result will be present and published in some conference and journal paper. It can be applied for patent or collaborate with the industry to transfer the technology to society. To succeed the project, we will follow some methods. We need to do some surveys on the autonomous drones one and some current and solution to clarify the detailed requirement for implement mass delivery service beyond the drones one. And beyond the limitation of existing solution, we will be propose the innovative and new solutions. The mass delivery service beyond the drones one, with the two one the efficient drone navigation using the multiple model deep learning and on the data capture from the multiple tester. The second is the multiple objective optimization for the optimal delivery scheduling. We also project in this proposal, we want to collaborate with different partners to share the knowledge. And
can you wrap up in 1 minute? So we have some time for Q&A.
So I can make conclusion now. Smart delivery is essential tech for delivery food and medicine, especially in the COVID-19. And development of AI can provide efficient methods for autonomous navigation. However, the fast scheduling is a smart delivery system. So, okay, that's all I have. I already finished.
Yeah, thank you for the presentation. Yes, we have some time for Q&A. Anyone?
Hello.
Yes.
Yeah, I can try to ask something. Who will be the user of your system? Who will fund you? Who will give you money to build this?
Actually, we try to make the initial study, and by ourselves, this support by our university right now.
Yeah, but after actually this type of application is useful, right? But to be able to make use of it, there must be a scale, a certain scale that it can be useful. So, but to drive to that scale, how to start that?
Actually, we will start from the.
Yeah, so when you put your proposal, I think you need to address that when you write in the proposal. Yeah.
Yeah, actually, firstly we try to make some initial study first. After that, when we have enough the skill, we will start to develop the real one, I think.
Yeah, the technology itself should be achievable, right? You just need traffic management, route planning. Although I think it's achievable, but after you have it, how to deploy it, and there must be people who are willing to invest into it.
Yeah, sure. Actually, further, we try to get some funds for this project recently, but we need to wait for some kind of
Yeah. Good luck. Yeah, for your proposal. I think you should try to make this part a bit clearer for the proposal.
Yeah. Thank you.
Thank you.
Yeah, thank you for the comment. Yes, maybe one last question from Tony Anwan.
Okay. My question is, what kind of drone are you planning to use for your system?
Drone is some kind of look like the robot. It can fly. It can fly in the air, right?
Yeah. Drone is something like robot which can fly. Yes, but what kind of drone? Is it how many kilo, for example?
Yeah,
what is the weight of the
weight
drone?
and the size of the
The
drone.
size. Yes.
Yeah.
Are you planning already?
I'm not planning right now, but we maybe plan with some type a little bit heavy drone, or it can be have to enough the possible can be.
Yeah, you must plan well because there are drones which cost you like $500,000. Yeah? So if you get from NICT like that would not be so beneficial for your project.
Yeah, actually, we didn't decide which one we will use.
Oh, okay. Okay, thank you. Thank you, Prof.
Okay, thank you, Hung. Thank you for all the informative and interesting 4 presentations. If you have further question, you can send the question to the presenters directly. And let's have a 5-minute break before we move on to the next session. Thank you.
Okay, thank you very much.
Okay, thank you.
Thank you, Prof. Francois.
Thank you, Dr. Francis and the speakers. So let's moving to the next session, session 6. So this session will be chaired by Dr. Sam from Cambodia. Dr. Sam, can you hear me?
Yes, I hear you well. Can you hear me?
Yes, okay. Please.
Okay, thank you very much, Ishiro-san. So, good afternoon, everyone. So, my name is Dr. Sam from Cambodia Academy of Digital Technologies. So, now I'm the chair of session 6, titled ICT-related technology and application. So, in this session, we will have 4 presentations from 2 from Brunei, 1 from Cambodia, and 1 from Laos. Okay, so before we start the session, can we handle all the speakers? Please turn on the camera so that we can do the photo session. Thank you very much. All right.
Thank you.
So yes. So before we start the session, I would like to highlight a little bit about the rule of the presentation. So all the speakers, for each speaker, you have 10 minutes of presentation, followed by 5-minute question and answer. So please try to be mindful for your time frame so that we will have time for the question and answer. So for the first presentation, I would like to invite Mr. Sumukpon Anusa from University of Technology Brunei, UTB, to do a presentation titled Automation Sim. So, Mr. Somon, the floor is yours.
Okay, thank you, Dr. Sam. I'd like to share my screen now. Can you see that? Can you see the screen?
Yes.
Okay, the sound is clear, yeah?
Yeah.
So for the presentation, I like to say about automation sim. So the word itself might be a bit vague. What do I mean by automation sim? Is the simulation of automated machine. So it's more toward robotics. But anyway, the project is not about robotics. There are some robotics inside, but we do not really concentrate on robotics. We concentrate on the idea of education, actually. So the motivation, I 4.0 is coming, and at the moment, I think there is a gap between university and industry in this area. So that is my interest. The component for I 4.0 that we would like students to know would be in ICT technology, hardware, software, and what are the components inside would be the workforce, academia, industry. These two parties inside the workforce have to do design and manufacturing. So now academia usually involved in the design, like in industry more toward manufacturing. Although the skilled people who in ICT mainly do the design, and engineering probably involve some manufacturing. And when you go to industry, then we do both of these. But that is the gap at the moment, especially when the AR, VR, augmented reality move very fast, and all the deep learning AI move very, very fast. The thing that we teach in university, it seems to be obsolete very fast as well. So that is the motivation for the proposal. So what is the application of automation? It's actually in all the domains. You can think about in sport, in production, in logistics, in retail, in everywhere you will see this type of automation that I 4.0 will move into it. So the platform for this type of I 4.0 for the design part, platform could be in augmented reality, virtual reality, and we do serious game simulation. Serious game here means you try to understand the environment, but not by actually doing it, by actually simulate it first in order to gathering more information before make a decision to implement it, to deploy it. So application cases will be in processing, evaluation, planning, in education, in training, in safety and health. I would say that we find all the application in this type of process everywhere. So this, for myself, I'm teaching in ICT. So my focus will be in the software part, maybe academia, will be on the design part mostly. The domain actually can be anything. At the platform, my focus will be on AR, VR simulation and game style. Application can be anywhere. So in the past IVO, of this senior officer from IVO used to give the type of presentation, which I think is very insightful, and I would like to just quickly go into it. When we design a process, right? So we need to think about the customer. We need to think about who we use it. And then we have to look from ourselves, what do we have? From that, what we have, we must have a way to compile them to a certain product that suit the customer. So I think if we can clearly see this process, it will make the design process easy for us. And I think this is very useful thing that I received when we listened to the IVO in the previous IVO. Okay, so from that, I would say that at the moment the gap between industry and university in terms of the workforce skill for I4.0. Hence, I think that maybe it's a good idea that university in Southeast Asia, in ASEAN, should see if we can work together in order to bridge the gap. At the moment, the product and the simulation are done by companies that produce a robot, such as KUKA, or that make product. They develop their own hardware to do it. Now, this type of software are not freely available for university to come together and build the asset. And in order to save costs, we should focus on open source software, such as Blender, Unity, Unreal, ROS. All these software are free to use for teaching and for research. Some of these software, if you want to make a product to sell, then you need to pay some license. Otherwise, it's free for the exploration and for research part. So what do we do is that we create the asset. So this asset will be the model of sensor, and we will model their functionalities in such a way that it's suitable for a particular product. Right? Such as if you are in the production line, what type of sensor you need in order to carry out a certain product, then we need to develop that type of sensor. But this sensor is not real physical sensor, and it don't need to have a real physical property, but we need to have enough fidelity of the model to fit the chart. If we want to analyze the flow of package, then there must be a sensor that measuring proximity, measuring size, or be able to see certain things. That type of thing need to be modeled, right? But we don't need to model all the physics of it. So that will be the part of asset creation. If we can have asset creation, then we can share the asset. So this will save costs. And then we can use that asset to develop a certain product. And that product can be used by SME. So in this case, the SME will be our end user. And once the product or the asset have been developed and create the product, then we can start to do simulation and to measuring certain property of our plant or of our factory or our production lines. Usually, this type of process, it will be useful when the cost of the production is less than the cost of implementation. The cost of the real production is more than the cost of implementation in the simulation. If we can find the domain like that, then it will be useful to do this. I hope that is quite clear. So, for example, we can develop an asset and then implement all these together, plumbing them together, become a certain simulation environment. Then we can start to simulate and see the property. and do analysis on that information before we actually implement it. And that will be the answer for the resource that we have, expertise that we have. We produce the product, and for the particular end user. So we have to identify first what are the end user that we use the product, and then we can go back to all the components. So that will be the idea. So for example, if the end user is the logistic system, then it will be a kind of thing that we need to model. Right? And we need to model in such a way that it has enough fidelity for the task. Similarly for this, if the production is for packing something, then we need to model this in such a way that it captures the fidelity of the task. Don't need to model all the physics, but it has to be enough to capture the fidelity of the task in order to be able to later on analyze them and do the cost analysis before actual implementation. Okay, the proposal of the project is to develop a collection of shared assets that support the construction of various simulations, workflow such as activity and production line, manufacturing robot, factory automation. By analyzing this outcome, we can gain good understanding before actually build it. What a potential member university that have mechatronics, have course in AR, VR, serious game, those can be potential course that we can develop and teach in university. Local SME can participate by propose a particular task to be done, and then this task can be modeled and developed as the asset and share among university. Or government unit that looking for IVO 4.0, so those could be potential team members. Okay, so we repeat the information. Objective to develop these assets, that's the main objective. To develop virtual environment and to use this virtual environment in real application, and then to evaluate, document, and publish the findings. These are the main task that will be done. So for those who are interested in this type of area, you can email me and we can discuss further. So this project is less into research, but it's more into developing assets for education purpose. Right, thank you. I share some of the link to the product Unity, and then share some of the picture of the hype cycle in this area. So you can see like digital twin or this smart factory. These are the areas that we are addressed in this presentation. Thank you.
Thank you very much, Mr. Samnok. So we have 3 minutes for questions. So any question from the floor, please?
Could I ask the questions? Actually, my WebEx don't have the raised hand in my WebEx icon. Thank you very much, Professor Somnuk. Do you hear me?
Yes, I can hear you. How are you?
Hey, I'm fine. Very nice to meet you. Actually, you are switching from deep learning and image recognition to the digital twin, isn't it? Right?
Yeah, and also shift into education more into education.
Okay. All right. Actually, in Thailand, at Chulalongkorn University right now, we are very much interested in the digital twin. Actually, we going to have the 5G private networks, and also gonna implement the digital twin with a single arm robot and AMR, something like that. And I think that your project is quite interesting. And but after you do the automation simulation, do you have to how you compare the performance of your system after you do the simulation?
I think this part need to rely on the end user. That means we need to really get the actual SME to come, and we need to model their process, and then they will be the one who evaluate this and see that if it actually save cost or can improve their process. So
What?
it will be more practical.
Okay, so after you do the simulations, then you have to talk with the SME and then factory or something like that, and then like try to compare the performance after that, right?
Yes,
Something.
correct. Yeah.
So the your automation simulation is like how can it is possible, like can you explain like the differences between your automation simulation and the digital twin? Because
Okay. The digital twin would be more rigorous because it tends to aim for prediction of the actual event that have not occurred yet based on the model, right? It aims for that. To use a model to predict the future in the physical world.
Okay.
Yeah, but in our case, we are a lot less because we don't want to do digital twin. To be able to do that, the physics of the model must be very accurate. Otherwise, it will be impossible to predict the real event. So the physics must be very good. But in our case, we very diluted. We just want the physics to be good enough to predict a certain task, such as a flow, production flow, pipeline, counting, like that only.
Thank you very much, Mr. Samno.
Thank you very much. Okay.
Okay, thank you very much, Mr. Samno. So with the time frame, so allow me to move for the next presentation. So I would like to invite Mr. Sampon Khattavong from National University of Laos to present about the seamless localization system based on indoor-outdoor environment using reducing your strength for Android platform system. Mr. Sampon, Dr. Sampon, the floor is yours.
Excuse me, actually, I am the representative of Dr. Sampon to present this work.
Okay.
Okay, could you hear me clearly?
Yes, yes.
Okay. Good afternoon from Laos. Thank you very much for having me today. I am delighted to be a representative of the team to present our research work with the topic of seamless localization system based on indoor-outdoor environments using signal strength for Android platform system. We are from University of Professor Ta and Mr. Sanasami from Lao member, and then we have collaborative with international institutions such as with Dr. Lukito and with Dr. Widyawan from Gajah Mada University, UGM in Indonesia, and then with Professor Dr. Hamamoto in Tokai University. The outline of the presentation include introduction, existing work, and implementation and performance of the seamless localizations and the experiment results. Let me start by giving you some introduction and breakout of the localizations. You may know that mobility tracking has been currently be important needs for many people in order to integrate different such as indoor or outdoor conditions together with integrate with some smart systems, localizations and location awareness is one of the example to implement the system to sense the position in physical and computation environments, such as the current location, relative location, the people, and the accessible, the device and network connectivity between indoor and outdoor, and also overall area. Yeah, from this kind of work, we have a lot of technology and have a lot of things to do in terms of seamless localizations, because this is not new project to implement, but we have tried to find some mechanism to apply to our system. The previous work, maybe they have something that also interesting, and we also try to apply something. And you may see from here, maybe they use from GNSS and Kalman filter, GPS and GSM, and use some attached device like Arduino and something for vehicle tracking system. Now we are moving to the implementation and performance of the seamless localizations. The figure that you have noticed from the slide, this one is our case study for the seamless systems. And we have combined between two conditions, such as outdoor and indoor, and also we know that the system also use different technology. Example, indoor we also use the other one, and the outdoor also use the other one. That's why we would like to combine all of them to be a complete system without any obstacle and connection seamlessly. And for our work, we have applied for the Wi-Fi in terms of indoor detection, and then GPS and GSM for outdoor detections. And this one we also have used smartphone based on Android application, and then the application also can detect from outdoor to indoor and vice versa. Here is the integrated system design framework that we have implemented. We not just only use for the signal strings, but we have developed some models based on ontology in terms of outdoor, and then outdoor from the scale of the location, and then we have applied some fuzzy logic and probability conditional to apply to the system, and then we have conclude to the receive signal strings for the implementation and performance. And for our results, we also have many things that we have achieved, and this one is one of our project that we also have achieved from the combination between Wi-Fi and GPS. Yeah, this is about the indication of the signal strengths when you move from outdoor to indoor and indoor to outdoor, and then the graph will be slightly increase and decrease depends on your current position. And we have applied and we have set up some membership degree to apply to the system based on signal strength indicator. Some results from our current work, and now turning our attention to the result of the experimental and then discussion. As you can see in here, we have developed some Android application to detect the localizations and positioning based on outdoor and indoor, and they work seamlessly without any changing or switching to the other application. You just use only one complete system, and then the system just switch for a moment, and then the system will change the situation to the outdoor or indoor or overlap area. It depends on your current positioning that you are standing, example. Yes, and from this one, we have developed something, and then maybe you can see from here the outdoor signal detecting from here. This one is the situation that you are outdoor, and then you are moving to the indoor, and then the application will detect that you are outdoor in terms of signal strengths, because from this situation, the signal of the GPS and CSM is higher than the other one, because we calculate and we can classify from the provide technology in terms of indoor and outdoor. And then when you move to indoor location, and then the status or the situation will be changed in terms of indoor signal detecting, and then and then when you are moving to the other specific rooms, and then you are able to find the location and the direction to that place based on your destination. Yes. And then during the indoor processing, we also have several kind of technology. Example, we have Wi-Fi, and we also have Bluetooth low energy and pedometer to count our step, and then to calculate that how long from your current situation to the destination. And then, of course, this one is we just focus on Wi-Fi, and then the other one we also will combine all of them. And then the reason that we combine is to be ability for us to the system. Yes. And then here the some results that can be described on the graph, and there's the user that move to the indoor and outdoor, and then the graph will increase and decrease. It depends on your current situation and current your positioning as well. And we have summarized. We have some collect some value that we can calculate from this one, and in terms of signal strengths. And then when you are outdoor, the GPS will be work, and then or will be activated, and then the Wi-Fi will be activated in terms of indoor, and then we'll change the situation. It depends on situation. Yeah, there is our result, and then we are planning to submit this work to the international level. Example, like conference paper that we would like to apply some our outcomes or an achievement to the international level. Come to our conclusion. This one is we have some Android application that the accuracy of the indoor and outdoor is about 98.4, and then 97% in terms of the certainty value of the current location. Yes, and then here is some difference, and then we have done some publication in terms of this project, and then we have also some international paper and international journal that also have published, and then we also have a kind of thing, and this is just a part of our project, and then we have done something, and then we are going to continue our work in the future and with the international collaborative. Okay, thank you so much for your attention, and then end up with my presentation. Thank you so much.
Thank you, Dr. Kamla, for your presentation. So we have 4 minutes for question and answer. So any question from the floor?
Maybe I can ask something.
Yes.
Dr. Kamla, at the moment, what is the accuracy in terms of localization accuracy? The one by 99%. I think probably I'm not sure what that is. That the accuracy based on location localization or based on what criteria?
the equivalency from that value is based on certainty value that you detect from current location, that we collect some data from collaborative, from what? From GPS, sorry, yeah, from GPS
Yeah.
value.
So it's not the actual location, right? You do not
Yes.
know the actual location. I mean, 1 meters, 10 centimeters. What is the accuracy at that level?
From the level is about 1 meter to 2
1
meters.
meters.
Yes.
Thank you. Thank you.
Any other question? So I have one question. In your scenario, you have the GPS and the Wi-Fi. So you study about the seamless detection of the localization. So in the case that when we go to the building, inside the building, that the Wi-Fi is not connected, in this case, you still use the GPS, right?
We have the other one, as I mentioned, that we have Wi-Fi and Bluetooth low latency and pedometers for indoor. Yes, for outdoor we and sometimes we also use the GSM. What I mean to say is about 4G or mobile signal inside the building also.
Okay. So did you compare about with Wi-Fi or with GSM? So the accuracy of the localization?
Yeah, actually our purpose is not compare with other, but the main purpose of our project is combine the technology that already existing and then just try to let them work together seamlessly in terms of outdoor and indoor, and then also we try to have the alternative for the user in case that if you are enter to the building and there is no Wi-Fi, but of course you still have the other one to conduct your system and then to continue your work. To continue your system to the destination. But the equivalency also, we also think about that in terms of indoor. And as I said earlier, that we have around 97%. This one is about from certainty values of the current location. Yes.
So thank you very much, Dr. Kamla, for your presentation. Very good presentation. And so now we move to the next presentation. So I would like to invite Dr. Malais Shetty Sheikh Abdulhamid from University Technology Brunei to do presentation on teaching the Arabic language to children using a phonic education digital mobile application. So Dr. Malai, the floor is yours.
Thank you very much. Okay, good afternoon, everyone, and welcome to our session. Allow me to share my screen. All right. Can you see my screen? Okay, can you see my screen?
Yes.
Okay,
please.
all right, good. Okay, first of all, a very good afternoon to everyone, and thank you for listening to my presentation. Today, my presentation is about teaching the Arabic language to children using a phonics educational digital mobile app. Now, for my presentation, I'm the project leader, and my name is Dr. Zeti, and I also have a project member, and her name is Mrs. Aklima Harris from the UK, and she'll be doing a co-presentation with me in a bit. Okay, just a little quick background that I work at University Technology Brunei, and you can see some of credentials on your screen. And this is my co-presenter for this afternoon, Mrs. Aklima Harris. Okay, moving on to my presentation. Today, I will talk about, my presentation will cover the following things. Firstly, problem statement, and then status of Arabic language, objectives of phonics program. I'll cover literature review, reading in Brunei, and use of digital mobile app, and of course, ongoing collaboration. So now, talking about the problem statement, what is the problem statement that we will share? Firstly, it's to promote reading through an educational phonics program using a mobile or digital platform, and to support digital literacy for language learning. Now, currently, one of the world's most spoken first language includes Arabic and ranks top 5th. If you look at the number of speakers, for example, 319 million speakers are first language speakers of Arabic, and my co-presenter will talk about this later on. Now, what is the purpose of having a phonics program, you may ask? We have two main objectives. Firstly, we would like to provide support for reading to children through a phonics approach to build literacy skills for the Arabic language. And secondly, is to provide support for digital literacy through mobile or digital platform to prepare students for the 21st century. Now, according to the literature, there has been some research to prove reading skills, for example, and phonics is one of the things that we highlighted. So my study has also been, has resonance in the US, where in the US, they talk about dual language immersion as according to Ryan 2013. And another study is by Harvard University by Paula Uccelli. She talks about academic language in 2014. And the next one is also a continuation of the academic language, which helps promote phonics and reading, is by Aguilar, Uccelli, and Galloway in 2019. And of course, in talking about academic language again in English only settings. And for my own personal study, I touch on cultural literacy as social cultural practice in 2021. We also talked about how literacy is very important for children and it's part of the culture. In order to learn a language, you also have to learn the culture of the language. So that was part of my study, which I presented in 2021. So that is my location where I come from. Now, on development in phonics, okay, an overview over the last 20 years. Why phonics? Back in 1965, it started with synthetic phonics and it's been invented by Blaise Pascal in 1655. And then we moved on to something called a whole language approach. And this was developed by Goodman and Smith in 1970s. And they talk about the simple view of reading from 1986. And for example, in the US, they talked about balanced literacy. And in the UK, we talked about searchlights. It wasn't until in 2020 to 2006 when, according to the Ross report, a lot of people talked about how literacy is so important and you have to go back to synthetic phonics, okay? So part of the reason why we're doing this, we'll share with you in a couple of more slides. I'd like to move on now. Okay, so what are the issues that we face here in Brunei? Some of the common issues are that there are low reading skills in Brunei. And daily communication is always localized in languages such as Malay and English. In Brunei, Malay is the first language and English is the second language. Of course, there's always something called reluctancy in reading. So we always have this issue about reading, and any kind of phonics program will definitely help children to read better, to read faster. Okay, so if I just go back to reading scores in Brunei, according to PISA 2018, 48% of Brunei students average scored less than OECD standards of only attainment of level 2 in reading. And on that note, any kind of phonics program, as I mentioned, will definitely enhance your reading skills and support any digital literacy. So if I were to share this chart or results back in 2018, Brunei scored at 408, which if you look at this here, is way below OECD standard, and we are much below by 400 and, well, about 87 in a sense, okay? So this is where we scored in reading. So reading is definitely an issue for a lot of children in Brunei. So now, going to what we think, we propose. If you teach phonics using a digital or a mobile app, it will definitely enhance your reading skills and also foster your digital literacy skills, all right? So the rationale being that if you use it cross-language and cross-cultural to learning another language, example, the Arabic language, you will definitely improve your reading. And rationale 2 being that, for example, if you use phonics program for faster language acquisition, you can now do it using mobile or digital apps, because this is now the feature, especially in the era of the pandemic and COVID-19. We are staying at home, and the best thing we can do is to teach children via online, and digital apps are probably the next best thing. So now, our program, okay, in phonics is that it will focus on the 4 basic language skills. We're using a holistic approach. You focus on listening, on speaking, reading, and writing. And if you look at worldwide, the issue of illiteracy in Southeast Asia, for example, about 678 million people in the world of Asia, in the whole Southeast Asia, but the literacy rates are about 68 million. That's quite a big amount of illiteracy going on in Asian countries as a whole. And for that, I would now like to pass on to my colleague, Mrs. Aklima Harris. She will then talk about a phonics program that's already running, and she will tell you more about this. Mrs. Aklima, I will pass on to you. Thank you very much for listening. I'll pass on to you now.
Thank you very much, Ziti, for your kind introduction. As explained, my name is Aklima, and I am speaking as the founding director of Flexiphonics. So Flexiphonics is a new program that's new to the market. It's an interactive phonics program that uses songs, stories, and actions to help children learn how to read whilst having fun. Our rationale came from noticing that there's a problem in the market at the moment with the majority of Muslims. 85% of Muslims are non-native Arabs, and a lot of the programs that teach Arabic, especially to early learners, are in Arabic, so only 15% are able to tap into them services, and the rest of us, 85% non-native Arabs, struggle. And what we do is we have to wait until our children are at a learning age, maybe 5, 6, when they can pay attention more, and then we send them to school, mosque, Ugama, etc., where in which they can sit and learn the conventional way. So because Arabic is the second most globalized language in the world, we decided it's extremely important that we create a program to be able to tap into young minds. So the current whole word approach in Arabic, it results in the loss of prime learning time. And our children, as we're aware, early years learning, there's so much research to suggest that between 0 to 5 is the time they learn the most. So to be able to maximize during that time, it's extremely crucial. So Flexiphonics is the cornerstone of good education system that understands the correlation between reading, understanding, and academic success. So we use the strategies like listening skills, kinesthetic learning. We put it all together to make sure we're catering to all of our learners. We have a team put together. So myself, as I mentioned, I'm an international educator. I'm currently in Brunei. I was teaching in UAE before this, and before that in the UK. I'm an Arabic specialist, and I am the founding director of GEMS Nursery in the UK. I also have a team of international teachers, Montessori specialists, child psychologists, and speech and language therapists, ensuring that our program is a holistic approach to teaching children. These are the learning outcomes that we hope that our children attain after our program, and we have results to show. So our program has been piloted in the UK and in UAE, and we found that children have a better grasp of the Arabic language, recognition, pronunciation, and letter formation than those who are conventionally taught. If you'd like further information on this, you can refer to our website. We're just for a summary, Phonics is a program. It's an ideal way to start Arabic literacy reading program for very young children, and it's proven to bring amazing results and get children reading in a very short space of time. Our approach is the most effective way to turn content into something meaningful. With songs, stories, games, children can learn their correct letter sounds, pronunciations, while having fun, thus laying a strong foundation for their future. We're really excited at the moment to be doing a collaboration with Dr. Ziti and UTB. The findings of our research proposal will be groundbreaking in informing language pedagogies and improving literacy skills in Brunei and throughout Asia. We're also looking to collaborate with anybody else in this forum. So it's really exciting hearing what you have currently going on, and we're looking to build more partners throughout Asia to trial our program and to see how our phonics can be used through multiple languages. Please don't hesitate to get in touch with us on Flexiphonics on our social media pages or on our email, flexiphonics@gmail.co.uk. Thank you very much for giving me this platform, and if you have any questions, by all means, please don't hesitate to ask.
Thank you.
Thank you very much, Dr. Malai and Ms. Alima, for your presentation. So now, do you have any question? I would like to give the floor for question. Yeah, please.
Can I ask the question?
Yeah, go ahead, please, Karen. Thank you.
Okay. Thank you, Dr. Malaizeti and Dr. Aklima.
Yeah.
Yeah. I would like to know what is exactly do you need? Is it application software, or is it something with hardware, or?
Okay, currently we are
Because
currently,
you have data, right?
yeah. We're currently running the program and we're turning it into an app. So what happens is that we will turn the program into, it's currently being digitalized, so we're turning it into an application.
Okay.
So all the program, the software, all the things that we've got in the program for teaching phonics, which used to be done traditionally, we're now moving into an app. So anybody around the world can use the app, download the app, and also have the same kind of element of information to do better in phonics, using phonics approach.
Okay. Yeah, because I have worked with one of my ex-students in the area of using Kinect for deaf students or deaf children or something like that. But okay, this is something else, right?
It's
Maybe.
definitely else. It's a program where you can actually teach it to children, but we're now going digital. So we're going towards digitalization. So this will be provided on our app that we're currently building. So we put everything on an app, and anyone can learn phonics languages by just downloading the app. And it will help you learn languages faster. In this case, we're focusing on Arabic language to start first. And through our research, then we'll proceed to other languages. So that's the whole program.
Okay, now I understand. So you are creating practically a mobile app for your phonics.
Yes, to teach reading for children. Yeah, for different to cater for different people.
Arabic language. Yeah.
Yes, correct. To start with Arabic, definitely. Yeah.
Okay,
Mrs.
thank you
Aklima?
very much.
Welcome. Mrs. Aklima, is there anything you want to add on? Mrs. Harris?
No, I think you've covered everything. Thank you.
Okay.
Hi, I have a question.
Go ahead.
NICT. Just wondering, is there any other apps, like already, the apps that already teach Arabic? Is there any other app available already? And if so, how is your app different than, the one that's already existed in the market?
Okay. Mrs. Aklima?
At the moment, yeah. So at the moment, there's currently nothing available that caters to teaching Arabic to earlier learners. So there is a lot of Arabic programs. There's a lot of early years programs that teach English Arabic to be taught by using phonics in an early years program in English. So this is the
that's
first
the difference with our app. Correct. Yeah, because English is universal to a lot of people, and it's probably the most international language around the world. So by doing it via English platform, anybody can learn. Even if a child can learn it quickly and navigate it. We make it so user friendly as well. Even a child can run through it. Even my 3-year-old, 4-year-old can just go through the app, and even my 3-year-old knows how to use TikTok. So imagine the future for the children nowadays. Yeah.
So the user can be any nationality, like who just want to learn, who understand English and would like to learn Arabic.
Yes, that's right. Absolutely. Yes, that's correct.
Okay, thank you.
You're welcome.
Any more questions?
We always look forward to collaborators as well. Yeah.
Yeah. Okay, so I think there are no more questions. So thank you very much.
Just a comment, maybe. It's quite interesting. Maybe we can even extend this app to different other directions. Yeah.
Yes, it's definitely.
We call Flexifonics because
although
we launched with Arabic, we are very interested. The idea and concept behind Flexifonics.
I would like to work together with you, right?
Oh, okay.
Because
we would love you to join us.
Yeah,
because we have.
Concept is that
because I have also a quality.
Therefore, it's not limited to
I have also a quality which have augmented reality expertise.
Okay, it's good. That's good. We're always looking forward to that. Absolutely. Thank you.
Thank you.
Thank you very much for listening. Thank you.
Very much.
Have a good day. All right. Thank you.
Yes. So now we move to the last presentation.
Thank you.
So I would like to invite Mr. Lee Hyung Bung from Cambodia Academy of Digital Technology from Cambodia, who will present on the presentation titled Multitask Sequence Prediction for Natural Language Processing. Mr. Lee Hyung, the floor is yours. Mr. Lai Hyun, you are unmute now. We did not hear you. So, Mr. Lai Hyun? I did not hear Mr. Lai Hyun.
You're unmuted, but there appears to be a problem with the microphone on your end.
So, Mr. Lee Hyun, do you hear us?
Hello, can you hear me?
Yes. We hear you.
Trên cho mình. Nó full screen này.
Okay, so Mr. Lee Hyun, you can start now. We see your screen and also your voice. We hear your voice.
Okay, I'm going to start now. Good afternoon, I'm Lee Hyun from Cambodia of Digital Technology, and I'm glad to be here today to present about my project, which is called Multi-Task Sequence Prediction for Natural Language Processing. So I have divided my presentation into the following points. First of all, the introduction of this project. Secondly, the related work. I'll explain briefly about the existing multi-task system. Thirdly, I'll give an overview of the dataset and method, and then I'll explain, interpret the result I interpret the result from the experiment, and finally the conclusion. Without further ado, let's move on to the introduction. First of all, let's start the definition of multi-task learning. Multi-task learning is a learning paradigm in machine learning that aims to leverage useful information in multiple related tasks to help improve the generalization performance of all the tasks. And the transformer architecture, which used in the proposed model, is a novel encoder-decoder architecture that based on attention mechanism for transforming one sequence into another without the use of recurrent network. For example, recurrent neural network and long short-term memory networks. So recent study always claim that transformer outperform LSTM on multiple tasks. For example, language translation, ASR, and many more. But is there really an improvement from LSTM to transformer? So the problem with the LSTM is that it cannot be trained in parallel due to the sequential processing behavior of the recurrent network. And this results in higher demand of resource to train and longer computation time than attention-based model. So we are interested in extending the existing cascaded multi-task system based on LSTM architecture with a sophisticated architecture that is transformer. And we are also interested in studying the behavior of cascaded multitask learning on different NLP problems, including morphosyntactic tagging, machine translation, and constituent syntactic analysis. Now I'll explain the existing multitask sequence prediction system. So the hidden state of the encoder are passed into the decoder, and the hidden state of the previous decoder also passed into the following decoders, and it produces the predicted output. And the loss, we can get the loss by comparing the predicted output and the expected output. And the global loss can be computed by the summation of all the losses. Since we have 3 experiments, first of all, I would like to introduce the Tiger dataset, which is for the morphosyntactic analysis. And Tiger was annotated with morphosyntactic information. It takes German sentences as an input, and we will try to predict the post-tag and morpho. And we will use this on the transformer architecture. Secondly, the WMT14 for the language translation, we take the English as English sentence as an input, and the remaining language, for example, Czech, French, and German, as the for the prediction. And finally, the WFJ dataset. We also have 3 different datasets for this WFJ. First of all, the base version, then the byte encoding 16K merge operation, and finally the byte encoding 32K merge operation. We take the English sentence as an input again, and for this constituent pass-3 task, we would like to predict the post-tag, segmentation in chunk, and the pass-3 in sentence format. So let's move on to the method, the proposed method in this project by extending the transformer into the multitask system. So as I mentioned, as I showed earlier, in this case, we would like to remove the LSTM encoder and replacing it with the transformer encoder. Basically, the results that we get from the encoder output are from LSTM are different from the encoder output from transformer. So in this case, we filtering the encoder output to the exact same thing as the transformer, as the LSTM one. And at this point, the rest of this process is identical to the existing system. Now let's move on to the result. These are the best hyperparameters used for the existing system. And if not mentioned otherwise, we'll be using this hyperparameter. And the system was built on the FAIRFEX framework. And before we can evaluate on the machine translation and pass-3, we need to do some post-processing on the generation data. That is removing the BPE unit, which is the double add sign, and as well as the sequence separator sign. The same also applies to the constituent pass-3. Now let's take a look at the results we get from the LSTM. So this is the lowest result we got from the existing system, the loss. So I would like to point out that for loss, the lower is actually better. So if we use the exact same hyperparameter, as you can see that we get a significant amount, significant higher loss than the LSTM one. So we did hyperparameter tuning to get the better result, and the better result still only a little bit better than the default hyperparameter. And as you can see in the accuracy for post-tag, we get like 98 and 93 for post-tag and morpho respectively for LSTM. But for transformer, the best one, we only get like 34 and 22 for post-tag and morpho respectively. For the language translation, as you can see, the evaluation is based on blue score. So the blue score between 20 to 29 is actually, we can get a gist of it, but there are many grammatical errors. And for the blue score between 30 to 40, it's a good translation. And as you can see, from the English to Czech, that is a single task translation. We got like 29 blue score, and from English to German, we get like 31 blue score. But for the multitask setting, multitask translation from English to Czech and then to German, we only get like 28 and 27, and then 30 for German and 26 for Czech. So the single task one is actually better. So we would like to try to add another language, which is French. And then we can see that the result is still the same. Like the single task still perform better than the multi-task one for Czech and German. As you can see previously, like 29, but now it's only like the best one only 26. And for German, the best one is around 31, but in this case, the best one is only around 27. For the result for the WSJ, the constituent pass-through, we can see that there are 3 data sets, but the by-pair encoding 32K merge operation actually got the best loss, which means the lowest loss for both the 2-task and 3-task model. But for the accuracy, we can see that the BPE perform better on post-tag, but for pass-through, the base one actually perform better. As you can see for the 3-task one, the base one actually perform better. So we did an evaluation on the Evolve, and we can see that for the 2-task and 3-task, we can see the F1 measure for the pass-through is actually better for the base one, but the BPE 32K actually perform worse. And in conclusion, for the first experiment, the tiger corpus, we conclude that the problem is more related to the hyperparameter optimal choice, not the implementation. And that is not a trivial problem as long as the transformer encoder and LSTM decoder hybrid is kept. And for the second experiment on language translation, we proved that jointly learned to translate multiple languages does not perform better than a single task counterpart. The same conclusion also applied to the constituent pass-through based on the outcome of the 2-task and 3-task model. We believe that the chunks are actually not improving the result of post-tag and pass-through. And that is the end of my presentation. Thank you for your attention.
Thank you very much, Mr. Lee Hyun. Okay, so we have 4 minutes left for question. So I give the floor for the question, please.
I can ask something. Can you give a bit explicit semantic of the task that you have? Can it be pinpoint? What is the semantic of the task?
You mean the objective of the task?
No, when you say multitask, right? That's like a subjective, or you can pinpoint into the real semantic meaning of it. What is the meaning of the task there?
So as I did give the definition of multitask learning, it's actually is a learning paradigm in machine learning that aims to leverage useful information in multiple related tasks to help improve the generalization performance of all the tasks. So let's say, for example, language translation. We have English as an input and other European language as the task that we need to predict to learn, and that multi-tasks are Czech, German, and French. So we would like to learn.
Okay, so you like the model to be able to learn, train on one task, apply to another task. Is that the concept, right?
Yes.
Yes. Okay. All right. Can you explain a bit about your transformer architecture? How many heads are there?
So you mean the hyperparameter for training?
Okay. From your diagram, right? It looks like your transformer output from the encoder then go directly into 3 branches.
Yes.
Yes, is that right? Yeah. So so that output from transformer is from one head.
No. Actually, we because this was based on the existing system that based on LSTM. Okay, so LSTM take the hidden state as an input for the decoder. So we need to filtering out the encoder output. For example, like the positional encoding, we don't need that. Do you understand?
So the LSTM, when we output, we can specify that we need the sequence plus the state, correct? We can specify in the LSTM that we want the state and the sequence that coming with each state as well. So I think there's some difference between transformer and LSTM. So what you explain is that then you change LSTM to be transformer so that you adjust the output in such a way that it matches with the LSTM before, right?
That's it.
The three model there. Can you but that is not what you mean by multitask, right? When you say multitask, you actually mean the actual task of doing French, English, thing like that. Is that correct?
So for the task, I mean the decoder. For example, this decoder for example, language translation. Suppose that it is language the language Czech. Decoder 2, for example, German.
Okay.
3, for example.
Thank you. So that is what you mean by multitask. Okay. Thank you.
Okay.
Okay. So thank you very much, Mr. Lee Hyun. So now it end of the presentation, and thank you for the fruitful and very informative for presentation, and thank you for all. So now we come to the end of session 6. So if you have any question, you can contact directly to the presenter. So yes, I would like to thank to all, and I would like to conclude the session. Thank you very much.
Thank you very much.
Thank you very much, Dr. Sam, and all speakers. It's time to start the last session, and session 7. So this session will be chaired by Professor Blatt, and we are behind the schedule around 35 minutes. Please keep the time by yourself, and Dr. Sam, please.
Afternoon, everyone. May I request all the participants to open their camera for. Okay, thank you very much. You may now turn off your webcam and your mic, and then let us listen to the pre-recorded presentation of the 23rd paper, the title of which is A Study on Applicable and Improved K-clicks Method to the Recommendation System by Dr. Ilya Kone
from National University of Laos.
My presentation today is a study on applicable and improved K-CRIS methods to the recommendation system. Here is my content of presentations today. Today, the users in online social media are increasing rapidly. Then the size of the social network community is vast and very intricate. The relationships among the users in this network graph might be beneficial. Classify users from this network graph into the various community is a grand challenge for the multiple researchers. So we develop and improve K-CRIS method to find the sub-community from these networks. Proof that this method is very efficient in the community detection from the various network graphs. It is a challenge for my research. As we know, the primary strategies of the business over the internet is a recommendation system, and according to number of items has increased to become more concrete. So to find items that users are looking for through the existing technology of a recommendation system is quite a little bit hard. The most current recommendation system, for example, in YouTube, Netflix, or TikTok, they are using collaborative filtering methods. And here is the methods that's included in the collaborative filtering. But they also have some problems like cornstarch, data sparsity, and scalability when we're using this method. For example, Netflix, they are using viewer rating, viewing history, information about the category, year of release, title, genre, and more. Auto viewer with similar watchings, preference, and tasks. Time durations of the viewer watching a show shows the device on which a viewer is watching, the times of the day a viewer watched. Based on the fundamental knowledge about the user who have the similar feature information, they might write the same item. Therefore, the main motivation are the risings, creates an efficiency network graph from the similarity among user personalized information, find an efficiency methods on community detections in various network graphs. Prove the knowledge of user who has similarity personalized information might write the same item in the recommendation system. Find an algorithm on increasing accuracy in the recommendation system. Here is a related words for related words. The first one is FCA. For the FCA is a techniques of the data analysis that describe the relationship between a particular set of attributes and specific sets of objects. There are two types of outputs, concept practice and attribute implication. How to create the FCA network graph? First, create a formal context from user personalized information training datasets. Then create a concept practice from the formal context. After that, the attribute implication functions or associations rules function used to create a relationship table that's described as the relationships among the user. Finally, a network graph was created from this table. What the next is the K-CRIS. K-CRIS is a technique in the social network analysis used for analyzing data in the complex community of the community from the network graph that have a value of K-CRIS. Improve K-CRIS. Develop and improve K-CRIS methods. First, the training dataset is created from the movie rent dataset. Second, this dataset used to create a network graph. After that, applies K-CRIS to cluster this network graph into a several community by using a value of K equal to 3 to 14. Later on, a suitable community will find new user. Finally, list of 5, 10, and 15 movies from the suitable community will be recommended to a new user. Afterwards, we perform experiment randomly for each dataset. For the proposed methods, we divide into 4 methods. For the first one, we study, develop, and apply a social network analysis methods, network graph methods, detecting a community from the network graph using K-Crix, develop and improve K-Crix method, similarity measure methods, collaborative filtering methods. For the second method, we study, develop, and apply a network graph technology, data mining technology, improve algorithm of the purpose work. For the third method, we study, develop, apply on the various like social network analysis, between net, century plus KNN, normal discount cumulative gains methods, improving algorithm of the purpose work. And for the last method, we study, develop, apply on the formal concept analysis methods, creating a network graph based on FCAs and various parallel processing techniques. This is the detail of the method 4. First, we use moving datasets, and then we create a network graph using FCA. After that, we divide into the various community by using K-Crix and do parallel algorithm. After that, when new user come to the system, the new user will verify for the suitable community for them. After that, list of recommending moving will be generated by using data mining and do parallel algorithm. After that, the recommended movie to the new user will be generated by using data mining. To find the suitable communities, we use the KNN and between centrality methods. For the evaluation, for datasets, we use moving. And for accuracy measurement method, we use mean absolute percentage errors. And here is the existing method that we use to evaluate our proposed work. Here is the result of each methods. For example, result of K-Crix, result of maximal Crix, result of using collaborative filtering, and the comparisons of the all methods. Here is the result of the method 2, and the result of the proposed works for K-Crix, and KNN, and POCF. Here is the result of method 3 for the proposed method K-Crix and AR, K-Crix and CF, plus KNN plus NDCG. And here is the result of the last. We can see is when we use to parallel processing, our time that we use for experiment is decreased from 48 hours to 12 hours. Conclusions. The major significant finding, we are the first on develop and apply the various methods. We develop a social network graph from the feature similarity among the user, apply K-Crix method to the classified community in the social network graph. Develop improve K-Crix methods, applies improve K-Crix to the recommendation system. Develop a network graph from a formal concept analysis method. Applies an FCA network graph to the recommendation system. Applies the do parallel algorithm to divide the proposed works algorithm into the several processes, then execute them as a parallel processing using the multiple core CPU. The results of experiments was improved that and improved K-Crix was efficient in detecting the community from the various network graph, very significancies, increasing accuracy in the recommendation system, solve a cold start problem. For the feature study, refer to the limitations of the experiments set up, limitations of the datasets which provide a few feature information of the user and the complexity of the proposed algorithm. In the future, the various type datasets and various feature information of user will be applied to the proposed work. The proposed method algorithm would be modified for easy to apply in real work. My presentation is finished. So for any suggestions, comments, and questions, please do not hesitate to send an email to me. apologize. Thank you very much.
Okay, thank you very much. Again, may I request everyone to open your respective cameras. So we'll again take a photo of all the participants prior to the second center for this session. Okay, I am requesting everyone, please. Is it already okay, Sarah?
Yes, okay, sir.
Thank you. Thank you very much. Okay, you can now turn off your webcam and we can proceed to the next center, number 24. The title of the paper is Transfer Learning-Based Object Detection and Classification, to be presented by Ms. Yu Min of University of Computer Studies, Yangon, from Myanmar. Okay, you may start your presentation. Ms.
Yes.
Min, go ahead.
Yes. Hello everyone. I am from University of Computer Studies, Yangon, Myanmar. Today I would like to present about transfer learning-based object detection and classification. These are the contents of the presentation. I would like to introduce about the presentation. Object detection allows us to identify and locate objects in an image or video. Object classification is a process of detecting a specific classified label for an object in an image or video. Deep learning is deep learning have been sorry. Deep learning technology has hello. Deep learning technology has been successful in many fields in recent years, including computer vision. Transfer learning is an approach in deep learning and machine learning where knowledge is transferred from one model to another. During the process of transfer learning, 3 points must be considered. The first point is what to transfer. It should be identified that which part of the knowledge can be transferred from the source to the target in order to improve the performance of the target test. The second point is when to transfer. Transfer learning techniques should be utilized only if it makes the target test performance or research to be improved. The third point is how to transfer. After the first and second points are finished, ways of transferring the knowledge across domain or tests can be identified. Of the presentation are to classify objects using transfer learning technique, to detect objects using region proportional network, to use the detection and classification results via web browser, to make comparison or transfer learning technique using the proposed data set. I would like to tell about motivation of the presentation. Fast and accurate object detection classification systems are rising in demand. Traditional feature extraction techniques make a hand content to extract features from the image. Deep learning technique requires a very large amount of data set. Obtaining large data sets is as remain time consuming. Training is very expensive for a time and resources in order to get large and effective deep learning models. This figure shows the overview of the system. The dataset is collected by using PoE support IP camera. Transfer learning technique is used to obtain the customized model in order to detect and classify objects in the proposed dataset. The obtained customized model is deployed to Raspberry Pi. The resulting frame for the test image can be seen via web browser using the FlashWeb framework. The proposed dataset contains 3,000 images. The dataset is split into training, validation, and testing dataset, which contain 1,920 images, 600 images, and 480 images respectively. The categories of class are as follows. I would like to share about transfer learning. One of the most well-known transfer learning technique is fine-tuning. The first issue for using fine-tuning is that trained models are only partially transferred by discarding test-specific layers and fine-tuning module layers. The second issue is that by placing weights in lower convolution layers and retraining weights in upper layers using data from the target domain, parameters of the target model may be driven far away from initial value, which also causes overfitting. In order to solve the first issue of fine-tuning technique, fine-tuning is used. Suppose that S0 is a bitrate deep neural network, YS is a source category, and YD is a target level to length category relationship. The mapping YS to YD is firstly learned from F0 or HD, YD best, where F0 or H is approximately equal to probability of YS given A is a probability distribution over YS. Probability of YS given YD can be computed from probability of YD given YS by base rule. To be reflected with high fidelity of the probability output all source categories of F0 or H category relationship learning mentions the calibration procedure. This table shows the category relationship between proposed dataset classes and image-net dataset classes. For example, class in proposed dataset is highly relationship with moving type class in image-net dataset. To solve the second issue of fine-tuning technique, behavior-based regularization using feature-based attention is used. Behavioral regularization is that the distance between the network behavior is considered to regularize the behavior of the networks. Feature-based extraction from convolution layer is that each feature of the network from the target dataset is used to get the corresponding output. A weighted feature mask with supervised attention model is that the weights of features are characterized by the potential performance loss when removing these features from the network. In order to locate the objects, region proposal network is used. To generate region proposal, a small network is slide over the convolutional feature map output and the large convolutional layer. Multiple region proposal code and class are simultaneously predicted at each slide given location. The region proposal network is trained for the region proposal test. The Flash web framework is used in order to use the resultant training web browser. Flash is a popular micro web framework written in the Python programming language. Flash is very lightweight, making it super easy to build easy web applications. These figures are the sample resultant frames. In order to evaluate the performance of the customized model based on the classification accuracy. And the proposed dataset is trained by using the hyperparameters such as learning rate is 0.001, momentum is 0.9, weight decay is 0.0005, and number of approach is 100. According to this table, conditioning technique and behavior-based regularization techniques are more accurate in classifying objects than fine-tuning techniques. In conclusion, this system is implemented using transparent technique and pre-trained rational predictive model based on image data set. It's used to generate the customized model. A customized model can be built by using transparent even if there is a small data set. It also makes us to save training time. The process information can also be viewed by our web browser. These are the references of this presentation. Thank you for your attention.
Professor Prala. We can never hear you. Professor Pralat, we cannot hear anything from you.
Hello? Your mic is set to off.
Yes.
No, sorry, Professor Ballard's mic is set to off.
Yes, yes, no. Hello? Can you hear me?
Yeah, we can hear you.
Sorry, the chair of this session has his microphone turned off. My apologies. Professor Ballard? If anybody has any questions for the presenter, please feel free to ask them now.
Okay, yeah, maybe I can ask something. It's not really a question, but maybe what kind of environment you are looking for? What type of application you are looking for in this? What in your mind when you plan to do this at detection of car, people, and what is the need for that detection? What do you use it for?
Yes, the objective for this system is to use in campus monitoring system.
Right. So you want to detect people and car like that, right?
Yes.
And pass. So I would assume that the Wi-Fi signal should be good. Can we assume that? Can we assume that the connection, the Wi-Fi will be good? Because I think, okay, my point is that I think the design of the process and the hardware and the software depend a lot on what you want to get at the end. Like if it's going to be put at the edge where there is no Wi-Fi, that means you need to have the model inside, right? Or if it has the Wi-Fi, maybe one option would be you actually get and then send over the internet to retrieve a very, very high quality prediction. The design decision like that. So I think if you are clear on what actually to get, you actually can decide the process in more detail, and you can be more like precise on what you want. Just the idea. You're doing, yeah. Thank you. Very good presentation. Thank you.
Thank you, sir, for your suggestion, and thank you to the National Institute of Information and Communication Technology for supporting the camera and Raspberry Pi transmitter.
Thank you. Is there some question from audience? Not anymore? Thank you. And may I ask you one? So what kind of the application are you trying to develop? What kind of the application? Can you hear me? Mr. A. Fo Min?
Hello?
Yes. Can you hear me?
Yes, sir, I can hear you.
So may I ask you one question? So what kind of application do you plan?
Yes. My application is a campus monitoring system. Yes.
You mean the traffic monitoring? It's okay?
Yes.
Thank you.
Yes.
Thank you very much. And is there any other questions or comments? Okay, thank you very much, Mr. A. I'm sorry, A. Phil Min. So let me move to next presentation. Next presentation will be presented by Mr. Ramon Van Cliff Bomel and of Dost Asti from Philippines. Can you hear me?
Yes, sir, I can hear you clearly.
Okay, please.
Thank you for the introduction. So hello, everyone. Good afternoon. I am Ramon Van Clefraro from the Department of Science and Technology, Advanced Science and Technology Institute, DOST-ASTI of the Republic of the Philippines. And I'm here to present to you our preliminary work regarding the topic, LoRa-based mesh network for off-grid SMS-style communication in emergency situations. So to start, let me talk to you about the background of this project, on the motivations and the rationale on why we thought of this project. So there would be instances where our conventional communication networks may be incapacitated, could be
Sorry,
damaged.
we didn't see your slide yet. Did you share?
Sorry. Let me share the slide.
Presentation.
Sorry for that. There. So once again, let me introduce you to the project entitled LoRa-based Mesh Network for Off-Grid SMS-style communication in emergency situations. But to give you an introduction to the rationale of this project, so there would be time when conventional communication networks could be incapacitated, unavailable, or damaged. And this could be for a number of reasons. One is natural disasters, and as we all know from the ASEAN nations, we are plagued with many natural disasters all throughout the year. So there could be also technical failures from time to time, and also the possibility of warfare where our infrastructure could be damaged. So at these times, data is very crucial for, first of all, situational analysis, to see the situation on the ground. And then once we see the situation on the ground, it's good for the next step, which would be strategic planning. And then when a plan is cooked up, then we can plan for search and rescue operations. But also, this data is important for general communications. So the proposed solution for this kind of instances is an off-grid SMS-style communication network based on low-power wide area networks, or LP1. So let me talk to you about the relevant technologies of this project. First, this project utilizes LoRa technology, which stands for long-range radio networks. So this technology is based on a mesh network, and we use this because of its low power. This can be powered off-grid through solar panels or battery. It has long range and can serve as relay as well as a node. And because of the frequency of operation, which is naturally unlicensed and it's in the ISM band, so it is free to use. So now, why did we use or choose SMS-style communication? So this actually stems from the LoRa technology limitations, particularly on the data rate. As we all know, the data rate of LoRa communication is very low. And so we also chose SMS-style communication because it is simple enough to convey crucial information, like the situation, location, or if someone needs help. So there have been relevant previous works by ASEAN IVO members. The first one is a relay station network based on low-power wide area network, LP1 technologies, for disaster management. So this uses LoRa nodes as a relay for communicating sensor data and throw this data into the next relay until it reaches a base station, which can send it to the internet and to the Center for Data Analysis and Preparation. So the second one is a LoRa-based mesh network for off-grid emergency communications, which uses an ESP32 microcontroller plus LoRa module and connects phone via Bluetooth low energy to provide an SMS-type communication. Now, the current implementation we want to do in this project is we want to use the Wi-Fi access point of an ESP32 microcontroller versus Bluetooth cost of its longer range compared to Bluetooth, its higher data rate compared to Bluetooth, and better capacity for multiple users. Remember that we are planning to use a mesh network configuration. So the configuration for LoRa is an ESP32 microcontroller and RM95
configuration. It can function as a. For this project, we use a LoRa messenger. And using the application, you can configure the frequency of operation, the spreading factor. You can also set the transmitter power. You can set your node name to set as your identity. You can also set your recipient, whether it be another node or a broadcast, and other parameters for SMS style communications. So nearby active nodes are discoverable with our SSI and possible number of hops to reach. So we know how many hops it took for a message to receive, for the receiver to receive our message. So it's also easy to use because of its intuitive chat box interface. So we were able to do some lab testing or node setup in ASTI, where we were able to set up an off-grid capability setup, wherein it consists of an ESP32 and RFM95 LoRa module, powered by a photovoltaic source with MPPT solar charger and battery placed inside an enclosure box and mounted on a pole. So as you can see on the image on the right, that's the setup. So our lab test consisted of testing capability for phone connection to the LoRa node via the Wi-Fi access point of the ESP32 microcontroller. And we, for node 3, wanted to know which nodes were active and in the area, the setting of node name, our identity as the source or sender, and the recipient, in which we can set the recipient, or if we want to broadcast the message to active nodes in the area. And then we were able also to test the basic send, receive functions, and the power supply of the setup. So the tests done to test capabilities were in an urban setting using 23 dBm transmit power, a spreading factor of 7, which means a higher data rate. We also operated at the frequency of 868 megahertz LoRa band frequency. So let's now talk about some field testing that we were able to do. So we were also able to do some preliminary field testing, although limited. And we were able to conduct the same tests, but were performed on a rural setting in a province in the Philippines where no connectivity is present. Because remember, one of the aims or one of the objectives of this project is to provide a temporary solution for communications. And we set the setup to have a 23 dBm transmit power, a spreading factor of 7, and operating at 868 megahertz LoRa band frequency. To keep mobility easier, instead of using photovoltaic setups, we used power banks instead in place of photovoltaic power supply, so we can move around the area. Our preliminary observations were that as the number of characters successfully sent to a receiver decreases as node-to-node distance increases. So the setup here is we have spreading factor of 7, and we were testing it at a node-to-node setup. And we also were able to notice that foliage seems to have great effect on the send and receive success of the setup. And we were able to infer that maybe a mesh configuration may help with issues. Because basically you're increasing your node participation. So we have our future plans for this work where we want to explore tests using a mesh configuration, as you can see in the figure in the right. So one node may be connected to multiple users using their mobile phones. And then each node will be connected by a LoRa link. And these nodes will be connected in a mesh setup. So we also plan to study the routing algorithm used and explore optimizations or an implementation of a new algorithm altogether for the optimization for this type of application. So we also want to test we will also want to conduct a stress test on the operation of both node-to-node and mesh operation on power, how long it will last, environmental conditions, how long it will last in a rainy environment, in a very sunny environment like that. And we also want to see the packet data rate, or basically the amount of success of sends or receives as the number of nodes increases or the number of users per node increases. And also we have there is a potential work to create a personalized version of these LoRa nodes, similar to open source projects like Meshtastic and Disaster Radio, wherein instead of a LoRa node that is stationary in one area, each person can carry a personalized LoRa node, which can function as a personal emergency communication device. So we also plan to involve incorporation of other essential modules like GPS to include location. And this might be essential for applications like rescue operations in times of disaster. So as you can see on the figure on the right, there are that's the example of personalized LoRa nodes, which can be used for emergency personal communications. So that's the end of my presentation. Thank you for listening, and I now open the floor for any questions. Thank you.
Thank you very much for your presentation. Are there any questions or comments from audience? Any
Hello.
question and the comments? Yes.
Can I ask a question?
Yes, please.
Okay. So, Ramon, right?
Yes, sir.
Ramon, I just want to ask. So you are using LoRa Mesh network. What is the user interface? I mean, what do you use? For example, smartphone or computer or what?
Yes, sir. The process is that a user can connect to the LoRa node using the Wi-Fi access point of the ESP32 microcontroller. So you can use your mobile phone, your laptop, or your tablet, as long as it has a Wi-Fi capability. And the user interface is an open source messenger app, it is browser based. So it's not Android, but it's browser based. So basically, when you connect to the node, to the LoRa node via Wi-Fi, the process is that it gives you a similar to a sign-in
SMS.
page. Yeah, sign-in page wherein when you access that page, it will guide you to the interface, to the chat box interface.
Okay. Okay. Following the question, just another question. You know that LoRa network is not that often existing in the areas, right? So how useful is actually this project? I mean, if there is no LoRa mesh network, then this project is cannot be used, right?
I respectfully disagree a bit with that, sir, because
Okay.
we could think of an individual LoRa node as, for a lack of better term, a base station itself, wherein multiple nodes could connect to it and connect to other nodes as well. What my point here is that we can use this for localized operations, like for example, a city coordination wherein there could be disasters in an area and there's the network is down, or maybe there's no network at all, no conventional network at all. The local government units could use these devices to communicate with, for example, people on the ground, which are able to assess the situation. So this could be used locally, but yes, sir. But we could also scale as well.
How fast you can install a LoRa network, and how much is the cost?
For the cost,
project.
for the cost, actually, sir, if we were to establish a single node with the photovoltaic supply, it may estimately cost around $500 US.
All right.
But, the LoRa node itself, if you were to buy an ESP32 microcontroller, LoRa module, and an antenna, it would only cost around $260 US.
Okay, that's fine. Okay, thank you.
Thank you, sir.
Thank you. Is there any question else? So may I ask you one? And I think you know the project relay station led by NICT Thailand. So what's the difference between you talk and this project?
Yes, sir. Actually, that project is one of the relevant previous works where this work is sort of a related literature, if you must say that. The difference is that in that project, each node is functions only as a relay in which the information from sensors are passed to each node until it reaches the base station, from which that information, the sensor information, could be distributed to necessary parties. But in this work, our goal finally is to actually create a personalized version of it, and not a stationary node where people will have difficulty to connect to for this purpose.
Thank you. So a simple one more. So what kind of the emergency situation are you considering?
Sir, I think the most possible cause for this is maybe earthquake, or maybe a landslide wherein maybe a cell tower is situated somewhere that may be damaged. So the floor might be damaged or the earth might be damaged.
Thank you. Thank you very much. And I need to move to next presentation. Thank you. So let's move to next one, the last one. This presentation will be presented by Mr. Tae-Ham Nyong from the Cambodia Academy of Digital Technology. And the title is the design and development of a certificate real-time IoT solution.
Thank you. Yep, thank you, sir. Thank you very much for your introduction. I will share my slide right now. Hello, everyone. I'm sorry, I know I will be the last one, so it's a bit of time thing. So I will be as quick as possible. So I know it has been a very interesting morning regarding the topic about IoT and stuff, and it's really related to my work. But
I'm sorry, please show us your presentation whole screen.
Oh, sorry.
Yes, okay.
Is it better? Okay, so yeah, so there has been a talk a lot about regarding using IoT and different sensoring and stuff in the different field of agriculture and thing, and it very related to the work I have been doing regarding the network protocol for using in IoT. So my topic is building the real-time network protocol for IoT. So today I have 7 small parts. I will introduce a little bit about the problem, why we build this project and the objective we want to achieve, the technology we use, and the function that I develop in order to get what we want, and the deployment setting to test if our developed function is working. And then we're looking at the deployment result, how does it turn out, and that will be following up regarding a small conclusion of the experiment. So the problem is that if you are aware of the current 60 protocol is one of the protocol using in IoT network, and this protocol is not deterministic by its own, because this protocol stack involve different protocol that is not it's not time sensitive. That's why real time is not possible in this protocol. Plus, the tree, as you can see in this picture, is that node is working and communicate with each other in the tree pattern. This, you can see, will increase more time in terms of transmission delay from one node to another. Like in case if you want to transmit from node D to the root node or the coordinator or access point, as if you like, it will have to go through its parent node, and then the parent node go to the root node. So it will have a bigger latency in terms of transmission. So that is the problem we want to address. And the other problem is that in the 60 protocol stack, there is a protocol that involved in this communication is 6TOP. So 6TOP is a protocol to conduct a communication link between node and node. And in this protocol, node have to request if they want to send the data or something, and then the root node or access node have to confirm if the node can do the transmission or not, and that communication has to go on and on. That's why we cannot determine whether the transmission is being concluded or not. So that is also the part where we will address as well. So coming from the problem, the objective that we want to build is we want to build a solution, a network solution, where node can transmit to any node in the network. If you can see here, from node A can transmit to node B can transmit to node C, and node C can transmit to node A back or whatever, meaning any node can send the data to each other without going through the routing protocol or any other protocol. So that is what we want to build, and we want to make sure it's transmitting in a timely manner. In order to achieve the goal, the technology we use is the introducing to Contiki-NG. So Contiki-NG is one of the popular open source operating system that I think that is being used right now in the field of IoT, and the important that we are going to use this technology because it is built in with the wireless communication protocols such as TIS and more. So it's a standard open source operating system. So so in this part we will use this Contiki-NG operating system to build our solution that we have TIS protocol available in them. So we're going to justify the protocol and make them used in our to serve our goal. So a little bit of introduction into TIS communication protocol. So TIS is like you can say a big part of 6TIS because it's like the main protocol that the node can communicate with each other. In this protocol, they use a wireless means, so there is different channels you can use, and then the time is divided into a small slot that is normally 10 milliseconds, if you can see here, and then that slot is being captured into a super frame or slot frame with 150, 200 depending on our configuration. So that is some characteristic of TIS. And with that, with what we have, we want to build this function in order to serve our goal. So the first one is that we want to eliminate 6TOP protocol in the 60, so that the node, they don't have to communicate back and forth in order to be able to transmit or send the data. And we also want to eliminate the routing protocol in the network so that you don't have to go in terms of tree pattern in order to communicate. So you can just do a direct communication with all the nodes in the network. So to do so, we eliminate the two protocol, and then we create a new type of message. We call it command message. In order, this command message is purpose to its purpose is to handle the data transmission from the root node to tell the node that in the network what time they can communicate and from which from what node to what node on different channel and stuff. So that is the configuration that we have to do, so the root node can send to the normal node. And the next function is we want each node to handle and listen to command message, because earlier in the 60 protocol there is the node only they don't handle the command message, they just listen and communicate with the 6 top protocol. And then the other one is node has to be able to handle the data message when another node send the message to themselves. So after the development of the function, we deployed, we do the experiment, and you can see the experiment here. This is the configuration we put. So in the first slot, the root node will send the enhanced beacon. It's like the opening of the network. So each node listen to the enhanced beacon and join the network. After that, root node send the command message 1 and 2 in the slot 1 and 2, so that all nodes listen to the command message and understand it, so they know when they send or when they have to receive. So it will reduce that they don't have to use we don't have to use 6 top protocol. That's where it's working out. So after this is the deployment setting, and then here is the proof of the development. When we already deploy to our device, we listen to the transmission through Wireshark, and then the result is the proof that the develop function is working, and our node can communicate with each other in a timely manner, and there is no the transmission delay is not there anymore. And after the deployment, we go on further to study the determinism of the network. So with that, we have to study the jitter and everything in order to understand the transmission delay in the node. And then we see the experiment. It's look like there is a pattern that in every 4 transmission, meaning every 4 superframe, there is one transmission that is happening to be very late, and it's happened at the same again and again. So with that, we can conclude that in every 2 seconds, it's possible that the root node is doing the update of the network time, so that every node is being synchronized. That's why we have a latency in the first transmission. So that is the end of my presentation. Thank you very much. And if there is any project that may be possible that we can work together in IoT, it's a very nice that we can collaborate with each other. Thank you very much.
Thank you for your presentation. And I would like to ask any question and or comments from audience.
Yes, please.
So any question or comments? So may I ask you one?
Yeah.
Yes,
I would be interested to know more about this network and your project. Please contact me if you can, or if you can give me your email. Also, Ramon, the presenter before, Mr. Ramon, if you could give me your email, I would be interested to communicate with you too. All right? Is this okay?
Thank you very much, sir. Yep, I will send you my email then.
Oh, yeah. Okay. Thank you very much.
Yep. Thank you, sir.
Any question or comments else? So may I ask you one, okay? So you proposed your new protocol. So are you trying to do some field trial with some company or vendor like Cambodian Telecom with a big scale?
No, sir. Actually, it seemed like a new protocol. It's just like an add-on on the TISH protocol that already exists. But and regarding the deployment, we only deploy in our own setting. We haven't reached out to the industry regarding the testing of our protocol yet. But it's working out very well in our environment.
Thank you. Something else? Okay, thank you very much for your presentation. So let me conclude this this session, and thank you for the 4 speakers for their presentation. I would like to close this session, last session, session number 7. So last one, we have I would like to invite the chairman of ASEAN IVO Steering Committee, Dr. YANO Hiroyuki, give us the closing address, please.
Hello everyone, can you hear me? Okay. 大丈夫ですか? 大丈夫. So it's time to closing everyone. And I'm Hiroyuki Yano, Vice President of NICT, a chairman of the ASEAN IVO Steering Committee. I'd like to thank you for all your participations and the presentations, the session chairs, your stewardship and arrangement at each location for long hours. It's almost 9 hours. Okay, so I really appreciate it. We had 26 interesting and impressive presentations and fruitful discussions in today's forum. Okay, sorry. I remember the proverb, need is the mother of the invention. I consider the social problem in the mother of the new ideas and new technologies and innovations. That is, innovation means the combination of the new technology, new, not only new, but conservative technologies. Okay. Even if research shares the same topics, each country and region has their own unique perspectives, issues, and methods. As NICT's President Tokuda said this morning, this is not a reach where these large or global scale problems can be solved by the effort for just one country, one individual, or one institution. I hope that today's presentation and discussions will be the inspiration for for joint projects. That is the aim of the ASEAN IVOs. And if there has anything you were unable to ask during today's post-presentation Q&As, or because of some disconnection or something like that, please use the talk room on the NICT website in our ASEAN IVO's website to further exchange and form project teams to make project proposals. Thank you for participating online in spite of the time differences. Now it's almost 8 p.m. in Japan. So hopefully next time we'll be able to gather under the same roof. Thank you so much. That's it.